Welcome to the Introduction to Web Development course. This course teaches you how to build responsive, interactive websites using HTML, CSS, and JavaScript. You'll also dive into version control with Git and advanced techniques and discover how tools like Microsoft Copilot can enhance your development workflow and collaboration. We will begin with the basics of HTML, focusing on its structure and essential elements, forming every web page's foundation. We'll explore how HTML interacts with CSS and JavaScript, discuss the importance of semantic HTML for accessibility, and guide you through creating your first simple web page. Next, we will explore the syntax and principles of CSS, emphasizing its role in creative responsive designs and enhancing web accessibility. We'll also dive into advanced CSS techniques for complex styling and layouts, equipping you to build web pages that adapt seamlessly across different devices. Then we will focus on JavaScript, the core language behind interactive web experiences. JavaScript allows developers to bring websites to life by manipulating page elements, responding to user actions, and managing data. From learning its syntax to mastering asynchronous programming and data handling, you'll see how essential JavaScript is for building dynamic, engaging web applications. Next, we will explore the power of version control using Git and GitHub. Version control helps developers manage and track changes in their code, ensuring nothing is lost and making collaboration seamless. As we dive into Git commands, integration with development tools, and advanced techniques, you'll see how this skill is essential for any developer aiming to work efficiently in a team setting. Finally, we will learn how Microsoft Copilot can be leveraged for web development projects, including HTML, CSS, and JavaScript. We will demonstrate how Copilot assists with coding and optimization, using it to complete a small web development project and showcasing the practical application of your newly acquired skills. Throughout this course, you will develop foundational skills in web development, focusing on the core technologies of HTML, CSS, and JavaScript. We're excited to guide you as you build the groundwork for your web development journey. Let's get started. Hi, I'm Dr. Sharon Jumper, and I'm excited to be your instructor for this course. My journey into front-end development began when I was a teenager, experimenting with code for fun. I would write simple scripts on computers in big box stores that turned their displays into silly little interactive experiences. After high school, I spent 4 years in the U.S. Army as a signals intelligence analyst, where I deepened my understanding of how computers facilitate global communication. These early experiences shaped my career and fueled my passion for learning. As a lifelong learner, I've adapted my skills to the rapidly changing landscape of technology, applying front-end development principles in my roles as a lawyer, professor, enterprise learning architect, cybersecurity consultant, and entrepreneur. Whether building prototypes or launching full-fledged platforms, the ability to create dynamic, user-friendly interfaces is invaluable in today's digital-first economy. Today, we will explore the core aspects of front-end development, creating engaging, responsive, and accessible web pages that captivate and communicate effectively with users, as well as applications that make their lives and businesses more productive. From designing visually appealing layouts to adding interactivity, you'll gain the skills to craft modern web experiences. Whether you're planning to enhance a personal project, scale a business, or simply learn a new skill, front-end development opens a world of opportunities. And with technologies like Microsoft Copilot assisting you, you'll find the development process smoother and more intuitive. I'm excited to guide you through this journey of learning and discovery. Let's get started.
The learning experience in this course is designed to give you a comprehensive understanding of key concepts through various learning methods. You'll be guided through interactive, engaging materials that help you build practical and theoretical knowledge. Whether you're interested in front-end, back-end, or full-stack development, this program has the tools to support your growth every step of the way. Throughout the course, you'll be introduced to core concepts and key ideas in videos. These videos are designed to help you understand definitions, processes, and essential steps clearly and concisely. You'll get to absorb foundational knowledge, setting the stage for deeper exploration as you move forward. And when you need step-by-step guidance, screencasts will provide you with a detailed practical view. These screencasts will show you exactly what's on the screen and how to work through specific coding tasks. The course also includes readings that reinforce the key ideas presented in the videos. These readings are more than just supplementary material, they're job aids. You can print them out and use them as a reference while working on assignments or activities, helping to apply what you've learned in real-world situations more easily. Small activities are included to help you check your understanding of key ideas. These activities provide quick, interactive opportunities to practice what you've just learned. After completing each activity, you can compare your work with a fully explained example and answer key. This ensures that you always know if your answer is correct. Practical experience doing tasks you would in a job within this field is essential, and that's where guided labs come in. These labs take you through the implementation of different concepts step by step. As you work, you'll receive feedback and helpful hints, ensuring you can get the help you need when you need it. It's the perfect opportunity to practice in a controlled environment while learning by doing. After completing the guided labs, you'll move on to independent projects, or you try it. This is where you'll put your skills to the test, applying what you've learned in the labs. You'll work through real-world problems, cementing your understanding of the course material. The course will culminate in a practical project leveraging Microsoft Copilot that you can use as a portfolio artifact when you begin your job search in this field. As you progress through the program, the portfolio pieces will become stronger and better representations of the authentic experience you've gained. They'll showcase your understanding of code and the ability to implement different concepts from the developer program. This course guides you step by step from understanding concepts through videos and readings to apply them in activities, screencasts, and labs. Each part of the course builds on the last, helping you gain knowledge and authentic experience. By the end, you'll have completed real projects that not only showcase your skills, but can also be included in your portfolio as you start your career. Everything you do here will prepare you for success as a developer. Let's get started.
Throughout this course, you'll complete several guided labs. These labs are meant to give you an opportunity to practice your newly learned skills in an environment where you can get help and feedback as you complete coding challenges. This video will describe how to complete the guided labs in this course. We will explore a guided lab together so that you'll know what to expect when you come to one later in the course. First, let's check the content leading up to a guided lab. This structured content ensures that you have exactly the skills you need to complete the task. In this instance, there is a practical application video that describes in detail how this concept is used in real-world situations. Following this practical application video, you can review a reading that explains the concept in detail so you can go through this content at your own pace. Next, you'll find a video that works through the guided lab itself. This video won't give you all the answers to the guided lab, but it will provide an overview of the upcoming questions and challenges. Lastly, we come to the guided lab itself. The guided lab is a simulated code environment where you can experiment with code and receive hints and feedback in a realistic coding situation. To start, I'll click Start. In this lab, step 1 is an introduction to if-else statements, so I'll click Begin. Below the simulated code environment, I can find the specific instructions for this lab. Declare the variable age as type int. Place your cursor into line 2, type your answer, and select Enter to check your work. Alright, I think I know this one. I'm going to type in INT and hit Enter. Great, I got that correct, and I got a bit of feedback about my correct answer. To move on, I click Continue. And these instructions say, prompt the user to enter their age, place your cursor into line 4, type your answer, and select Enter to check your work. This one is a little trickier. Let me try type your age. Got it. This feedback for my wrong answer points me in the right direction. Let's try that again. I'm going to erase what I had here and then enter your age. Perfect. I'll click Continue. Let's try one more. Convert the input to an integer using int.parse and store it in the age variable. Place your cursor into line 6, type your answer, and select Enter to check your work. I'm not totally sure here, so I'm going to click on Hint and get some help. And the hint says use console.readline, and then an open and close parentheses, display a message asking their user for their age. Great, that helps. I'm going to click Continue and type in console.readline. And I've got it. That's how you work through a guided lab. Some questions will require more complex code to complete, so make sure you're using the hint function when you need it and reviewing the feedback provided for your right and wrong answers. Have fun completing these coding challenges that put your new skills to work.
In today's rapidly evolving tech landscape, artificial intelligence plays a key role in making development more efficient and intelligent. That's where Microsoft Copilot comes in. Microsoft Copilot is a powerful AI-driven tool that can assist developers in writing, optimizing, and debugging code. In this course, you'll leverage Copilot as a thought partner and a code-generating assistant, helping you solve problems, generate code snippets, and enhance your projects. The goal is to provide you with hands-on experience using a tool that real-world developers use to improve their workflow. In the last module of this course, you'll engage in videos, screencasts, guided labs, and independent projects that integrate Copilot. These labs will take you through how to use specific prompts to generate code, optimize solutions, and solve problems. You'll be shown step-by-step how to leverage Copilot's capabilities to strategically approach the final project. During the guided labs, you'll get hands-on experience working with Copilot. These labs are structured to show you how to craft effective prompts and work with Copilot's code generation features. You'll use it to assist in writing code, refining your solutions, and debugging. This practice will prepare you for the independent work you'll do in the final project. After the videos, screencasts, or guided labs, you'll move on to independent activities where you'll take control. Here you'll use Copilot to assist with various aspects of the project. You'll be making strategic decisions, but Copilot will support you by generating code, suggesting optimizations, and helping you troubleshoot. This prepares you to work more independently while still having the power of AI to assist. The final project will combine everything you've learned in the course, and you'll have Copilot as a key tool in your development toolkit. You'll use Copilot to help you generate and refine code as you combine the concepts from earlier lessons. The project is a portfolio-ready artifact showcasing your coding skills and your ability to leverage AI in modern development workflows. To succeed in the final module, actively engage with the guided labs and practice using Microsoft Copilot effectively. The videos and prompts will take you through Copilot and equip you to apply it strategically and independently. By the end of the course, you'll be fully prepared to complete the final project and demonstrate your skills using traditional coding and AI-assisted workflows. Welcome to the course. In this video, we will discuss how you can make the most of each part of the course to set yourself up for success. Whether you watch the videos, complete activities, or work through hands-on labs, Each element has been designed to help you master the skills you need to become a confident and capable developer. The first step in every lesson is the videos. You'll be introduced to new concepts, definitions, and key ideas. Watch these carefully and take notes on the important points. The videos provide the foundational knowledge you'll need to build on, so don't skip them. They'll give you the context to understand everything that comes next. After each video, complete the readings. These readings reinforce the key ideas you've just learned and can serve as job aids. I recommend printing out the readings or saving them for quick reference. They'll be extremely helpful when completing activities, working on projects, or just needing a refresher. They're not just supplementary. They help you apply what you've learned to real-world tasks. Throughout the course, you'll find small but impactful activities. These quick exercises allow you to check your understanding of key ideas. Don't rush through them. Take the time to work through these activities thoughtfully. After each, compare answers with the answer key to check how well you understand the material. This is your chance to practice without pressure. At the end of each lesson, you'll encounter practice quizzes. These quizzes are a great way to ensure you fully grasp the concepts from the videos and the readings. Use these as a checkpoint to assess how well you retain the information. If you find yourself struggling, review the videos and readings again. The goal is to build confidence and solidify your understanding before moving forward. When you need to see the material in action, screencasts guide you. These videos show you exactly how to work through certain tasks step by step. If you ever feel stuck or unsure about applying a concept, watch the screencasts and follow along. This hands-on guidance is invaluable for understanding how the code works in real time and applying what you've learned. At the end of each module, there will be graded quizzes. These are an important part of your success as they allow you to demonstrate mastery of the material. These quizzes build on the practice quizzes, and they're a great way to ensure you're ready to move on to more advanced concepts. Treat these quizzes as milestones. Passing them means you're fully prepared for the next challenge. The guided labs are where you'll take the concepts from the lessons and apply them in a controlled, hands-on environment. These labs will take you step by step through tasks, including helpful feedback and hints. The more effort you put into the labs, the more you'll get out of them. It's all about learning by doing, so take your time and ensure you understand each step before moving on. After you've completed the guided labs, it's time to test your skills with independent projects or you-try-its. This is where you'll apply everything you've learned without step-by-step instructions. These projects are a great way to gauge how far you've come and to put your knowledge to the test. Don't worry if you feel challenged, that's part of the learning process. By completing these projects, you'll reinforce your skills and build confidence. Finally, at the end of the course, you'll complete a culminating hands-on project that you can use as a portfolio artifact. This project will showcase the skills you've gained throughout the course and give you something tangible to present to potential employers. As you progress through the program, these portfolio pieces will become stronger representations of your hands-on experience and understanding of key concepts. Success in this course comes down to using all the tools available. Watch the videos carefully, engage with the readings, complete the activities and quizzes thoughtfully, and take full advantage of the screencasts, labs, and projects. Each element of this course is designed to help you master the material step by step. By the end, you'll have a solid understanding of the concepts and real projects to prove your skills. Remember to persist, take your time, and you'll be ready for a successful career in development.
Are you ready to create something amazing? By the end of this project, you'll have your very own personal portfolio website, a place to showcase your skills, creativity, and all the hard work you've put into learning web development. Whether you're hoping to impress potential employers, build your online presence, or just create something you're proud of, this project is your chance to shine. And don't worry, you won't be doing this alone. Microsoft Copilot will be your sidekick, helping you write, enhance, and debug your code every step of the way. In this video, we will introduce the end-of-course project. By the end of this project, you'll have developed a fully functional website that showcases your skills, projects, and contact information. You'll use HTML, CSS, and JavaScript, and Microsoft Copilot will be your assistant along the way. Whether you're new to web development or have some experience, this project is designed to be approachable and help you build essential skills. Let's review the details. The goal of this project is to create a personal portfolio website, which will include the following sections. First, you will have the home page. This is where visitors will land and learn about you. Next comes the About Me section. This section will describe who you are, your background, and what you bring to the table. Then comes the Project Gallery. Here, you'll showcase your best work. Next up is the Skills list. This will highlight your technical and creative skills. The website development project will conclude with building a contact form. This form will allow others to contact you easily. Throughout the project, you'll be using Microsoft Copilot to help you with writing, enhancing, and debugging your HTML, CSS, and JavaScript code. Copilot will assist you in generating HTML for your site's structure, styling with CSS to make your website visually appealing and more responsive, adding JavaScript for interactivity, such as validating forms or adding dynamic content. You'll work incrementally through a series of activities, each aligned with the lessons we've provided in this course. This way, you'll learn by doing, with Copilot offering real-time suggestions and improvements. This project is broken down into 6 manageable milestones to ensure that you stay on track. The first milestone for this project is to set up your development environment by installing and configuring Microsoft Copilot in your IDE. The second milestone is to create the HTML structure for your website using Copilot to generate the necessary code. In the third milestone, you will use Copilot to create code that will style your portfolio using CSS, making sure it's responsive and visually appealing. In the fourth milestone, you will use Copilot to add interactivity with JavaScript, such as form validation and dynamic content displays. For the fifth milestone, you will integrate all components, HTML, CSS, and JavaScript, and test the site for functionality and usability. Finally, in milestone 6, you'll conduct a peer review to gather feedback and make final revisions. Don't worry if you're new to web development or Copilot. We'll guide you step by step through each activity, and Copilot will provide helpful suggestions along the way. Follow the detailed instructions in each activity. We also encourage you to ask questions, collaborate with peers, and explore new ideas as you progress through the project. In our next lesson, we'll start with milestone 1, where you will learn how to install and configure it in your chosen IDE so you can begin coding. This is a chance to tap into your creativity. Good luck, and let's get started. Welcome to HTML for Web Development. This foundational module not only introduces you to the core language of the web, but also sets the stage for advanced front-end techniques covered later in our program. You'll learn how HTML integrates with CSS and JavaScript to craft interactive, well-structured websites. By mastering semantic HTML, you'll enhance web accessibility and SEO, equipping yourself with crucial skills to build and optimize web pages effectively. We will begin by defining the basic structure and elements of HTML, which will set the foundation for all web development tasks. Next, we will explore how HTML serves as the backbone of the web, interacting seamlessly with CSS and JavaScript to create dynamic and responsive websites. Then, we will delve into the importance of semantic HTML and how it enhances web accessibility and search engine visibility, ensuring your content reaches a broader audience. Following that, we will guide you through creating your first HTML document, where you will apply your understanding of HTML tags and attributes to create a web page's structure. Finally, You will combine all the pieces from this module to construct a complete web page using HTML. By the end of this module, you'll master the essentials of HTML to create accessible and dynamic web pages. Equipped with a deep understanding of HTML's integration with CSS and JavaScript, you'll be ready to advance your front-end skills in upcoming modules. Let's examine HTML for web development and start building the web one line of code at a time. Every web page you visit, from news sites to online stores, is built using HTML. This fundamental language shapes the structure of content, making it readable and organized on the web. HTML is the first step in creating a successful online presence. In this video, we will explain the fundamental components of HTML, focusing on elements and tags. HTML, or Hypertext Markup Language, is the standard language used to create web pages. Think of HTML as the skeleton of your web page, giving it structure and organization. Every web page starts with a basic HTML document that includes tags to define its elements. Now, a tag is a special code enclosed in angle brackets used to mark the start and end of HTML elements and tell the browser how to display content. Tags come in pairs: an opening tag, like open bracket h1, close bracket, and a closing tag, like open bracket /h1, close bracket. Some elements use self-closing tags, like open bracket br / close bracket, which don't need a separate closing tag. An HTML element is made up of a start tag, content, and an end tag. Elements define the structure and content of a web page, such as headings, paragraphs, and sections. Let's explore some common HTML elements. The h1 element is used for headings. It includes a start tag, h1, content, the heading text, and the end tag, which is /h1. This makes the bold and large stand out. For example, GrooveEco's homepage uses h1 for the main title to make it clear and prominent. The p element is used for paragraphs. It includes a start tag of p, content, the paragraph text, and an end tag, which is /p. This groups sentences into readable blocks of text. The div element is used for creating divisions or sections on a web page. It includes a start tag, div, any content inside it, and an end tag, /div. This helps organize different parts of the content. An interesting fact is that some HTML elements don't require an end tag. These are called self-closing tags. Self-closing tags is a type of HTML tag that doesn't need an end tag. It is used for elements that do not contain any content. For example, the br / tag is used to insert a line break and doesn't need a separate closing tag. Now that we understand the different types of tags, let's see how they fit together to form the structure of an HTML document. The basic structure of an HTML document includes the doc-type HTML declaration and the main doc-type HTML head and body elements. Inside these, various elements and tags work together to form the content of the web page. Let's take a look at the basic structure of an HTML document. Understanding the basic structure of an HTML document is essential for creating web pages. Here is a simple template. The doc-type HTML declaration defines the document type as a version of HTML. It tells the browser that this is an HTML5 document. The HTML element is the root element of the page, containing all other elements. The head section contains the metadata, like the title, link to style sheets, or scripts. It doesn't display content on the page. The title element defines the title of the web page, shown in the Browser tab. The body element contains all the content that's displayed on the web page, such as text, images, and links. Knowing how to use HTML elements and tags is essential for building web pages. These basics are the foundation for all web content. Happy coding!
Imagine having the ability to control every detail of your website's elements, everything from how they appear to how they behave. By understanding HTML attributes, you'll gain this control, making your web pages more dynamic and interactive. In this video, we will describe how attributes provide additional information about HTML elements. HTML attributes let you fine-tune how elements behave and appear, adding functionality and interactivity to your website. Now that we understand what attributes are, let's explore how to properly structure them in your HTML code. Attributes are written as a name-value pair, such as name equals value, and placed inside the opening tag like this: tag name, space, attribute equals value. In this example, attribute is the name of the attribute you want to define. The value of the attribute provides specific information or behavior. With this basic syntax covered, let's explore some of the most common attributes you'll use to enhance your HTML elements. First is the class attribute, which you'll use to group multiple HTML elements together by assigning them the same class name. This lets you apply the same CSS styles to all elements with that class, making it easier to manage and style your website. For example, you can have two paragraph tags that have the same class attribute. Both elements would have the same styles applied to them. Next, let's examine the ID attribute. This attribute is used to give individual elements a unique identity on your page, allowing for specific styling or functionality. This identifier must be unique on a page, allowing you to apply specific styles or JavaScript functions to that one element only. Now let's explore the href attribute. Used in A tags, this attribute sets the destination URL for a hyperlink, guiding users to the right location with just a click. This attribute tells the browser where to go when the link is clicked, whether it's another page on your site or an external website. Lastly, the source attribute defines the file path for an image or script you want to include on your web page. It's used in tags like image for images and script for JavaScript files, telling the browser where to find the file. For example, in an image element, you can use source attributes to link to an image stored on a web server. The browser will get the image from the server and display it on the web page. Now that we've discussed some of the common attributes, let's explore how you can include them in your HTML elements. The syntax for including attributes in HTML tags is straightforward. An attribute is added with the opening tag and consists of the name and the value pair, separated by an equal sign and enclosed in quotes. Here's the general format: element, attribute equals, quote, value, end quote. Let's examine some of the examples of commonly used attributes. In this example, we create a div element with an ID attribute set to header. Within this div, the text, "this is the header," is placed, and finally the div tag is closed. The attribute class assigns one or more class names to an element, which can be used for styling or scripting. In this example in the HTML code, we have a paragraph element with the class attribute set to intro highlight. The text within this paragraph is "welcome to this website." The paragraph is then closed with a closing p tag. The style attribute allows you to apply CSS directly within an HTML tag, often used for quick, specific styling. While it's powerful for adding individual styles, it's generally better to keep your CSS in separate files to maintain cleaner code. In this example, you begin with a span tag, which is used for inline elements. We'll add a style attribute to it with the CSS properties color: red and font weight: bold. In this span, include the text important text. Finally, we close the span tag. The attribute href specifies the URL of the page the link will go to. In this HTML code, we create a hyperlink using the a tag. The href attribute is set to www.example.com, and the clickable text within the link is visit example. The tag is then closed. The attribute target specifies where to open the linked document. For example, here you would start with an a tag, which represents a hyperlink. Set the href attribute to www.example.com, then add a target attribute with the value _blank. This makes the link open in a new tab. Inside this tag, include the text open in a new tab. Finally, close the tag. The attribute source specifies the path to the image. In this HTML code, we have an image tag to display an image. The source attribute points to the image.jpg, and the alt attribute is set to a descriptive image, which serves as the alternate text for screen readers or if the image fails to load. This tag is self-closing. HTML attributes make your web page powerful and have a greater impact. They help you add more functionality and interactivity to your web page. In this video, we've walked through what attributes are, some of the most common ones, and how to use them in your tags. Now that you know how they work, you're ready to create some really dynamic and engaging web content.
Picture walking into a library where every book is sorted into sections like fiction, nonfiction, and reference. These sections are organized on shelves, making it easy for you to find the book you need. Similarly, an HTML document uses tags like HTML, head, and body to structure its content, much like how a library's organization helps you find books. In this video, we will describe the hierarchical structure of HTML documents and its importance in web development. HTML document structure is the basic layout of an HTML document, including doc type, head, and body sections. The 5 main tags that form this structure are doc type HTML, HTML, head, title, and body. Let's examine each of these types of tags. The doc type HTML tag defines the document type and version of HTML being used, much like a sign at the library entrance tells visitors what kind of library it is. It tells the browser to expect HTML5, the latest version. The HTML tag is the root element that wraps all other HTML content and signifies the beginning and end of an HTML document. It's like the walls of a library that contain everything inside. For instance, every web page, like WebWave's homepage, starts with the HTML tag. The head section holds important information about the web page that isn't shown directly on the screen, like the page's title. Think of it like the information desk at a library, helping organize everything behind the scenes. The head section helps browsers and search engines understand the page better. The title tag, which is inside the head section, sets the title of the page that appears in the browser tab. It's like the name of a library displayed on a sign outside. The body section contains all the visible content of the web page, like text, images, and videos. This is like the main area of a library where the books and resources are kept. For example, everything you see on a website is placed inside the body tag. Another way to make an HTML page more meaningful is by using semantic HTML. Semantic HTML uses special tags that describe what their content is about, making it easier for people and computers to understand the structure and purpose of the web page. This is like using clear labels on library shelves to help people find the books they want quickly. There are several common types of semantic HTML tags, each with a specific purpose. Let's look at some of them. The nav tag represents a section of navigation links similar to a directory or a map in a library that shows you where different sections are located. The main tag indicates the main content of the document, like the central area of the library where the main collection of books is found. It should contain the unique content of the page. The article tag is used for a self-contained piece of content, such as a news story or a blog post. It's like an individual book or magazine in a library. The section tag groups related content together, similar to a specific shelf or section in a library dedicated to a particular subject. The footer tag is used for the bottom part of the web page, which often contains information like copyright details or contact information. It's like the reference or help desk area of a library, providing additional resources. Now, let's look at how to build a more complex HTML structure. One common method is called nesting. Nesting places elements within other elements, creating a clear and organized structure in the HTML document. It's like putting books on specific shelves in a library, so everything is easy to find. Nesting is important for several reasons. First, it creates clear and organized documents or web pages by defining how different parts of the content are related. Secondly, nesting makes it easier to style specific parts of a web page. Third, proper nesting helps with accessibility for tools like screen readers. It helps the screen reader understand the content, making sure the site is easier for everyone to use. Just like organized shelves in a library, well-nested HTML elements keep everything in the right place. Understanding HTML structure, nesting, and semantic elements help you create organized and user-friendly websites. Mastering these basics makes your content clear and accessible. Happy coding! When you think of a website, it's like a building. HTML creates the framework, but web standards act like building codes, ensuring that the structure is safe, consistent, and accessible across all devices. Once the structure is set, CSS and JavaScript bring it to life with style and interactivity. In this video, we will describe how HTML functions as the structural foundation for web pages. Web standards are the rules and guidelines that help us build websites correctly. They ensure that the site's structure works across all devices, browsers, and for all users, just like building codes keep structures safe and functional in the real world. Let's explore a few key web standards. First, there is responsive design, which means creating websites that adjust to different screen sizes, from large desktops to small mobile phones. This is important because users access websites from a variety of devices, and a website needs to look and function properly on all of them. Next, we have accessibility, which ensures that a website can be used by everyone, including people with disabilities, so that no one is excluded from the site. Then, cross-browser compatibility ensures that a website performs consistently across different web browsers like Chrome, Firefox, or Safari. Cross-browser compatibility is a high priority for web content because users rely on different browsers, and the website needs to provide a consistent experience no matter what they use. Finally, performance optimization focuses on improving the speed and efficiency of a website, since faster websites offer a better user experience and result in more visitors. Now that we've seen how web standards ensure a strong and accessible structure, let's move on to CSS, which is responsible for the style and visual design of the website. CSS ensures that the structure looks good and adapts visually to different devices. CSS, or cascading style sheets, is a language used to control the visual presentation of a website. CSS allows you to style HTML elements, controlling things like layout, colors, fonts, and spacing. Let's review a few ways CSS can style elements. First, CSS controls the design of a web page, meaning it determines how elements like headers, footers, and sidebars are arranged. Layout plays a key role in how users navigate and interact with the content. Second, CSS controls the colors used on a website, including background colors, text colors, and link colors. Using the right colors can reinforce branding and make a website visually appealing. Third, CSS allows you to control the fonts used on a website, including font type, size, and style. Fonts directly affect readability and can help set the tone of the website. Fourth, CSS can control the spacing between elements, such as distance between paragraphs, images, and buttons. Proper spacing improves readability and gives the page a clean, organized look. CSS media queries apply different styles to a website depending on the size of the screen. This ensures the layout remains user-friendly on any device, making the website accessible on both mobile devices and desktops. While CSS ensures that the website is visually appealing and responsive, JavaScript adds functionality and interactivity. JavaScript allows the website to respond to user actions and dynamically update content, making the structure more engaging and interactive. JavaScript is a programming language used to make websites interactive and dynamic. It enables websites to respond to user actions, update content without reloading the page, and interact with users in real time. Now let's explore some of the ways JavaScript makes web content interactive. One way JavaScript brings interactivity to web content is form validation. This checks whether a form is filled out correctly before it's submitted, which helps users avoid mistakes and ensures that the data submitted through websites is accurate. JavaScript event listeners respond to user actions like clicks or keystrokes. This allows the website to react to the user in real time and provides a more engaging experience. JavaScript enables dynamic content updates, which allow parts of a web page to refresh without reloading the entire page. This provides a smoother user experience and makes the site feel more responsive. By combining CSS and JavaScript with the structured foundation of HTML, developers can create websites that are responsive, interactive, and visually appealing across all devices. Happy coding! Have you ever wondered how to make your web pages not only functional, but also visually engaging? When building a website, the challenge often lies in transforming a simple, bare-bones structure into something that truly stands out. Imagine you're building a house. The foundation and walls provide an essential structure, much like HTML does, for a web page. But it's the paint, the interior design, and the furniture, the elements that bring life and personality to the house, that are akin to CSS. Just as these decorative choices transform a basic structure into a welcoming home, CSS enhances HTML, turning a simple web page into an engaging and visually appealing experience. Just as accessories and style make an outfit stand out, CSS adds the visual appeal to the structure provided by HTML. In web development, HTML provides the structure, while CSS, cascading style sheets, adds the style, defining how web pages look and feel. Whether you're new to web development or just brushing up on your skills, this lesson will guide you through the essentials of styling HTML elements. In this video, we will explain how HTML interacts with CSS to define the presentation and layout of web pages. CSS stands for Cascading Style Sheets and is used to style HTML elements. It allows developers to change colors, fonts, layouts, and more. By applying CSS, you can transform a plain HTML document into a visually appealing web page. Let's examine some of the things that CSS can do for a website. Now, let's review a simple CSS example that styles a web page. First, we have the body selector. This selector targets the entire body of the web page. Within the curly braces, we define a rule: background -color, #, number FOFOFO. This sets the background color of the page to a light gray, using the hexadecimal color code #FOFOFO. Next, we move on to the H1 selector. This targets any heading level 1 on the page. The rule inside the braces is color: number 333, which sets the text color of the heading to a dark gray using the color code #333. In this example, the body of the web page is styled with a light background, and the heading has a contrasting dark text color, which helps to create a clean and readable design. Let's examine another CSS example, this time with styling paragraph text. Here we're using the P selector to target all paragraph elements, P, on the page. Inside the curly braces, we define a few properties to style the text. First, we set the font family to Arial, sans serif. This means that the paragraph text will use the Arial font if it's available. If Arial is not available, the browser will fall back to any generic sans serif font. Next, we set the font size to 16 pixels. ensuring that the text will appear at a reasonable size of 16 pixels. Finally, we apply font weight bold, which makes the paragraph text appear bold, giving it more emphasis. This simple CSS rule helps to control the appearance of the text, ensuring it's easy to read and stands out with bold styling. Here's another example of using Flexbox to lay out elements on the page. We will start with .container class selector, which targets any HTML element with a class name of container. Inside the curly braces, we first use display::flex. This activates Flexbox, a powerful layout model that allows items within the container to align and distribute space efficiently. Next, we apply justify content: space between. This property ensures that the items in the container are spaced evenly, with the first item aligned to the left, the last item aligned to the right, and any remaining space distributed between them. This simple Flexbox rule helps create responsive, flexible layouts where items are neatly spaced apart. To apply CSS to an HTML document, we have several methods: external, internal, and inline styles. Let's compare them. External style sheets are the most common method of applying CSS to an HTML document. You create a separate CSS file, link it to your HTML document, and define all your styles in one place. This is like having a universal wardrobe you can use for multiple web pages. You should write the styles in the styles.css file, then link the CSS file in the head section of the HTML document. We use the link tag, which is placed inside the head section of the HTML. The rel equals style sheet attribute tells the browser that this is a style sheet, meaning that it contains CSS that will style the web page. The href equals styles.css attribute specifies the location of the CSS file. This technique allows us to keep the styling separate from the HTML structure, making it easier to manage and maintain the design of the web page. These CSS styles are added directly within the style tag in the head section of your HTML file. This method is useful when you want to apply specific styles to a single page. Internal CSS files are useful for single-page websites or for overriding external styles. Let's review this example. The style tag is placed within the head section of the HTML file and allows us to write CSS rules directly on the page. In this example, we're targeting the H1 element, which means that any H1 heading on the page will be affected. Inside the curly braces, we define a rule: color, blue, semicolon. This changes the text colon of the H1 heading to blue. Using the style tag is useful for adding quick styles directly into the HTML file, but for larger projects, it's best to keep the CSS file in a separate style sheet. This method involves adding CSS styles directly to an HTML element using the style attribute. Now, let's explore how to add inline CSS directly to an HTML element. In this example, we have an H1 tag that displays the text, "Hello World." We're using the style attribute within the opening H1 tag to apply CSS directly to this element. The rule color, red, semicolon changes the text color to red. Inline CSS is useful for applying quick, specific styles to individual elements. However, it's generally better to use an external or internal style sheet for larger, more maintainable projects. As you've discovered, each method of applying CSS to HTML has its pros and cons, but for larger projects, external style sheets offer the most flexibility and ease of maintenance. Now, let's examine the CSS box model, which is crucial for mastering web layout design. It describes how HTML elements are structured in terms of space. The CSS box model is a fundamental concept that describes how elements are structured and spaced on a web page. It consists of 4 parts: content, padding, border, and margin. The content area is where the text and images appear. Padding is the space between the content and the border. It creates an internal buffer around the content. The border surrounds the padding, if any, and content. It can be styled with different colors, widths, and styles. Margin is the space outside the border, separating the element from the other elements. Let's apply a simple CSS rule that styles a box element on the page. We'll start with the .box class selector, which targets any element that has a class name of box. Inside the curly braces, we first set the width to 200 pixels, which defines the fixed width of the box as 200 pixels. Next, we use the padding property to add 10 pixels of space inside the box, creating space between the content and the border. The border property is set to 2 pixels solid #333, which means that the box will have a solid border that's 2 pixels thick and a dark gray color defined by the hexadecimal code #333. Lastly, we apply margin: 20 pixels, semicolon. This creates 20 pixels of space outside the box, separating it from other elements on the page. This combination of properties helps define the size, spacing, and border style of the box. Let's examine how StyleWave, a digital marketing company, can use CSS to improve their homepage. The HTML structure includes headings, paragraphs, and images. CSS is used to style these elements, changing colors, fonts, and layouts. An external style sheet ensures consistency across the site, while internal and inline styles make specific adjustments. The box model helps organize content, padding, borders, and margins to create a clean, well-spaced layout. This combination of HTML and CSS creates a visually appealing and user-friendly website. Understanding how HTML interacts with CSS is essential for defining the presentation and layout of web pages. In this video, we explored the basics of CSS styling, the methods of linking CSS to HTML, and the importance of the CSS box model. Now that you understand how HTML and CSS interact to create visually appealing web pages, try styling a simple HTML document using the techniques we've covered. Experiment with different colors, fonts, and layouts to discover how CSS can transform your design. Have you ever visited a website that just felt alive, responding to your every click and action? That's the magic of JavaScript. Imagine a static display window in a store. It looks good, but doesn't do anything when you interact with it. This is similar to how an HTML page feels without JavaScript. Just as adding movement and sound can transform that display window into something engaging, JavaScript brings static HTML pages to life, making the web come alive with functionality and interactivity. In this video, we will explain how HTML interacts with JavaScript to add functionality and interactivity to web pages. JavaScript can be integrated with HTML in two main ways. First, by embedding it directly within the HTML file, and second, by linking to an external JavaScript file. Each method has its benefits and serves different needs. First, let's explore how embedding JavaScript directly within HTML works, followed by the advantages of using external JavaScript files. To embed the JavaScript directly within HTML, use the script tag. Here, the JavaScript code inside the script tag writes JavaScript is working directly onto the web page. In this example, external JavaScript is written in a separate .js file and linked to the HTML document using the script tag. We include the script tag, which is used to load external JavaScript files. The source attribute points to script.js, allowing us to link a JavaScript file that will execute when the page loads. By including the script at the bottom of the body section, we ensure that HTML content is fully loaded before the JavaScript runs, which helps improve performance and prevents errors. This is a basic but essential technique for integrating JavaScript into a web page. Using external JavaScript is great when you want to reuse scripts across pages. Plus, keeping your JavaScript in a separate file helps keep your HTML clean and organized. Think of the DOM, or Document Object Model, as a blueprint for your web page. It lets JavaScript change things on the page whenever a user does something, like clicking a button. This structure allows JavaScript to interact with and modify HTML elements whenever a user interacts with the page. Now, let's see how JavaScript can use the DOM to change the content of these elements in real time. JavaScript allows you to modify various aspects of HTML elements, including content, styles, and attributes. First, let's look at how you can change the text of an HTML element by using the getElementById method. Then we'll explore how to modify other attributes and styles to customize the element further. To change the text in an HTML element, you can use a method called getElementById. In this example, JavaScript selects the H1 element by its ID and changes its text content from Hello World to Hello JavaScript. JavaScript can also be used to modify existing HTML elements, including content, attributes, and styles. To change the style of an HTML element, you can use the inner text or inner HTML properties. In this example, JavaScript changes the visible text of the paragraph from original text to modified text. Now, let's explore how JavaScript can respond to user actions, such as clicks and key presses, to make your web pages interactive and engaging through event handling. In web development, events are actions like clicks, key presses, or mouse movements that happen within the browser. Event handling in JavaScript means you can run specific code when something happens on your web page, like when a user clicks a button or presses a key. This makes your website more interactive. Next, let's explore how to set up event listeners to handle these actions effectively. JavaScript provides a way to listen for these events and then perform actions using event listeners. An event listener is a function that waits for a specific event to occur on an element and then executes a block of code when the event happens. Now, let's go step by step through the process of adding event listeners to HTML elements. First, we'll use the addEventListener method to set up the listener. Then, we'll create a function that runs when the event occurs. Here's a basic example showing how to add a click event listener to a button. When the button with ID equals click button is clicked, an alert box with the message button was clicked appears. Now, let's look at some practical examples of event handling in JavaScript. Event handlers define what happens when an event occurs. Here's an example of an event handler that results in displaying a message when a specific key is pressed. When the A key is pressed, a message is displayed in the paragraph with ID equals message. Users will see, you pressed the A key. Let's examine how Interact Pro, a smart home services company, can improve its website by using JavaScript with HTML. JavaScript adds both functionality and interactivity to web pages. Inline scripts manage simple tasks like displaying alert messages. Internal scripts handle more complex tasks, such as updating content dynamically. External scripts are ideal for reusable functions across multiple pages. The DOM is used to modify events in response to user actions, while event handling triggers these changes when users interact with the page. This combination creates a dynamic and engaging user experience. Understanding how HTML interacts with JavaScript is essential for adding functionality and interactivity to web pages. In this video, we explored basic JavaScript integration, DOM manipulation, and event handling. By mastering these concepts, you can create dynamic and responsive pages that effectively engage users. Happy coding! Building a website, every decision you make affects how easily users can navigate and understand your content. But it's not just about what users see, It's about how your code communicates with search engines and accessibility tools. Semantic HTML helps bridge that gap by giving meaning to your content, improving both usability and structure. In this video, we will define semantic HTML and its role in web development. Semantic HTML refers to the use of HTML tags that give meaning to the content they enclose. These tags make it easier for users and technologies to understand the structure and purpose of the web page. Unlike non-semantic HTML tags, which are used mainly for formatting, semantic tags provide information about the type of content they contain. This helps both developers and browsers understand the structure and purpose of the content, improving accessibility and SEO. Semantic tags like header, article, and footer give specific meaning to different parts of a web page. The header tag defines the introductory section of a web page or a specific section within a page. What makes this tag semantic is that it describes the purpose of the content inside it, telling both users and technologies that this is the header section. The article tag is used to define a self-contained piece of content that could stand alone, such as a blog post, news article, or forum entry. This tag is semantic because it explicitly tells browsers and search engines that the content is a complete, independent piece of information. The footer tag represents the footer section of a web page or section, which typically contains copyright information, links, or author details. It is a semantic tag because it communicates the role of the content as a footer section, allowing technologies to recognize that it is supplemental information. Now let's talk about why semantic HTML is important for web development. Semantic HTML plays a crucial role in enhancing readability, maintainability, and the overall structure of web pages. Semantic HTML makes your code more readable for anyone who reviews it, whether it's another developer, a search engine, or assistive technologies like screen readers. The clear structure provided by semantic tags helps everyone understand the content more easily. In addition, with semantic HTML, your code becomes more organized and easier to maintain. Instead of trying to remember what a div or span does, you can rely on meaningful tags that describe their content. This makes updating your site easier over time. Semantic HTML also has a significant impact on search engine optimization, SEO. By using meaningful tags, you help search engines better understand and index your content, improving your website's visibility and ranking. Finally, by using semantic HTML, you help search engines understand the structure of your web page, making it easier for them to index your content and rank it higher in the search results. This improves your website's SEO, or search engine optimization, making it more likely that users will find your page. Semantic HTML improves both the usability and the visibility of your website. By using semantic tags, you enhance readability, SEO, and accessibility, ensuring your content is well understood by both users and browser technology. Imagine entering a room where everything is thrown about with no order. Finding anything would be a nightmare. Now picture that same room, but organized meticulously with everything in its place and easy to find. That is what semantic HTML does for your web pages, turning a chaotic page into a well-structured one. Semantic HTML organizes your content and enhances accessibility, SEO, and users' experience by creating a well-structured and meaningful hierarchy for your web pages. In this video, we will describe how to effectively implement semantic HTML in a web project. Semantic HTML uses HTML tags to provide meaning to the content they enclose, much like how signposts guide travelers. These tags help users and search engines navigate and understand the structure and purpose of your web page with ease. This is crucial because it makes your web page easier to use and easier to read, and it helps rank better on search engines. Here's how to start structuring your web page using semantic tags. The header tag is used for the introductory content or navigational links. It's typically placed at the top of the page. The nav tag defines a set of navigation links. It's often placed inside the header, but can be used elsewhere depending on your page structure. The footer tag contains information about the page, such as copyright details or contact information, and is placed at the bottom of the page. These tags create a clear and logical structure for the top and bottom sections of the page. Now that we've established a strong foundation with your page's structure, it's time to explore how to effectively organize your content within that framework. The main tag wraps the main content of your page. Think of it as the central hub where your most important information lives, like the body of an article or the main feature on a news site. It excludes headers, footers, and navigation, ensuring that the focus remains on the core content your users are there to navigate. The section tag is used to group related content together within the main area. Each section can have its own heading and is a distinct part of the content. The article tag is used for self-contained content that could be independently distributed, like a blog post or a news article. With your main content organized within the main section, let's explore how to further structure this content using headings, which play a crucial role in both user experience and SEO. Use H1 to H6 tags within your header and section elements to define headings and subheadings. This not only provides structure, but also improves accessibility and SEO. The P tag is used to enclose paragraphs of text. Place it inside your article or section tag to clearly separate blocks of text. The image, IMG tag, is used for images, and it should always include an alt attribute to describe the image content for screen readers. The A tag defines hyperlinks and is often placed within the nav or article tags to provide navigation and additional resources. Sticking to best practices is key to making your web pages accessible and easy to maintain. Here are a few best practices to keep in mind. Make sure to pick the right semantic tag for the content you're showing. This not only improves the clarity of your code, but also helps search engines and assistive technologies understand the structure of your page. For instance, if you're displaying a block of text that represents an article, you should use the article tag instead of a generic div. Using these tags too much can clutter your HTML and make it harder to understand. Instead, opt for semantic tags that describe the content they contain. Write your HTML in a way that is easy to follow, with proper indentation and comments if necessary. This makes your code easier to maintain and debug. For example, instead of using multiple nested div elements to structure your page, use semantic tags like header, nav, main, and footer to keep your code clean and organized. Use semantic tags for structure and non-semantic tags for styling and grouping when necessary. For instance, a div tag could be used with a class for styling purposes, e.g. applying a background color, but the main structure should be created with semantic tags like article, header, and section. This maintains clarity while allowing flexibility for styling. Use CSS with semantic HTML to ensure your content is well designed while keeping it meaningful. For example, you should use HTML tags like article, header, and section to define the structure while CSS is used to style the content, making it visually appealing without altering the semantic structure. This ensures both readability and a polished appearance. Let's bring everything we've discussed into focus with a simple case study. Imagine you're creating a blog page that features an article with a heading, a section for related articles, and a sidebar with additional links. How can you use semantic HTML code to create a well-structured web page? Here's an example of how you can create a well-structured web page. Semantic tags clearly define each section. In the first section, we have a header that contains the main heading of the blog, and inside the main tag, there's an article with a subheading and a paragraph discussing semantic HTML. Here, we have an aside section that contains a list of related articles. This is useful for navigation or additional resources. In the last part, we have another aside for quick navigation links to the home, about, and contact pages, as well as a footer with copyright information. By breaking the code into multiple screens, the audience can focus on one part of the structure at a time, making it easier to understand. The result is an organized and accessible web page that is optimized for SEO and flexible to adapt to future changes and additions. At the top of the page is the header section, featuring the main title of the blog, My Blog, displayed prominently in large font. Below the header, the main content area begins with an article titled Understanding Semantic HTML, followed by a brief introduction discussing the importance of semantic HTML for creating accessible and well-structured web pages. There is an aside section called Related Articles, providing links to 2 additional resources, Why Semantic HTML Matters, and Best Practices in Web Development. Another aside section titled Quick Links helps users navigate the site with links to home, about, and contact. Finally, at the bottom of the page, the footer section displays a simple copyright message, Copyright 2024, My Blog. This layout exemplifies a clean, well-organized structure utilizing semantic HTML tags like header, main, aside, and footer to ensure both accessibility and clarity. Effectively implementing semantic HTML in a web project involves structuring the page with a clear hierarchy following best practices for tag usage and ensuring that the content is both semantically correct and visually appealing. By adopting these techniques, you can create web pages that are accessible, maintainable, and optimized for search engines. Have you ever wondered how some websites look so professional and well organized? It all starts with a solid HTML structure. In this video, we will guide you in creating a well-structured HTML document from scratch. EcoEssence, a company that creates eco-friendly skincare products, has asked us to create the foundation for their webpage, featuring their logo and an introductory video. We'll walk through the process step by step. Let's start by creating the HTML structure. Think of building your HTML document as laying the foundation for a house. Each tag, from doc type HTML to body, plays a crucial role in ensuring your structure is solid and functional. Let's break down these essential elements one by one. Let's start by reviewing what each of these tags do. Every HTML document starts with the doc type HTML declaration. This tells the browser that the document is written in HTML5, ensuring the page is displayed correctly. Next, we open the HTML tag. This tag wraps around all the content on your page, telling the browser that everything inside is part of the HTML document. Inside the HTML tag, we begin with the head section. The head contains the information about the page that isn't visible to users, but is essential for the browser and search engines. The first element we add in the head section is the title tag. This sets the page title, which appears in the Browser tab. We'll set it to EcoEssence for this page. We add a meta charset equals UTF-8 tag next. This tag ensures that the text on EcoEssence's page displays correctly across different languages and regions. Next, we include a meta tag, which is a description of the page. This helps search engines understand the purpose of the web page. For EcoEssence, we describe the company as offering natural, eco-friendly skincare products. Finally, in the head section, we link to an external style sheet using the link tag. This style sheet controls the appearance of the page, such as fonts and colors, to match the EcoEssence brand. Now that we've completed the head section, we can move on to creating visible content of the web page. We start with the body section. This is where all visible content for EcoEssence's web page will go, such as text, images, and videos. Below the heading, we'll add a paragraph using the P tag. This paragraph introduces EcoEssence and emphasizes their eco-friendly mission. Let's add the EcoEssence logo next using the image tag. The Alt attribute provides a description of the image, ensuring accessibility for users who can't see the image. Finally, we'll add a video using the video tag to showcase EcoEssence's story. The Controls attribute allows users to play or pause the video, and we add a fallback message for browsers that don't support the video. We now close the body and HTML tags to finish the basic structure of EcoEssence's web page. This structure sets the foundation for a clean and organized web page that can be built upon with more content and style. With these steps, we've created a solid foundation for EcoEssence's web page, which will give visitors an introductory video tour of EcoEssence and its products. By following these steps, we've laid the groundwork for a professional and well-structured web page for EcoEssence. This basic HTML structure not only organizes the content, but also ensures that the page is accessible, functional, and ready for further enhancements. With the foundation in place, you can now build upon it to create a polished, user-friendly website that effectively represents EcoEssence's eco-friendly mission.
Imagine you're building a website from scratch. What tools would you need to make it interactive, organized, and user-friendly? Forms, tables, and lists are the backbone of any well-structured website. They're not just random elements. They're the tools that allow you to gather information, present data clearly, and organize content in a way that's easy for users to navigate. In this video, we will explain how to create and implement forms, tables, and lists in an HTML document. Forms are the backbone of any interactive website. Whether you're signing up for a newsletter, placing an order, or leaving a comment, you're interacting with a form. In HTML, forms are created using the form tag, which serves as the container for all the elements that collect user input, and labels to help identify and describe the text fields. Let's explore how to create a form in your HTML document. The area between the opening form tag and the closing form tag acts as a container holding all the elements that will make up the form, like input fields, labels, and buttons. Think of it as a frame that organizes and manages how the form behaves when you interact with it. Well, you don't see anything on the web page just yet. These tags lay the foundation for building our form. With the form fields in place, we can add elements for users to enter data into the form. For this purpose, we'll use the input element. In this example, we have one input field with a text type. It will show the text enter your name in the field before the user fills anything in. We can add other fields to get more user information if we need it. Now that we've set up the form structure, let's add a way for users to submit the form. This is done by including a button element. Here we've added a button type equals submit with submit between the opening and closing tags. This button is what users will click when they're ready to send their information. The type equals submit ensures that when the user clicks the button, the form is submitted. The button triggers a function in JavaScript which can send the form data to a database or save it to a file. Without this button, the form wouldn't be functional. Now that we've covered forms and how they allow users to interact with your website, let's shift our focus to tables. Tables are essential for displaying structured data clearly, making it easier for users to compare and analyze information at a glance. Think of a table as a grid where data is organized into rows and columns, much like a spreadsheet. This format is ideal for displaying information that needs to be compared side by side, such as product features, pricing, or schedules. Let's start by exploring how to create a table in HTML. First, we use the table tag to create the table structure. Next, we'll define the headers for our table. Headers describe what each column represents. To do this, we'll use the th tag, which stands for table header. We're using 3 th tags for the headers: product, price, and quantity. Now that we've created our table headers, let's add the actual data. We'll start by adding tr elements, which stand for table rows. And then within the tr elements, we'll use td tags to actually add our data. We'll start by adding 3 td tags for apples, $2, and 10. We can easily add more rows to our table using additional tr tags. Each new TR tag creates a new row, and inside that row we'll place more TD tags to fill the cells with data. In this example, we have added a new row with data for bananas, $1.50, and 20. End the table with the closing tag /tr, and then /table. And there you have it. We built a complete table with headers and rows of data using the table, tr, th, and td tags. You can structure and display data in a clear and organized way. Next, let's explore organizing data using lists. Lists are ideal for displaying items in a specific order, like steps in a process, or for grouping items without any particular sequence, such as a collection of features. HTML provides two types of lists, unordered and ordered. An ordered list is also known as a numbered list. This is perfect when you need to present steps or items in a specific sequence. Think of a recipe where each step needs to be followed in order. On the other hand, an unordered list is also known as a bullet list, and it's great for when the order doesn't matter, like listing ingredients for that same recipe. Here's an example of an ordered list. Start with the ordered list tag, and then add the following list items wrapped by the list item tag. Preheat the oven to 350 degrees, mix the ingredients, pour the batter in a pan, bake for 30 minutes. It will display a recipe which lists a numbered series of steps in the proper order to cook something. Now here's an example of an unordered list. Starting with the unordered list tag UL, we've added flour, sugar, eggs, and butter as list items, wrapping them in the list item tag. This results in a bulleted list of ingredients needed for the recipe that could appear in any order. To create a nested list, start by creating your main list using either OL for ordered lists or UL for unordered lists. Then nest additional lists inside your main list items to create sublists. In this example, the fruits list has its own sublist, which groups related items together. Creating and implementing forms, tables, and lists in an HTML document involves using specific tags to structure and organize content. By understanding how to use these elements effectively, you can enhance the functionality and usability of your web projects.
Have you ever visited a website where the images and videos took forever to load, or worse, didn't load at all? In this video, we'll show you how to avoid these pitfalls by properly embedding media elements in your HTML documents. In this video, we will describe how to embed and manipulate media elements within an HTML document. First, let's look at how to embed an image. Images are a key component of any web page, and embedding them is straightforward using the img tag. The two most important attributes you use are src and alt. The src attribute is where you tell the browser where to find your image. This can be a relative path to an image in your project folder or an absolute URL to an image hosted online. The alt attribute is just as crucial. It provides alternative text for screen readers, ensuring that your content is accessible to users with visual impairments. It's also useful when the image fails to load, as the alt text will be displayed instead. Let's explore how to add an image to an HTML page using the img tag. The img tag doesn't need a closing tag and is used to embed images into a web page. We start with the src attribute, which stands for source. This points to the location of the image file. In our example, the image source is set to path to your image.jpg, which would be replaced by the actual file path to your image. Next, we have the alt attribute, short for alternative text. This provides a description of the image for users who can't see it, like those using screen readers or when the image fails to load. In this case, the alternative text reads description of the image, which should be replaced with a meaningful description of the image. Together, the src and alt attributes make the image accessible and functional for a wide range of users. Now that we've covered images, let's move on to another essential media element, videos. Videos can greatly enhance user engagement when embedded properly. The video tag is used to display video files on a web page. In this example, we start with the SRC attribute, which stands for source. This points to the location of the video file. Here it's set to path to your video.mp4, which would be replaced with the actual file path to your video. We also add the controls attribute. This enables playback controls like play, pause, volume adjustment, and full screen options, giving users the ability to control how they watch the video. The video tag is self-contained, meaning we can include everything we need within the tag itself to display and control video content. It's a good practice to provide multiple formats of your video using source elements within the video tag. This ensures compatibility across different browsers. Here's an example. We start with the opening video tag and include the controls attribute, which adds built-in controls like play, pause, and volume adjustment, allowing users to control their viewing experience. Inside the video tag, we use two source elements to provide different video formats. The first source has src equals video.mp4 attribute, which points to the MP4 version of the video. We also specify video/mp4 to tell the browser what format this file is in. Next, we add another source element with src equals video.webm, pointing to the WebM format of the video, and type video/webm to define the format. By including multiple formats, we ensure compatibility across different browsers. If one format isn't supported, the browser will try the next one. Finally, we add the fallback text, "Your browser does not support the video tag." This message will appear if the browser doesn't support the video element at all, ensuring a graceful fallback for users. Now, let's explore how to embed an audio file into a web page using the audio tag. We start with the opening audio tag, which includes the controls attribute. This adds built-in controls such as play, pause, volume adjustment, allowing users to interact with the audio. Inside the audio tag, we use two source elements to provide different audio formats. The first is src equals audio.mp3, which points to the MP3 version of the file, and the type equals audio/mpeg specifies that this is an MP3 format. Next, we include another source with source equals audio.ogg, pointing to the OGG format, and type equals audio/ogg to define it as an OGG file. By providing multiple formats, we ensure that audio can be played across different browsers. If one format isn't supported, the browser will automatically try the next. Finally, we add the fallback text, "Your browser does not support the audio tag." This text will appear if the browser doesn't support the audio element, ensuring the user is aware of the issue. When embedding media, it is important to follow best practices to ensure your content is accessible, responsive, and efficient. First, consider the file formats you use. For images, use formats like JPEG or PNG for standard images and SVG for scalable graphics. For videos, MP4 is widely supported, but providing additional formats like WebM can improve compatibility. Always use compressed and optimized files to improve page load times. It is important to remember that accessibility is another crucial factor. Ensure all images have meaningful alt text and provide transcripts or captions for audio and video content where possible. Lastly, design your media elements to be responsive. Use CSS to ensure that images and videos scale appropriately for different screen sizes, providing a seamless experience on mobile, tablet, and desktop devices. Embedding and manipulating media elements in an HTML document involves using specific tags to add images, videos, and audio content. By following best practices for file formats, accessibility, and responsive design, you can enhance the user experience and make your web content more interactive and engaging. Before we start adding content to an HTML document, we need to set up the basic structure. HTML documents have a very specific format that helps browsers understand how to display the content. Let's put together an HTML document in 6 parts, step by step. First, we need to add the declaration that specifies the HTML document type at the top of the file. Now, on line 4, add the attribute to set the character encoding for the document. Next, on line 5, add the title tag to define the title that will appear in the browser tag. Finally, on line 7, add the tag that wraps the visible content of the web page. Now that we have our most basic skeleton, let's start adding content to the body of the document. One of the most common tasks in HTML is adding text content. Let's add headings, paragraphs, and some basic elements to the body of our HTML document. On line 1, add the opening tag for the main heading. On line 2, add the opening tag for the subheading. On line 3, add the closing tag for the first paragraph. On line 5, add the opening tag for the first paragraph. On line 7, add the closing tag for the third heading. Now, click the button in the upper right corner to see how the code renders. Let's add lists. Lists are a great way to organize information, and HTML gives us 2 types of lists, unordered lists and ordered lists. Unordered lists use bullet points, while ordered lists use numbers. Inside these lists, each item is defined with the LI tag, which stands for list item. Add the opening tag for the first list item in the unordered list. Add the closing tag for the second list item in the unordered list. Add the opening tag for the third item in the unordered list. Now, add the opening tag for the first list item in the ordered list. Add the opening tag for the second list item in the ordered list. Add the opening tag for the third list item in the ordered list. Click on the button in the upper right corner to see how the code renders. Let's add a table. Tables in HTML are used to present data in a structured format. A table is defined by the table tag, and within it, rows are created using the tr tag. For headers, use the th tag, and for regular data cells, use the td tag. To make your tables more organized, you can divide them into sections using the thead tag, the tbody tag, and the tfoot tag. Always remember to use the scope attribute on headers for accessibility. Add the table caption using the appropriate HTML tag. Add the table headers with scope to improve accessibility. Add the table data cells for the first row. Add the table data cells for the second row. Now add the footer cell with td call span equals 3 to span all columns. Click on the button in the upper right corner to see how the code renders. You should now see a web page that includes properly formatted headings, paragraphs of text, a horizontal rule, and a line break. Each section is organized and easy to read. Let's add a form. Forms are the primary way websites collect information from users. Whether it's signing up for a newsletter or submitting a feedback form, forms play an important role in web interactions. In HTML, forms are created with the form tag, and they contain input fields like text boxes, radio buttons, check boxes, and submit buttons. It's also essential to use the label tag to associate a label with each input field for accessibility, helping screen readers interpret the form. Let's create a basic form that includes text input fields, radio buttons, and checkboxes. First, define the for attribute for the name label. Define the input type for the name field. Now, set the ID attribute for the name input field. And set the name attribute for the name input field. Now we need to define the for attribute for the email label. Define the input type for the email field. Define the ID attribute for the email input field. And set the name attribute for the email input field. Now we need to define the input type for a subscription radio button. Set the name attribute for the first subscription plan input. Define the input type for the newsletter checkbox. Set the name attribute for the second subscription plan. Now we set the input type for the newsletter checkbox. And define the input type for the submit button. We've created a functioning form that allows users to enter their name and email, select a subscription plan, and opt into a newsletter. This form will also have a submit button that can send the data when clicked. Click on the button in the upper right corner to see how the code renders. Now, let's embed some media. In modern web, Multimedia elements like images, videos, and audio files are everywhere. HTML provides special tags for embedding these media types. The img tag is used to display images, and it's important to include the alt attribute to describe the image for accessibility. To embed videos, we use the video tag with controls for playback functionality. For audio files, we use the audio tag, also with controls to allow user interaction. First, let's insert the tag to define a source of an image. Now add the source attribute to specify the source of the image. Add the alt attribute to describe the image for accessibility. Add the controls attribute to the video tag to enable playback controls. Add the source attribute to specify the source of the video file. Add the type attribute to specify the video format. Now add the source attribute to specify the source of the audio file. Add the type attribute to specify the audio format. Now we click the button at the top right to run the code and see how it renders. As you can see, you've got an image, you've got a video, and you've got an audio. Great job on completing this guided lab.
Imagine your website is like a blank canvas and HTML is the basic sketch. CSS is the vibrant paint that brings your sketch to life, adding colors, textures, and depth. Just as an artist carefully chooses brushes and colors, CSS lets you decide how every element of your web page will appear, from the fonts to the layout. In this video, we will explain the basic syntax of CSS, including how to write CSS rules with selectors, properties, and values. CSS stands for Cascading Style Sheets, and CSS syntax consists of rules written in specific format to apply styles to HTML elements. Understanding the basic syntax of CSS is the foundation for controlling the appearance of HTML elements. Let's break down the structure of a CSS rule. A CSS rule consists of three main parts: the selector, the property, and the value. The selector identifies the HTML element you want to style. The property defines what aspect of the element's appearance you want to change, such as color, font size, or margin. Finally, the value specifies the setting you want to apply to that property. Let's examine a few examples, starting with the different types of selectors. In CSS, curly brackets are used to define the block of styles that will be applied to the selected HTML elements. After specifying a selector, the styles for that selector are written inside the curly brackets. Each style rule inside the brackets consists of a property and a value. Imagine you're designing a blog page and you want all your paragraph text to be blue to match the brand colors. You use the CSS rule P, open bracket, color, blue, semicolon, close bracket. Here, the element is P, which stands for paragraph. This allows you to quickly ensure all your paragraphs match this design choice across the entire site. In CSS, there are different ways to target and style elements on a web page, depending on how they're marked up in HTML. Two of the most common methods are using class selectors and ID selectors. First, a class selector targets all elements that have a specific class attribute. This allows you to apply the same style to multiple elements across the web page. Class selectors begin with a period, followed by the class name. For example, period class name would target any element with the class name. Next, we have ID selectors, which target a single element with a specific ID attribute. Unlike class selectors, which can be used on multiple elements, an ID should be unique to one element on the page. ID selectors start with a hash, or number symbol, followed by the ID name. For example, hash ID name targets the element with the ID name. Properties and values define the style of the targeted elements. Let's look at some examples. In CSS, a property is an aspect of the element you want to style. Properties define what part of an element's appearance or layout you are changing. Common properties include color, font size, background color, and margin. Each property must be followed by a colon, and then a value that defines the desired style.
For instance, setting font size 16 pixels makes the text 16 pixels tall. It's important to always end the rule with a semicolon, as this separates it from other rules. Along with properties, CSS uses values to specify exactly how you want that property to behave. A value is assigned to a property to define its appearance. For instance, in the color example, the value is blue. The value can be a specific color, size, padding, height, width, border, background color, or any other parameter that makes sense for the property. You can apply multiple properties to the same element within a single CSS rule. Here's how it looks in practice. In this example, the H1 selector targets all H1 elements. The properties within the curly braces include color, red, font size, 24 pixels, and margin bottom, 10 pixels, This rule changes the text color to red, sets the font size to 24 pixels, and adds a 10 pixel margin below each H1 element. Now that we've covered the basics, let's explore how these CSS techniques come to life on a real website. Imagine you're a web developer at Codecrafters, and you're tasked with giving their homepage a fresh, modern look using CSS. They want all headings to be blue, the introduction text to be larger, and the header background to be green. Here's how they could write their CSS rules. These rules apply the desired styles, making the homepage visually appealing and consistent. In this example, we're demonstrating how CSS can be used to style different elements on a web page using various types of selectors: element selectors, class selectors, and ID selectors. First, we have an element selector. This targets all H1 and H2 elements on the page, applying the same style to both. The property here is color, and the value is blue, meaning that all text inside H1 and H2 elements will appear blue. Element selectors are great for applying consistent styles to specific HTML tags across your entire web page. Next, we have a class selector. Class selectors target elements that have a specific class attribute. In this case, the class is named intro. Any element with the class equals intro in HTML will receive the styling defined here. The font size property is set to 20 pixels, so any text inside an element with the class intro will appear larger. The class selector is especially useful when you want to apply the same style to multiple elements but don't want to rely on tag names alone. Finally, we have the ID selector. ID selectors target a single unique element with a specific ID attribute. In this example, the selector #header targets the element with the ID equals header, and it applies a background color of green. ID selectors are used when you want to style one unique element on the page, such as a header or a main content area. In summary, this CSS example shows how you can style elements using 3 different types of selectors: element selectors to style specific HTML tags, class selectors to apply styles to multiple elements within the same class, and ID selectors to target a unique element by its ID. By combining these, you can control the design and layout of your web page in a flexible and efficient way. In this video, we explored how CSS can be used to control the visual element of your web page. This allows you to start experimenting with web designs and turning your creative ideas into reality through code. By understanding these fundamentals, you can start styling your web pages to create more engaging and visually appealing content. Effective web design starts with learning how to style your content. From adding unique styles to individual elements to creating consistent designs across entire websites. Understanding how to apply CSS will give you the flexibility and control to craft professional, well-organized web pages. In this video, we will describe the various methods of applying CSS to HTML documents, including inline, internal, and external styles. Inline CSS is a method where styles are directly embedded into an HTML document using the style attribute.
This is handy when you want to give a unique appearance to a specific element without changing others. You can simply add the style inside the element's opening tag. Now let's learn how we can extend styling to an entire document using internal CSS. Now that we understand how inline CSS works, let's explore it in action with an example. Here's how you can change the color of a paragraph to red using inline CSS. The style attribute adds CSS directly to an HTML element, turning that paragraph text red. Internal CSS styles are added directly within the style tag in the head section of the HTML file. This process allows you to apply styles to an entire HTML document, making it useful when you want consistent styling across a single page. You define these styles within a style tag located in the head section of your HTML. This method ensures that all elements on the page can share the same styles. But what if you need to apply consistent styling across multiple pages? In that case, external CSS is your go-to solution. The style tag placed in the head section of your HTML lets you define CSS rules that apply to the whole document. This method centralizes your styles in one location, making it easier to manage them. However, for larger projects with multiple pages, external CSS might be a more scalable solution. Now let's examine how internal CSS is implemented. Here's an example where all paragraph text in the document is styled to appear in blue. Using external CSS comes with some great perks, especially for bigger projects. It allows you to reuse the same styles across multiple HTML documents, making your site easier to update and maintain. You do this with the link tag, making it easier to manage your site's design. This is done using the link tag within the head section. By linking an external style sheet, you simplify the process of managing styles for larger projects. Let's explore an example of how external CSS works. By using the link tag, you can connect your HTML document to an external style sheet like styles.css, ensuring consistent styling across multiple pages. Using external CSS has significant advantages, particularly for larger projects. It enables you to reuse styles across multiple HTML documents, ensuring consistency and making it easier to maintain and update your website's appearance. Any changes made to the external CSS file will automatically apply to all linked pages, streamlining the process of managing your site's design. Now, let's explore how code crafters can put these CSS methods to work on their website. They need unique styles for certain elements, consistent styling across entire documents, and a shared style sheet to keep everything uniform across multiple pages. Here's how they could achieve this. They could use inline CSS for unique styles, such as this code, which would make the text of their welcome message, "Welcome to Code Crafters," blue. They could use internal CSS for document-specific styles, such as a 20-point font size. In this example, the CSS rule says that any HTML element with the class intro will have a font size of 20 pixels. The class selector in CSS is defined by using a dot followed by the class name, in this case, intro. So when we apply the intro class to an HTML element like a paragraph or a heading, the text inside that element will appear with a font size of 20 pixels. They could also use an external CSS style sheet for styles that are shared across many documents. The link tag is used here to connect the HTML file with an external CSS file. The rel attribute specifies the relationship between HTML document and the linked resource. In this case, rel equals style sheet tells the browser that this link points to a CSS style sheet. Next, we have the href attribute, which provides the path to the CSS file. In this example, it's pointing to a file called styles.css. This external file contains all CSS rules for styling our web page. By linking to it, we keep our HTML clean and separate from the presentation layer, which is managed by the CSS file. For example, the styles.css file might contain rules that set fonts, colors, layout, and more, ensuring consistent design across multiple pages of a website.
The advantage of this approach is that you can apply the same styles to different HTML files by linking them to the same style sheet, making it easier to update your design across your entire website with just one change. So using the link tag in the head section is a common and efficient way to apply CSS to an HTML document. Today we explored 3 key methods of applying CSS to HTML documents: inline, internal, and external styles. Understanding each method allows you to choose the best approach for your projects and ensures that your styles are well organized and maintainable. Have you ever wondered how websites achieve perfectly spaced and aligned elements? The secret lies in understanding the CSS box model, which controls the layout and spacing of every element on a web page. From the content area to the margins, the box model gives you the power to manage how elements appear and interact with each other. In this video, we will explain the CSS box model and how it affects the layout of elements on a web page. The CSS box model consists of 4 components: content, padding, border, and margin. Each component affects the overall size and spacing of an element. Let's break down each of the 4 components and the role that they play in web page development. First, the content box is where your text, images, or other media reside. The size of the content box is determined by the width and height properties of the element. Next, the negative space surrounding the content box is called the padding. This creates space inside an element, such as a button on a web page. In this example, the padding between the content and the border controls how much space there is between the button text and the button border. If you increase the padding, the area around the content expands without affecting the size of the border or margin. The button appears larger with more space around the text. This can make the button easier to click or give it a more balanced appearance. Another property we can adjust is an element's border. This wraps around the padding and the content. It's the edge of the element and can be styled in various ways: thickness, color, and type. Adjusting the border size changes the visual boundary of the element. Adding a thick border to the same button creates a more defined edge, making it stand out against the background. However, this also increases the button's overall size. Finally, the margin sits outside the border. It controls the space between this element and its neighbors. Increasing the margin pushes the other elements further away, while decreasing it brings them closer. This can be useful for ensuring that elements aren't too close to each other and that the layout feels organized. Each of these adjustments can dramatically change the visual presentation and spacing of your elements, giving you control over how your page appears and functions. However, a common challenge when working with the box model is that adding padding and borders increases the size of the element, which can make layout calculations tricky. This is where the box sizing property comes in. There are 2 common methods of box sizing. First, let's examine the content box method. This is your default behavior. The width and height you set for an element only apply to the content box. Any padding or border is added outside this box, increasing the overall size of the element. Alternatively, the border box method changes the behavior so that the width and height include padding and border. The content box is then automatically adjusted to fit within the specified dimensions. This makes layouts more predictable and easier to manage because you don't have to worry about adding extra space when you increase padding or borders. In this video, we explored the CSS box model, its components, and how adjusting padding, borders, and margins can change the layout of elements on a web page. We also introduced the box sizing property for more predictable layouts. Applying these concepts will help you better control the size, spacing, and visual balance of the elements you add to your websites, allowing you to create well-structured and visually appealing web designs.
Imagine visiting a website on your phone only to find yourself zooming in and out, scrolling sideways, and struggling to read the content. Frustrating, right? This frustration stems from a lack of responsive design. And in this video, we'll uncover the core principles that prevent these issues. Responsive web design ensures that websites work seamlessly across different devices and screen sizes. In this video, we will identify the core principles of responsive web design. Responsive web design is a web development approach that ensures websites work well on various devices and screen sizes. It achieves this by using flexible layouts, images, and CSS media queries, which together allow a website to adapt smoothly, whether it's viewed on a smartphone, tablet, or desktop. Responsive web design is a crucial aspect of modern web development. It ensures that your website looks great and functions well, whether it's viewed on a large desktop monitor, a tablet, or a small smartphone screen. But how do developers achieve this? Let's get into the fundamentals. At its core, responsive design is about flexibility. Instead of creating separate designs for every possible device, we build one design that adapts. This is achieved through three key elements. First, fluid layouts that adjust to different screen sizes. Next, flexible images that resize within their containers. Finally, CSS media queries that tailor the design to specific device characteristics. Together, these elements provide an optimal viewing experience, easy reading and navigation with minimal resizing, panning, and scrolling across a wide range of devices. One effective strategy in responsive design is the mobile-first approach. As the name suggests, this strategy starts by designing for the smallest screen size, typically a smartphone. From there, the design is progressively enhanced for larger screens like tablets and desktops. Why mobile first? First, it forces us to prioritize content and functionality, ensuring that the most essential elements are front and center. Next, as we move to larger screens, we can add more features and content, enriching the experience without sacrificing performance. This step-by-step enhancement ensures a seamless experience across all devices. Now let's talk about fluid grids, a key component of responsible design. Let's compare fixed and fluid grids. Fixed grids use a set number of pixels, making them rigid and less adaptable. In contrast, fluid grids are based on percentages, allowing the layout to expand or contract smoothly as the screen size changes. This flexibility is crucial for responsive design, much like a rubber band. But grids alone aren't enough to ensure a responsive design. Images also need to adapt. That's where flexible images come into play. Alongside fluid grids, flexible images are crucial to responsive design. These images automatically resize within their containing elements, preventing them from breaking the layout or overflowing their containers. This adaptability is key to maintaining a visually appealing and functional design, no matter the device being used. Together, fluid grids and flexible images ensure that your website adapts gracefully to different screen sizes, from large desktop monitors to compact smartphones. But these are just part of the equation. Let's explore how CSS media queries further refine this adaptability. Let's consider a case study involving DesignFlex, a digital design agency. How might they use responsive web design to improve their website? In this video, we've identified the core principles of responsive web design and explored the benefits of applying a mobile-first approach and using fluid grids and flexible images. Each of these principles plays a crucial role in creating adaptable and user-friendly websites.
Have you ever tried to read an article on your phone, but the text was too small and the images were out of place? If you're like most people, you might give up and abandon the article, move on to something easier to read. When designing websites, how do you ensure that this doesn't happen to your visitors? This is where media queries come in. They're a key CSS tool that ensures websites are well designed and functional, no matter what device you're using. In this video, we will try to explain the function and the use of media queries in responsive design. Media queries are CSS techniques that apply styles to a web page based on the characteristics of the device, such as screen width, height, and orientation. Media queries are significant because they enable responsive design, which means websites are usable and visually appealing on any device. Websites respond to the device on which they're being displayed. Let's start by examining the syntax of media queries in CSS. First, the @media rule targets devices with specific features. This example will apply styles when the screen width of the device on which the website is being used is 768 pixels or less. Similarly, you can use a media query to determine the minimum size a screen must be to apply a given style. In this example, when the screen size is at least 768 pixels, the class wide view will be applied to any element that uses it. The reference to max width or min width is called a breakpoint. Breakpoints are the conditions under which your web design adapts to different screen sizes. Think of breakpoints as thresholds where you introduce changes to the layout, font sizes, or visibility of elements to maintain usability across devices. Common breakpoints include 320 pixels by 480 pixels for mobile devices, 41 pixels to 768 pixels for tablets, and 769 pixels and above for desktops and larger screens. You can apply different styles to optimize the user experience at each breakpoint. By strategically setting breakpoints, you can ensure your website is not just accessible, but also visually appealing on any device. Let's review a couple of practical examples. Here, a media query is used to adjust the font size on smaller screens. If the screen or browser window is 480 pixels wide or smaller, the default font size for elements in the body of the page will be set to 14 pixels. We can use media queries to hide unnecessary elements on smaller screens. Sometimes certain elements are better suited for larger screens. In this example, elements with the class desktop only will be hidden on screens 768 pixels wide or smaller. In this video, we explain the function and use of media queries in responsive design. We covered the syntax of media queries, the concept of breakpoints, and provided practical examples of how to use media queries to adjust font sizes, layouts, and element visibility. Mastering media queries will help you create responsive websites that offer a great user experience on any device. Creating layouts that adapt to any screen size is essential for modern web design, and CSS offers powerful tools to achieve this flexibility. Fluxbox and CSS Grid are two of the most effective layout models for building responsive designs to ensure your layouts scale perfectly across devices. In this video, we will summarize techniques for creating flexible layouts using CSS. Let's start with CSS Fluxbox, which allows you to easily align and adjust elements within a container. Fluxbox is perfect for handling layouts in one dimension, either as a row or a column. It simplifies the process of aligning items along a single axis and allows you to create layouts that adapt to different screen sizes. CSS Fluxbox lets you control the alignment, spacing, and order of elements within a container, making it easy to adjust a row of navigation links or a product listing based on screen width. You can also change the visual order of elements easily without altering the underlying HTML. CSS Fluxbox also allows for automatic item distribution, which enables automatic adjustments to item sizes, filling up available space or shrinking as needed. Once you've decided to use the Fluxbox layout model, you can use properties to align items horizontally and vertically. Now let's discuss CSS Grid, an ideal flexible layout tool option if your project requires a more structured two-dimensional approach for more complex layouts. CSS Grid allows you to design your layout by defining rows and columns, giving you precise control over how your content is displayed. CSS Grid makes it easier to create responsive layouts with media queries and fractional units, ensuring designs adapt smoothly to various screen sizes. A particular benefit for complicated projects is that you can rearrange this layout visually without changing the HTML structure. This makes it ideal for maintaining clean, semantic HTML. CSS Flexbox is used for arranging items in a single line or column, while CSS Grid can arrange items across both rows and columns, offering more layout flexibility. In addition to Flexbox and Grid, responsive units are another tool you can use to ensure your designs scale across devices. These are the building blocks that make your layouts truly flexible and adaptable. Responsive units rely on percentage values to create fluid layouts that adapt to the width of the parent container. For instance, setting an image to 50 VW or view width, or 50% of the viewport width would make it fill half the browser window regardless of the screen size. Here are some common responsive units. VW stands for viewport width. It is a unit based on the width of the browser window. VH stands for viewport height. It's based on the height of the browser window. Let's examine how VW and VH are used. One VW represents 1% of the viewport's width. For example, if the browser window is 1,000 pixels wide, then 1 VW equals 10 pixels. 1 VH represents 1% of the viewport's height. For example, if the browser window is 800 pixels high, then 1 VH equals 8 pixels. Since VW and VH units are relative to the size of the viewport, they allow elements to adjust dynamically based on the device's screen size. This makes it easy to build responsive designs without relying on fixed pixel values. For example, if we set an image's width to 50 VW, this ensures that the image will always take up 50% of the viewport's width, regardless of the screen size. Using these units ensures that elements maintain their proportions across various devices and screen sizes, from mobile phones to desktop monitors. This eliminates the need for complex media queries in many cases. For example, a hero section with a height of 100 VH will always cover the full height of the browser window, regardless of the device. You can use VW and VH units to size text, padding, or margins, ensuring that your typography and spacing scale in proportion to the viewport size. For example, setting the font size of a heading to 5 VW makes the text scale with the width of the browser window, so it remains legible on larger screens and doesn't become too small on smaller ones. So how do you determine if either or both of these options will fit your project? Use Flexbox for simpler linear and flexible layouts, where you mostly need alignment and spacing along one axis. Use Grid for more structured two-dimensional layouts that require precise control over rows and columns. In some cases, you may even combine the two, using Flexbox for more simpler layouts like navigation bars within a larger, more structured grid-based layout. By combining Flexbox, CSS Grid, and responsive units, you can build layouts that are not only well-designed, but also incredibly flexible and responsive. Whether you're designing a simple navigation bar or a complex multi-column layout, these tools will help you create designs that adapt seamlessly to any screen size. In this video, we summarize techniques for creating flexible layouts using CSS Flexbox and Grid layout models, and discuss the use of responsive units like percentages, viewport width, and viewport height. Understanding these techniques will help you create adaptable and responsive web designs that adjust the design for any device.
Web accessibility ensures everyone, regardless of ability, can explore the web with ease. For web developers, understanding and implementing accessibility features is not just about following rules. It's about creating an inclusive environment where every user can interact with the web seamlessly. In this video, we will define key web accessibility features and explain their significance. Let's start with an overview of web accessibility. Web accessibility is the practice of designing and developing websites so that people with disabilities can perceive, understand, navigate, and interact with them effectively. For instance, ensuring text alternatives for images allows screen readers to convey visual content to users who may experience difficulties learning from visual elements. Web accessibility is important because first, it enables people with visual, auditory, motor, and cognitive challenges to use the web more easily. It also supports inclusivity. In fact, it can improve the overall user experience for all visitors.
Now let's explore why legal requirements and ethical responsibilities are integral to web accessibility. Beyond just good practice, these rules ensure that digital spaces are inclusive and accessible to everyone, which is both a legal mandate and necessary to create an inclusive society. Many countries have established laws and regulations that require web accessibility. In the United States, the Americans with Disabilities Act, ADA, mandates that websites must be accessible to everyone. Similarly, in the European Union, the European Accessibility Act requires that digital products and services meet accessibility standards to ensure they are usable by all individuals, including those with disabilities. These laws are designed to promote equal access to the web for all. Businesses and organizations must ensure their websites comply with accessibility standards to avoid legal penalties and lawsuits. Ensuring web accessibility is not just a legal requirement, it's also an ethical responsibility. First, it guarantees that everyone, regardless of ability, has equal access to information and services. Second, it promotes fairness and inclusivity in the digital world. Next, let's discuss Web Content Accessibility Guidelines, often called WCAG or WCAG. These are the gold standards for ensuring that web content is accessible to all users. These guidelines offer a clear framework for developers to follow, ensuring that all users can interact with web content regardless of their abilities. Let's examine 4 critical areas of accessibility covered in WCAG. First, perceivability for all users. Perceivability ensures that all users can access and process the content presented on the website. This principle focuses on making all elements of the web page, text, images, videos, and other media, available to everyone through multiple senses. For example, visual information should also be available as auditory content, and auditory content should be accompanied by visual alternatives such as captions. Techniques like providing text alternatives for images, ensuring captions for videos, and offering a logical structure for content are critical in making the web perceivable to all users. Another important consideration is operability through various input methods. Operability ensures that users can navigate and interact with a website regardless of how they operate their devices. Whether they use a keyboard, a mouse, voice commands, or other assistive technologies, the site must remain fully functional. This area of web accessibility addresses issues such as providing keyboard shortcuts, ensuring that interactive elements like forms and buttons are easy to use, and avoiding traps like content that requires specific input methods, like only using a mouse to interact. Next, the understandability of content is key to ensuring that users can comprehend the information presented. This means that both the content and the user interface must be presented in ways that are clear and intuitive. The language used should be simple, avoiding overly complex jargon where necessary, and clear instructions should be provided where needed. For example, error messages should be easy to understand with suggestions on how to correct mistakes. Consistency in navigation and functionality are also crucial to help users predict how the websites will behave, making it easier to use. Finally, robustness across different technologies and platforms ensures that websites function well across different technologies, including different browsers, operating systems, and assistive devices such as screen readers. Websites should also be designed using standardized code so that they are future-proof and can adapt to changing technology. This principle ensures that as technology evolves, the content remains accessible, and users with different types of software and hardware can still experience the website fully. Let's explore some key accessibility features, starting with keyboard navigation. First, ensure that all interactive elements on a website can be accessed and operated using a keyboard. Users should be able to navigate through menus, buttons, and forms using the Tab key, Enter key, and other keyboard shortcuts, allowing those with motor disabilities to interact with the site effectively. Another is to ensure compatibility with screen readers. Screen readers are tools that read aloud the contents of a web page for users with visual impairments. To achieve this, developers should use semantic HTML elements and ARIA, Accessible Rich Internet Applications, attributes. Semantic HTML provides clear, meaningful information about the structure of the content,
while ARIA attributes enhance the accessibility of dynamic and complex web elements. Together, they enable screen readers to accurately convey the content and functionality of a website to users with visual impairments. Finally, developers should provide text alternatives like alt text descriptions, captions, or transcripts for non-text content such as images, videos, and audio to ensure that all users can access this information. In this video, we defined key web accessibility features and explained their significance. We discussed the importance of web accessibility, legal and ethical considerations, and identified essential accessibility features like keyboard navigation, screen reader compatibility, and text alternatives. By implementing these features, you can create a more inclusive web experience for all users. Imagine visiting a website where the text is so small and the colors so faint that you struggle to read anything. Now consider how frustrating that would be if you faced this barrier every day. In the digital age, making web content accessible isn't just a nice to have, it's a must. By designing with accessibility in mind, you not only enhance the user experience for everyone, but also expand your reach and meet important legal standards. In this video, we will summarize the best practices for designing accessible web content using CSS. Accessible typography refers to the design and implementation of text on a website in a way that ensures readability and usability for all users under various conditions and on different devices. Let's explore principles of accessible typography. First, scalability requires using relative units like EM and REM for font sizes so that text can be resized by users according to their needs without breaking the layout. Next, developers must also ensure that there is sufficient contrast between text and background colors to make the text readable for people with low vision or color blindness. It is also important to select clear and legible fonts, avoiding overly decorative or script fonts that can be difficult to read. You should also provide adequate space between lines of text, line height, and letter spacing to improve readability. Next, justified text can create uneven spaces between words, which can be difficult to read, especially for people with dyslexia. Left-aligned text is generally more accessible. Finally, you should ensure that text adapts well to different screen sizes and orientations, maintaining readability on both large top screens and small mobile devices. Let's examine a few applications of accessible design that can make websites more inclusive and user-friendly. Ensuring that text on your website is scalable and readable is crucial for accessibility. This is where relative units like EM and REM come into play. Instead of using fixed pixel sizes, EM and REM units adjust according to the user's settings or the parent element's font size. This allows text to scale more effectively across different devices and browsers. The EM unit is relative to the font size of its parent element. For example, if a parent element has a font size of 16 pixels, setting a child element's font size to 1.5 EM will result in 24 pixels. The rem unit is relative to the root element, usually the HTML tag. This makes it more predictable when designing larger sections of text, as it doesn't change based on nested elements. By using EM and REM, you allow users to resize text as needed, improving readability for those with visual impairments. This is especially important for people using browser settings to enlarge text for better legibility. Next, let's talk about flexible layouts and how they support accessibility for screen readers and assistive technologies. When creating layouts, ensure that your design can accommodate varying screen sizes, orientations, and preferences. Use CSS properties like Flexbox and Grid to create adaptable layouts. These CSS tools allow content to reflow and adjust based on screen size, ensuring that users accessing your site on different devices, such as mobile phones, tablets, or desktop monitors, can easily navigate the content. Ensure that your content is structured in a logical order. Screen readers interpret the DOM, document object model, of a web page, so using semantic HTML combined with flexible layouts will make navigation smoother for users who rely on these technologies. Make sure interactive elements such as buttons and links are easily reachable and operable, even when zoomed in or navigated with a keyboard. Using relative units for spacing and layout can help maintain proportions and usability across various settings. Finally, let's focus on how CSS can enhance navigation, making your website more intuitive and user-friendly. Links should stand out visually from regular text. This can be achieved by changing the color, adding underlines, or using contrast that is easily discernible for users with color vision deficiencies. Use :focus and :hover pseudo-classes to provide visual feedback when users interact with links and buttons. This makes navigation clearer, especially for users who rely on keyboard navigation or screen readers. With respect to interactive elements, you should ensure that buttons and form controls are visually distinct and clearly labeled. CSS can be used to enhance these elements with effects like focus outlines or borders, improving visibility. Use consistent spacing and padding around clickable elements to avoid accidental clicks and make it easier for users with motor impairments to interact with your content. By following these principles, accessible typography can help create a more inclusive web experience, allowing all users to access and read content more comfortably. Designing accessible web content using CSS is essential for creating inclusive digital experiences. By following these best practices, you can ensure your content is usable by everyone, regardless of their abilities or devices.
Have you ever struggled to make a website layout perfect on both desktop and mobile? Flexbox could be the game changer you need. It's a powerful tool in modern web development, enabling designers to create flexible, responsive layouts with ease. Understanding Flexbox is key to mastering CSS and ensuring your websites appear great on any device. In this video, we will examine how to use CSS Flexbox to create flexible and responsive layouts. Flexbox is a CSS layout model that allows items in a container to be automatically arranged based on the size and orientation of the window or device on which they're being displayed. Let's start with an overview of the CSS Flexbox model. Flexbox, short for Flexible Box Layout, is a one-dimensional layout method for arranging items in rows or columns. Unlike traditional layout methods like float, Flexbox is designed for distributing space along a single axis, either horizontally or vertically. What makes Flexbox particularly useful is its ability to automatically adjust the size of items within a container, ensuring that they align perfectly and distribute space evenly regardless of the screen size. This flexibility is why Flexbox is an excellent choice for creating simple, responsive designs that adjust across desktops, tablets, and mobile devices. A Flex container is the parent element in a Flexbox layout that contains and controls the behavior of Flex items. Flex items are the child elements within the Flex container that are affected by the Flexbox properties. First, to start using Flexbox, we need to define a Flex container by setting the display property to Flex on a parent element. This enables Flexbox for that container, making all its direct children Flex items. Next, we use the Justify Content property to align items horizontally within the Flex container. Options include Flex Start, Center, and Space Between. For example, to justify content center, we would center the items along the main axis of the container. Then the Align Items property allows us to align items vertically within the Flex container. Common values are Stretch, Center, and Flex End. Setting Align Item Center will vertically center the items within the container. Finally, the Flex Direction property determines the direction in which the Flex items are placed. It can be set to row, column, row reverse, or column reverse. For example, Flex Direction column will stack the items vertically instead of horizontally. Flexbox shines in responsive design, where the layout needs to be adjusted based on screen size. By combining Flexbox properties, we can create layouts that adapt seamlessly to different devices. For instance, a navigation bar can wrap its items onto a new line on smaller screens using FlexWrap Wrap. This adaptability makes Flexbox an indispensable tool in modern web development. Imagine you're designing a website with a navigation bar that needs to work on both desktop and mobile devices. How could you use Flexbox to develop the site? Understanding the Flexbox model is essential for creating responsive and user-friendly web designs. Using Flexbox, you'll be able to craft layouts and adapt effortlessly to any screen size, ensuring a consistent user experience. The learning experience in this course is designed to give you a comprehensive understanding of key concepts through various learning methods. You'll be guided through interactive, engaging materials that help you build practical and theoretical knowledge. Whether you're interested in front-end, back-end, or full-stack development, this program has the tools to support your growth every step of the way. Throughout the course, you'll be introduced to core concepts and key ideas in videos. These videos are designed to help you understand definitions, processes, and essential steps clearly and concisely. You'll get to absorb foundational knowledge, setting the stage for deeper exploration as you move forward. And when you need step-by-step guidance, screencasts will provide you with a detailed practical view. These screencasts will show you exactly what's on the screen and how to work through specific coding tasks. The course also includes readings that reinforce the key ideas presented in the videos. These readings are more than just supplementary material. They're job aids. You can print them out and use them as a reference while working on assignments or activities, helping to apply what you've learned in real-world situations more easily. Small activities are included to help you check your understanding of key ideas. These activities provide quick, interactive opportunities to practice what you've just learned. After completing each activity, you can compare your work with a fully explained example and answer key. This ensures that you always know if your answer is correct. Practical experience doing tasks you would in a job within this field is essential, and that's where guided labs come in. These labs take you through the implementation of different concepts step by step. As you work, you'll receive feedback and helpful hints, ensuring you can get the help you need when you need it. It's the perfect opportunity to practice in a controlled environment while learning by doing. After completing the guided labs, you'll move on to independent projects, or you try it. This is where you'll put your skills to the test, applying what you've learned in the labs. You'll work through real-world problems, cementing your understanding of the course material. The course will culminate in a practical project leveraging Microsoft Copilot that you can use as a portfolio artifact when you begin your job search in this field. As you progress through the program, the portfolio pieces will become stronger and better representations of the authentic experience you've gained. They'll showcase your understanding of code and the ability to implement different concepts from the developer program. This course guides you step by step from understanding concepts through videos and readings to apply them in activities, screencasts, and labs. Each part of the course builds on the last, helping you gain knowledge and authentic experience. By the end, you'll have completed real projects that not only showcase your skills, but can also be included in your portfolio as you start your career. Everything you do here will prepare you for success as a developer. Let's get started.
Have you ever struggled with creating layouts that appear great on every device? CSS Grid is a powerful tool that gives you control over how your content is arranged in both rows and columns, helping you design layouts that are organized and flexible. In this video, we will describe how to use CSS Grid for designing complex, grid-based layouts. A CSS grid is a system in CSS that allows you to create layouts using a grid of rows and columns. CSS Grid is a system in CSS that lets you arrange elements on a web page using a grid of rows and columns. It's like creating a table, but with more control and flexibility. This is especially useful when you want to create responsive and complex designs. Now that we know what CSS Grid is, let's look at how it organizes your content. The first thing we need is a grid container. This is where your grid starts. Think of it as the outer box that will hold your grid layout. A grid container is a box that holds your grid and tells the browser you want to use the CSS grid layout. A grid container is like a box that holds your entire grid. To make an element a grid container, you set its display property to grid. This tells the browser, I want to arrange the items inside this box using the CSS grid system. Now that we understand the grid container, let's see how we can set up a basic grid and start placing items within it. Let's start by making a simple grid. First, we define a grid container by setting display::grid on an HTML element, like a div tag. This container is where your grid items will live. Next, we create the grid container. This tells the browser to treat this div as a grid container where you can place items in a structured grid. Next, we create the row of the grid. This line creates 2 rows in the grid, similar to how we created columns. Each row will take up an equal amount of space within the grid container, dividing the height into 2 equal parts. Finally, this property adds space between the grid items. 10px means that there will be a 10-pixel gap between each column and row, giving some breathing room between the elements. Now we put everything together to create a grid container. We tell the browser to create a grid with 2 columns and 2 rows, where each column and row takes up an equal amount of space. The grid-gap adds spacing between each item in the grid. Once we set up our grid, we can place items inside it. These elements are known as grid items. Grid items are the individual pieces or elements inside your grid container that you want to arrange. These could be anything, like images, text, or buttons. In this script, we're keeping it simple, but in the next video, we'll explore how to place and span items in more complex ways. With these properties, you can create various layouts. For instance, you can place images, text, or other elements into this grid, and they will automatically arrange themselves into the structure you've defined. This layout will adjust as screen size changes. By mastering the basics of CSS Grid, you can create layouts that are organized and flexible. These foundational skills will help you as you move on to more complex designs. Imagine visiting a website where every interaction feels smooth and engaging. Subtle animations guide your attention, and transitions create a seamless experience as you navigate through the content. These effects are not just about aesthetics, they are crucial to enhancing user experience. In this video, we will explain the use of CSS animations and transitions to enhance web interactivity and aesthetics. Let's start with CSS transitions. A transition allows us to smoothly change the value of a CSS property over a specified duration. Instead of a sudden change, the transition creates a gradual shift, making the interaction feel more natural and polished. Instead of an abrupt change, a transition enables a gradual, animated shift between 2 states. For example, changing the background color of a button when hovered. Here's the basic syntax for a CSS transition. Let's examine each component. Transition-property. This specifies which CSS property will change. You can transition things like width, height, opacity, background color, and many others. Using all will apply the transition to any property that changes. Transition-duration. This defines how long the transition will take. In this example, it's set to 0.5 seconds, so the change will happen over half a second. Transition-timing-function. This controls the speed of the transition. The most common value is ease, which starts slowly, speeds up, and then slows down at the end. But other options like linear and ease-in-out are also available. There are also some advanced CSS properties for styling and layout that can improve each user's experience. One such advanced property is CSS animations. CSS animations allow you to animate transitions between different states of an element. They enable smooth changes to properties like position, size, color, opacity, creating dynamic effects that can enhance the user experience on a web page. CSS animations use the @keyframes rule to define a sequence of stages for an element to transition through from start to finish. Unlike transitions, which only define a single change, animations can orchestrate a series of steps, creating a more intricate and engaging experience. It changes an element's style at different points in the animation timeline. You can define these steps as percentages or with the from 0% and to 100% keywords. Let's go through an example of defining a CSS animation using the @keyframes rule. We'll name this animation Example Animation. First, we start by writing @keyframes, followed by the name of our animation, Example Animation. Within the curly braces, we define the different stages of our animation. At the first stage, 0%, the element is set to its initial position with transform, translate, x, open parens, 0, close parens, semicolon. This means the element will start at its original position on the horizontal axis. Next, at 50%, we move the element 50 pixels to the right with transform, translate, x, open parens, 50 pixels, close parens, semicolon. This represents the halfway point of the animation. Finally, at 100%, the element is moved all the way to 100 pixels to the right with the transform, translate, x, open parens, 100 pixels, close parens, semicolon. This marks the end of the animation. When this animation is applied to an element, it will smoothly transition from its original position, move 50 pixels, and then continue to 100 pixels to the right, creating a sliding effect. CSS animations offer a range of possibilities to enhance your web pages. Let's explore a few common use cases where animations can significantly improve user experience. When should CSS animations be used? First, hover effects. By animating buttons or links when a user hovers over them, you can create a more engaging and interactive interface. Imagine a button that slightly enlarges or changes color when a user's cursor moves over it. This subtle effect can make your site feel more dynamic. Next is loading indicators. CSS animations can be used to create spinners or progress bars, providing visual feedback while content is loading. This helps keep users informed and reduces perceived wait times. Transitions are another powerful application of CSS animations. They allow for smooth changes between different states of an element, such as menu sliding in or out. These transitions make interactions that feel more fluid and natural. Finally, attention-grabbing effects. Animating key elements like call to action buttons can draw the user's attention to important parts of your page. For example, a gentle pushing effect on a sign up button can encourage users to take action. Understanding and utilizing CSS animations and transitions improves your website's visual appeal and significantly enhances user interaction and experience. By mastering these techniques, you can create a dynamic, responsive, and visually compelling web design. Have you ever visited a website that displayed well on your desktop or laptop but was frustrating to navigate on your phone? A well-planned, responsive design could have prevented that frustration, ensuring a seamless experience across all devices. In this video, we will explain the steps for planning a responsive web design. Let's explore how to define your project's requirements, sketch wireframes, and choose the proper layout techniques to bring your design to life. The first step in planning a responsive web design is to define the requirements and objectives of your project clearly. Start by identifying the target devices your web page will need to support. Do your users primarily access your site on smartphones, tablets, or desktops? Or do you need to ensure a seamless experience across all devices? Knowing this helps you prioritize which screen sizes to focus on during the design process. Next, outline the user experience goals. What do you want users to accomplish on your site? For instance, is your primary goal to provide easy navigation, fast access to content, or a visually engaging experience. Clear objectives will guide your design decisions and help you prioritize what's most important. Once you've defined your requirements, the next step is wireframing. Wireframing is the process of sketching basic layouts for your web pages. This step is important because it allows you to visualize how your content will adapt to different screen sizes before diving into the actual design. It also helps you plan the flow of information and ensures that your design remains functional and user-friendly across all devices. It's a cost-effective way to test different layouts and make adjustments before you start coding. Start by sketching a simple layout for the smallest screen size, usually a smartphone. Think about how elements like your navigation menu, header, and main content will stack and resize. Then, create variations of the wireframe for larger screens, like tablets and desktops. As you sketch, consider how your layout will adapt to different screen sizes. This might mean simplifying the navigation for mobile or adjusting image sizes for tablets, ensuring the design remains functional and aesthetically pleasing at any resolution. Now that you have your wireframes designed, it's time to choose your CSS layout approach. The two most common methods for creating responsive layouts are Flexbox and CSS Grid. Let's compare these two methods. Let's begin with Flexbox. Flexbox is a CSS layout model that allows items in a container to be automatically arranged in a flexible and responsive manner. Flexbox is ideal for more straightforward layouts that require elements to align or distribute space within a container. It's excellent for one-dimensional layouts where you need to control the element's alignment, spacing, and order along a single axis. The second most common method for creating responsive layouts is the CSS Grid. CSS Grid is a two-dimensional layout system that allows you to design web pages using a grid-based approach. For more complex, two-dimensional layouts, CSS Grid is a good choice. It allows you to create intricate grid structures that can easily adapt to different screen sizes, giving you control over both rows and columns in your design. With a plan in place, you can now begin building your website based on the decisions you made. Planning a responsive web design involves three key stages: defining your requirements and objectives, creating wireframes to visualize your layout, and selecting the appropriate layout techniques like Flexbox or Grid. By following these steps, you'll be well equipped to design web pages that are accessible, engaging, and functional on any device. Have you ever wondered how some websites manage to display flawlessly on any device, whether it's a tiny smartphone or a large desktop monitor? The secret often lies in the power of CSS Flexbox, a tool that enables designers to craft layouts that adapt beautifully to different screen sizes. In this video, we will describe how to use CSS Flexbox to create responsive layouts that adapt to various screen sizes. Flexbox allows us to align and distribute space among items within a container efficiently. Let's explore some advanced properties to enhance our layouts. Here are some advanced properties that make Flexbox even more powerful. Let's explore each of these properties and learn what each can do. The flex-wrap property controls whether flex items should wrap out onto multiple lines when there isn't enough space in the container. For example, in a row of images, setting flex-wrap, wrap, semicolon allows the images to wrap onto the next line, keeping the layout neat on smaller screens. The justify-content property is used to align flex items along the main axis, horizontal or vertical. You can use options like center, space-between, or space-around to distribute the items within the container, ensuring balanced spacing and alignment on different devices. The align-items property aligns flex items along the cross-axis, the opposite axis of the main axis. For instance, setting align-items, such as center, vertically centers items within the flex container, is particularly useful for maintaining a balanced design across devices.
Now that we've covered the basics, let's explore some of the practical applications of Flexbox. Flexbox is ideal for building responsive navigation bars. For instance, you can use justify-content, space-between, semicolon, to spread out navigation links evenly across the bar, ensuring they remain accessible and aesthetically pleasing on both large and small screens. Creating grids of cards is another practical application of Flexbox. By using flex-wrap, wrap, semicolon, you can ensure that the cards reflow to fit the screen size, stacking vertically on smaller devices and laying out in rows on larger screens. Flexbox also shines when creating flexible content areas that need to adapt to different screen sizes. For example, you can use a combination of flex-grow and flex-shrink properties to allow content areas to expand or contract based on available space, ensuring readability and usability. By using CSS Flexbox, you can create responsive layouts that appear great and provide a seamless user experience across a wide range of devices. Whether you're building navigation bars, grids of cards, or flexible content areas, Flexbox is an essential tool in modern web design. This lab will focus on responsive design fundamentals, ensuring your page adapts well to different screen sizes while maintaining accessibility and aesthetic appeal. Before we can apply any CSS, we need to set up the structure of our HTML document. This will be the framework that holds all the content. We'll start by creating a basic web page structure with a header, navigation bar, main content area, and a footer. The goal here is to structure the document using semantic HTML tags like header, nav, main, and footer to give meaning to each section. This helps with both accessibility and SEO. To get started, first we're going to define the title of the web page using the title tag. Next, we're going to set the main heading inside the H1 tag header. Now we'll define the first link for navigation using the A tag. Now we'll define the second link for navigation using the A tag. And now we'll define the third link for navigation using the A tag. Now we'll define the heading for the main content section inside our H2 tag. Now we will add a paragraph of text inside the P tag for the main content section. Now we will define a heading for the sidebar using the H3 tag. Next, we'll add another paragraph of text inside the P tag for the sidebar. Now we will define the copyright text inside the footer using the P tag. And then we select the button at the top right to run the code. And as you can see, we have a basic HTML structure including the header, navigation links, a main content area, and a footer. The layout will be enhanced using CSS to ensure responsiveness. So let's continue to move forward. Next, we'll apply the CSS style to the page and define how the elements should be displayed. The box model is critical in CSS as it determines the size, padding, borders, and margins of elements. By applying the box sizing, Next, we'll apply CSS to style the page and define how elements should be displayed. The box model is critical in CSS as it determines the size, padding, borders, and margins of elements. By applying the box sizing border box property, we ensure that the padding and borders are included in the element's total height and width. We'll also style the header, navigation bar, main content, and footer for a more structured layout. First, let's apply the box sizing property to ensure that paddings and borders are included in the element's size. Next, we're going to set a font family for the entire page using the font family property. Now we're going to define the background color of the header using background color. We're going to set that to number 333. Now we will define the text color of the header using color. Now we'll define the padding inside the header using padding. Now we will align the navigation links horizontally using justify content. Now we will define the background color for the navigation bar. We're going to set that to 444. And then define the padding inside the navigation bar using the padding command. Now we will define the background color of the footer using the background color command. Again, we're going to set this to 333.
We're going to set a contrast color of white, and then we will align the footer text to the center using text align, and set our padding for the footer to 10 pixels. And then we select the button at the top right to run the code. If this was actually running, as you can see here, we've got the header, navigation, footer, and there are different background colors, and the text is aligned with the main content to the left and the navigation centered. The page has a clean and structured appearance. A responsive web page adjusts based on the side of the screen it's viewed on. We'll use media queries to apply different styles based on the screen size. For smaller screens, we'll stack the main content sidebar vertically and adjust the font sizes. Media queries allow us to set breakpoints like media to target smaller devices. This ensures that our page looks good on both mobile phones and larger screens. First, we're going to set the flex direction to adjust the layout for smaller screens. Now, we're going to set the width of the sidebar for smaller screens. You have to make sure that you get the % sign in there, or you'll get an error message like I did. Then we adjust the font size using the font size property. And then we select the button at the top right to run the code. On screens smaller than 768 pixels, such as tablets or mobile devices, the layout will adjust, stacking the main content and the sidebar vertically. The text will be resized to ensure readability on smaller screens. CSS transitions and animations help make your web page feel more dynamic and interactive. Transitions allow for smoother changes when elements are hovered over or clicked, such as a button changing color. Animations go a step further by defining multiple stages of a change, such as a button that expands and shrinks in a loop. We'll apply a transition to navigation links and an animation to the header and footer for CSS transitions and animations help make your web page feel more dynamic and interactive. Transitions allow for smooth changes when elements are hovered over or clicked, such as a button changing color. Animations go a step further by defining multiple stages of a change, such as a button that expands and shrinks in a loop. We'll apply a transition to the navigation links and an animation to the header for added interactivity. First, let's define the transition property for the navigation link. Next, set the animation name, duration, and easing function for the header. Now, we need to set the starting transform value for animation at 0%. And now we set the ending transform value for animation at 100%. And then we select the button at the top right to run the code. When you hover over the navigation links, if this was run live, the links would change color smoothly. The header will have a sliding effect, moving slightly to the right and back in a continuous loop. Great job completing this guided lab.
Congratulations on completing the module CSS for Web Development. You've mastered CSS basics, responsive design principles, and advanced layout techniques like Flexbox and Grid, equipping you to create accessible, modern websites that adapt to any device. We began by explaining the basic concepts and syntax of CSS. We then explored the different types of selectors and how they are used to apply styles to specific parts of an HTML document. Next, we learned about the use of CSS in web design and identified the core principles of responsive web design. We gained an understanding of the function and use of media queries in responsive web design. We then identified key web accessibility features, defined them, and explained their significance. We explored best practices for designing accessible web content using CSS. We described advanced CSS styling and layout techniques and explored the CSS Flexbox model, explaining how it differs from traditional layout methods and why it's useful for creating responsive designs. Finally, we designed a responsive web page using CSS and learned how CSS Flexbox creates responsive web layouts that adapt to various screen sizes. We discussed how CSS Grid can be combined with Flexbox to create even more versatile and responsive layouts, highlighting the strengths of each method. In this module, you've gained a solid understanding of CSS, covering everything from basic syntax and selectors to advanced features like Flexbox and Grid for crafting responsive layouts. You've also explored how to implement accessibility best practices to ensure your web content is inclusive and user-friendly. Equipped with these skills, you're now ready to create modern, adaptable, and accessible websites.
Mastering the basic syntax and constructs of JavaScript is the first step towards becoming a skilled developer. These core concepts are the building blocks for writing efficient, dynamic code, and understanding them will empower you to create robust web applications. In this video, we will use variables, data types, and operators in JavaScript to perform basic programming tasks. Whether you're new to coding or just brushing up on your skills, this video is designed to help you understand and use JavaScript effectively. JavaScript is a programming language used to create interactive effects within web browsers. Let's explore some of the things you can do with JavaScript. We'll start with variables. Imagine variables as containers or boxes where you can store information, which can be anything from a number to a piece of text. Here's an example of a variable declaration in JavaScript. This line of code states that the variable name should be set to the value Alice. Here, name holds the text Alice, so we can use it later in our JavaScript code. Using variables makes your code more flexible and easier to manage. Instead of repeating the same information, you can store it in a variable and use that variable throughout your program. In JavaScript, you declare or create a variable using three keywords: var, let, and const. Var is the old way to declare a variable. It's less commonly used now. Let is the modern way to declare a variable when you expect the value to change. Const is the way to declare a variable that holds a value that won't change. In this code, we're declaring three different variables using our three different methods. In line 1, we use var to set the variable age to the value 25. Similarly, the second line of code uses the let keyword to set the variable city to the value New York. Because we use var and let to declare these variables, we can change their values later in the program. For example, we can later set city to the value Barcelona later if we need to. The third line of code uses the const keyword to set the country variable to the value USA. By using the const keyword, we're telling the program that the country variable shouldn't change, and JavaScript won't let us change its value. Now that we've explored declaring variables, let's investigate what kind of data variables can hold. In programming languages, different kinds of data are called data types. For example, the data type string is used for text data. The data type number is used for both integers and decimals. The numbers 42 and 3.14 both are examples of the number data type. The Boolean type represents true and false values. The array type is used to store multiple values. For example, a single array variable can hold the numbers 1, 2, 3, and 4. Finally, the object type stores key value pairs like JavaScript object notation or JSON data. In this example, name and age are the keys, and Alice and 25 are the values. In many programming languages, data types are declared when the variable is created. For example, you might declare a variable as string first name equals Alice. However, in JavaScript, we just use the let var const keyword to declare a variable, and JavaScript figures out the data type the variable holds when the script runs. Now that we've learned how to declare variables and what data types they can hold, let's explore how to work with that data in JavaScript using operators. Operators are symbols that we use to manipulate, change, or evaluate variable data. In the math formula 1 plus 3 equals 4, the plus sign is an operator. It's used to perform the addition operation on the numbers 1 and 4. Commonly used types of operators include arithmetic, assignment, comparison, and logical. Let's review each of these. Arithmetic operators include plus, minus, star or times, slash or division, and percent or modulo operator. These perform basic math operations on variables and numbers in JavaScript. In the code let total equal product price times quantity, we use the star symbol to multiply the value in the product price variable times the value in the quantity variable and assign it to the total variable. JavaScript supports multiple assignment operators, which developers use to assign values to variables. These include equal, plus equal, minus equal, times equal, divide equal, and modulo equal. The most basic assignment operator is equal, which assigns a value to a variable. Plus equal adds a value to the variable. For example, quantity plus equal 1 will increase the value of the quantity variable by 1. Similarly, minus equal subtracts, star equal multiplies, and slash equal divides a value from the variable. In this example, the total is updated using different assignment operators. First, we assign a value to total using the equal symbol by declaring it as let total equal 100. Using the code total plus equal 20 adds 20 to the total, so the total is now 120. The code minus equal 10 subtracts 10 from total, so total is now 110. Total star equals 2 multiplies total by 2, so total is now 220. And finally, total slash equal 4 divides total by 4, so total is now 55. One final operator that is useful for mathematical operations is the modulo operator. This operator returns the remainder when dividing one number by another. For example, if total is equal to 55 and we use the code total modulo equals 6, total would be updated to the value of 1. We can also use operators to compare the values of variables or compare variable values with other numbers or strings. Comparison operators return a Boolean value, true or false. Here are some of the most common ones. Equal equal means equal to. Equal equal equal, strictly equal to. Exclamation point equal, not equal to. Exclamation point equal equal, strictly not equal to. Greater than is the greater than symbol, less than is the less than symbol. The greater than symbol and the equal symbol means greater than or equal to, and the less than symbol and equal sign is less than or equal to. In programming languages, it can sometimes be confusing to understand the difference between equal to and strictly equal to. Equal to or the double equal sign instructs the program to check for loose equality. This means that the program tries to determine if there's a way that the two values could be equal. So the double equal compares two values after trying to convert them to the same type. For example, comparing the number 1 and the string 1 is loosely equal. The double equal operator returns true because the JavaScript program converts the string to a number before doing the comparison. In contrast, strict equality checks both the value and the type. The operation returns false if either the value or the type is different between the two values. For example, the comparison of the number 1 and the string 1 would not be strictly equal. The triple equal operation will return false there, because while the values are the same, the types are different. Finally, we can compare values and variables using logical operators like and, or, and not. Logical operators allow a developer to combine multiple conditions and return true or false based on the combined conditions. Here are some common logical operators used in JavaScript. Double ampersand, which stands for the AND operation. This operation returns true if all of the items being compared are true. For example, the code quantity is greater than 1 and ampersand order number is greater than 1 will return true only if both the variables quantity and order number are greater than 1. The double pipe symbol stands for the OR operation. This operation returns true if any of the items being compared are true. For example, quantity greater than 1, double pipe, back order greater than 1, will return true if the value of quantity is greater than 1 or the variable back order is greater than 1. It also will return true if both are true. It returns false only when both are false. The exclamation point represents the not operator. It's used to reverse the truth value of a condition. If a condition is true, applying the exclamation point will make it false and vice versa. For example, exclamation point current customer will return true if the variable current customer is false, and false if the variable current customer is true. This operator doesn't change the actual value of the variable, it just evaluates its opposite in a logical expression. Understanding the basic syntax and constructs of JavaScript, including variables, data types, and operators, is essential for developing interactive web applications. By mastering these basics, you can start building dynamic and responsible web pages with confidence.
Controlling the flow of a JavaScript program gives you the power to make your code smart, efficient, and dynamic. Whether you're deciding between different paths with if statements or looping through tasks with precision, mastering these control structures is key to building interactive and responsive web applications. In this video, we will use control structures in JavaScript to manage the flow of a program. Whether you're new to coding or just brushing up on your skills, this video is designed to help you understand and use JavaScript effectively. Control structures are fundamental programming constructs that allow you to dictate the flow of execution in your code. They enable you to make decisions, repeat actions, and handle different scenarios based on conditions. In JavaScript, common control structures include if statements for conditional execution, switch statements for choosing among multiple options, and loops for, while, do while for repeating a block of code multiple times. By using control structures, you can write more flexible, efficient, and logical programs that respond dynamically to different inputs and situations. Let's examine each type of control structure. An if statement is a control structure used to execute specific blocks of code based on whether a condition is true or false. In JavaScript, you can combine if with else, if and else, to handle multiple conditions in a sequence, making your code more flexible and responsive. When using an if statement, the condition inside the parentheses is evaluated. If the condition is true, the code inside the curly braces following the if statement is executed. If the condition is false, the program moves on to check the next condition. If there's an else if statement, if none of the conditions are true, the code inside the else box is executed. In this example, the if statement checks if user age is less than 18. If true, it outputs minor. If the first condition is false, the else if checks if user age is between 18 and 64. If true, it outputs adult. If neither of the first two conditions is true, the else block runs and outputs senior. This structure allows your code to make decisions based on the input, ensuring that the correct block of code is executed based on the provided conditions, all within the black box of the control structure. A switch statement is a control structure that allows you to evaluate an expression and execute one of many possible code blocks based on the result of that expression. Use statements are particularly useful when you have multiple possible values for a single variable and want to execute different code for each value. This makes the switch statement a more organized and readable alternative to multiple if-else statements when dealing with several conditions. In a switch statement, the expression is evaluated once and its value is compared against each case. Think of a switch statement as a black box for routing your code. You input a value and the switch statement directs the flow of execution to the appropriate case without needing to manually check each condition. Let's look at an example of a switch statement. In this example, the switch statement evaluates the value of the day variable. If day is 0, the code will output Sunday and then stop because of the break statement. If the day is 1, it outputs Monday, and so on. If the day does not match any of the case values 0 through 6, the default block will run outputting invalid day. The switch statement acts as a control hub, directing the program's flow to the correct block of code based on the input's value, all within the black box of this control structure. It is important to note that the break at the end of case 0 and case 1 prevents the execution from continuing into the next case. Without break, the code would continue to execute subsequent cases regardless of whether they match, a behavior known as fall-through. A for loop is a control structure that repeatedly executes a block of code a specified number of times. For loops are particularly useful when you know in advance how many times you want to run the loop. The for loop consists of three main parts: the initialization, the condition, and the final expression, all of which control the flow of the loop. First, initialization is where you set up a counter variable to track the number of iterations. It runs once at the beginning of the loop. Then, before each iteration of the loop,
the condition is checked. If the condition evaluates to true, the loop continues. If it evaluates to false, the loop stops. Lastly, the final expression is executed after each iteration of the loop. This is typically where you increment or decrement your counter variable. Here is an example of a for loop. In this example, the initialization is let I equal 0. It sets up a counter variable I starting at 0. I less than 5 is the condition that is checked before each loop iteration. The loop will run as long as I is less than 5. The final expression of I plus plus increments the value of I by 1 after each iteration. In this for loop, the code block console.log open parens I close parens semicolon is executed 5 times, once for each value of I from 0 to 4. The loop effectively handles repetition, allowing you to perform tasks multiple times without manually writing each step. A while loop is a control structure used to repeatedly execute a block of code as long as a specified condition remains true. A while loop continues to execute a set of instructions repeatedly as long as certain conditions hold true. You input a condition, and the loop handles the repetition until that condition no longer exists. The while loop begins by evaluating the condition. If the condition is true, the code inside the loop is executed. If the condition is false, the loop stops and the program moves on to the next block of code. A code block gets executed each time the loop runs. Inside the code block, there is usually an update statement that modifies the variables involved in the condition. This is crucial to ensure that the loop eventually ends. Otherwise, you could create an infinite loop. Let's examine an example of a while loop. In this while loop, the code block console.log open parens I close parens semicolon is executed repeatedly as long as I is less than 5. The loop automatically stops once the condition I less than 5 becomes false, ensuring that the loop does not run indefinitely. The while loop provides a powerful way to repeat tasks when the number of iterations depends on a dynamic conditions during runtime. A do-while loop is a variation of the while loop that guarantees the code block will execute at least once, regardless of whether the condition is true. A do-while loop always performs its task at least once before checking if it should continue. This is useful when you need to ensure that an action occurs before the loop condition is tested. In a do-while loop, the block of code within the do section is executed first, unconditionally. After the code block executes, the condition in the while statement is evaluated. If the condition is true, the loop repeats. If the condition is false, the loop ends. The process of executing the code block and then checking the condition continues until the condition evaluates to false. Here's an example of a do-while loop. In this do-while loop, the code block console.log open parens I close parens semicolon is executed a total of 5 times. Unlike a while loop, where the condition is checked before the loop starts, a do-while loop ensures that the code block runs at least once. This is particularly useful when you want to guarantee that a specific action occurs before making any conditional checks. The do-while loop provides a straightforward way to perform tasks that must execute at least once, regardless of the initial condition. Understanding how control structures and logical operators can shape the flow of your JavaScript programs can make your code dynamic, efficient, and responsive to various scenarios. These tools are essential building blocks in your journey as a developer, allowing you to create smarter, more interactive web applications. Keep practicing these concepts, and you'll be well on your way to writing code that not only works, but works intelligently. Have you ever wondered how websites become interactive? JavaScript is a common language that is used to make static pages come alive. In this video, we will explore how to write and run basic JavaScript code in a web browser. JavaScript is a programming language
perfect for adding interactive features to web pages, making them more engaging and dynamic for users. When paired with HTML, JavaScript allows your code to run as soon as the web page loads. When you combine the two, be sure to use a text editor, which allows you to write and edit the JavaScript and HTML code that makes up your web page. We use text editors to create code because these tools do not have hidden formatting that could corrupt the code you are trying to create. Text editors provide features like syntax highlighting, code completion, and error checking, which help you write code more efficiently and spot mistakes easily. Text editors allow you to create, test, and refine your HTML and JavaScript code to build dynamic and interactive web pages. Commonly used text editors include Notepad++, Brackets, and Sublime Text. To get started, open your text editor and create a new HTML file named index.html. Index follows the common naming convention for a website's homepage. Let's add the basic HTML structure to your file. Open your index.html file and include the following code. Writing basic JavaScript code involves creating simple programs that can run in your web browser. Let's begin by writing a simple JavaScript program inside the script tag of your HTML file. Open your index.html file in a text editor. Locate the section where you'd like to add your JavaScript code, typically within the head or the bottom of the body. Now, let's add the following code inside the script tag to display a message. Script, console.log, open parens, quotation, hello, comma, world, exclamation point, quotation, close parens, semicolon, and then close script tag. Console.log parens, which is one of the most common methods used by developers to print information to the browser's console. The console is a tool that logs messages or outputs results during the execution of JavaScript. This is a basic JavaScript command using console.log parens : This function prints or logs the text hello world inside the console when you load the HTML file in the browser. To view the result, open your web browser and load the index.html file. Right-click anywhere on the web page, select Inspect, and then navigate to the Console tab. The message Hello World should be displayed in the console. This confirms that your JavaScript code is running correctly. This method is extremely useful when testing and debugging JavaScript code, as it allows you to output values, check variable states, and view program behavior in real time. One of the best practices in web development is to use external JavaScript files. This approach allows you to keep your HTML clean and your JavaScript code organized. Let's go through the steps to achieve this. First, to create an external JavaScript file, start by opening your text editor and create a new file named script.js. This file will be used to store your JavaScript code. It allows you to separate functionality, JavaScript, from the structure, HTML, making your code easier to maintain. Next, add JavaScript code to script.js. In the script.js file, copy the following code that you previously wrote. Console.log, open parens, quotation, hello, comma, world, exclamation, quotation, close parens, semicolon. This code will log the message hello world to the browser's console when the web page is loaded. Now, open your index.html file and link the script.js file to it. To do this, add the following script tag just before closing the body tag in your HTML. Script source equals, quotation, script.js, close quotation, close bracket, close script tag. By doing this, you keep your HTML file clean and your JavaScript code organized and separate, making your project easier to manage. Running JavaScript in the browser's console is a quick way to test and debug your code. To do this, first, open your web browser and load the index.html file. Right-click anywhere on the page, select Inspect, and navigate to the Console tag. The message Hello World is displayed in the console, indicating that your external JavaScript file is working correctly. Press Enter to run the code. The console should display Hello World. Writing and running JavaScript code in a web browser involves including JavaScript in HTML documents using script tags and testing code in the browser's console. By mastering these basics, you can start creating dynamic and interactive web pages and JavaScript. By the end of this lab, you'll know how to create an HTML file that includes JavaScript. You'll learn how to declare variables using let, const, and var, use if statements and loops to control the flow of your code, and write simple JavaScript functions that work inside your web pages. Let's start by creating a basic HTML document and embedding some JavaScript into it. First, define the document type for HTML5. Next, specify the language for the document, which in this case is going to be English. Now we need to set the character encoding for the document. Now we need to set the viewport for responsive web design. Now we need to set the title of the document to JavaScript Lab. And now we need to add the heading Hello JavaScript inside the body. And then insert a JavaScript statement to log a message. And then we click the button in the top right corner to render the code. And as you can see, we've got Hello JavaScript. Next, we're going to declare variables with let, const, and var. Let is used when the variable's value can change during the program. Const is used for variables that should not change once they are set. And var is an older way of declaring variables and should be avoided, generally speaking, in modern JavaScript. First, declare the variable name as Alice. Next, we need to declare the constant age. Now we need to declare the variable city. Now we need to print the value of name, print the value of age, and print the value of city. And then we click the button in the top right corner to render our code. Again, we have Hello JavaScript over here, and then you can see the data, Alice, 30, and New York on the right side. Control structures allow you to dictate the flow of your program. An if statement checks whether a condition is true or false and runs the corresponding code. In this step, we're going to use an if statement to check a condition. If the condition is true, we will display a message in the console. Declare a variable number and assign it the value 10. Now we write the condition that checks if the number is greater than 5. And now we fill in the number being compared, put in number 5 here, and then let's check our code by clicking the button in the top right corner. And you see the message in the console, the number is greater than 5. Loops are a way to repeat a block of code multiple times. The most common loop in JavaScript is the for loop, which repeats code based on a starting point, a condition, and an incremented step. In this step, we will use a for loop to print numbers from 1 to 5 in the console. Initialize the loop with I equals 1 to start counting from 1. Set the condition I less than or equal to 5 to run the loop as long as I is less than or equal to 5. And then we want to print the value of I inside the loop. Let's check our code, and you see it's printed out 1 through 5 over in the console on the right. Functions allow you to encapsulate blocks of code and reuse them throughout your program. Functions are declared with the function keyword and can take parameters to perform actions on data. In this step, we will write a simple function that takes a number as a parameter and returns its square. We will call this function and print the result. First, we need to declare the function as a number. Then we need to return the square of the parameter by multiplying the number by itself. Now we need to print the result into console log. And then we can check our code by clicking the top right corner. And as you can see here, it's multiplied 4 by 4, the square of 4 to get 16. Great job on completing this guided lab. A document object model, or DOM, is a fundamental component of web development. It represents the structure and elements of a web page. Understanding and working with the DOM using JavaScript is key to creating dynamic and interactive websites. In this video, we'll explain the basics of DOM manipulation and how to access and modify HTML elements easily.
A document object model, often abbreviated as a DOM, is a programming interface for HTML and XML documents that represents the page so that programs can change the document structure, style, and content. The DOM is not actually part of HTML or JavaScript. It's a separate specification created by the World Wide Web Consortium, W3C. This means it can be used with many programming languages, but is most commonly used with JavaScript in web development. You can think of the DOM as a translator that helps your code interact with the content of a web page. It takes the HTML and XML that make up the page and turns them into something your JavaScript can interact with. This means you can use JavaScript to change a page's design and how it works, altering the structure, style, and content on the fly. Think of the DOM as the bridge that lets you bring your web pages to life. The DOM represents an HTML document as a hierarchical tree structure. Each element in the HTML document is a node in the tree. For example, in a simple HTML document, HTML, head, title, page title, close title tag, close head tag. Body, H1, hello world, exclamation point, close H1 tag, close body tag, close HTML tag. The HTML element is the root node, head and body are the child nodes, and so on. Let's explore some things we can do with a DOM. The DOM lets you use JavaScript to access and change parts of your web page. Each part, like a heading or a paragraph, is called a node. You can grab any node and tweak it to change your page's design or how an element behaves. For example, you can find a heading like an H1 element and change its text to something new. In this example, we've changed the text from Hello World to Welcome to our website. Accessing HTML elements is the first step in working with the DOM. It lets you select and interact with specific parts of your web page. Think of it like pointing to part of your house blueprint to make changes. Imagine you have a web page for a company called Contoso with a heading like this: H1 ID equals header. Welcome to Contoso, close H1. To access an element by its ID, you can use document.get element by ID. To grab this heading with JavaScript, you'd write let header equals document.get element by ID, open parens, open quote, header, close quote, close parens, semicolon. This line of code finds the document with the ID header and stores it in the variable header, making it easy for you to make changes to it. To access elements by their class name, use document.getElementsByClassName parens. Imagine you have two paragraphs like this: pClass equals info, some info, close paragraph. pClass equals info, more info, close paragraph. You can grab these paragraphs with JavaScript by writing let info elements equal document.getElementsByClassName, quotation, info, semicolon. This code finds all elements with the class name info and stores them in the variable info elements. Now you can easily work with these elements as a group. Complex selectors help you grab specific elements or groups of elements based on more detailed criteria, and the impact of using JavaScript is more powerful. To use more complex selectors, try document.query selector parens and document.query selector all parens. For example, if we use let first info equal document.query selector open parens, open quote, info, close parens, semicolon, we select the first element with the class info. Here's what's happening. Document.query selector parens searches the entire document and selects the first element that matches the given selector. In this case, .info is a CSS class selector, and the period before that indicates you are selecting elements with the class name info. So this line of code stores the first element with the class info in the first info variable for it to use later. Alternatively, if you would like to select all elements with the class info, use this code. Let all infos equal document.query selector all open parents, open quote, dot info, close quote, close parents, semicolon. Let's break it down. Document.querySelector all parents searches the entire document and selects all elements that match the given selector. The .info is a CSS class selector, and the period before info means you are targeting elements with the class name info. Unlike document.querySelector parents, which only selects the first matching element, document.querySelector all parents returns a node list of all matching elements. In this case, it finds every element with the class info and stores them in the all infos variable. You can then use this list to access or manipulate each of these elements, for example, looping through them or changing their content. Modifying HTML elements means changing their content, attributes, or styles to update your web page on the fly. For instance, you can use JavaScript to change the text inside a paragraph, update an image's source, or tweak the colors and fonts of your elements. This makes your web page dynamic and interactive, responding to user actions or data changes. Let's explore a few common modifications. First, changing text content is easy with JavaScript. You can use element.textContent or element.innerHTML to update the text inside an element. For example, if you were building a page for the pretend company Contoso again, you could change a heading's text with this JavaScript code. Header.textContent equals welcome to Contoso, exclamation point, semicolon. This code finds the heading element and updates its text to say, welcome to Contoso. Next, changing an element's attributes is simple with JavaScript. You can use element.setAttribute parents to do this. For example, if you have an image like this, image ID equals logo, source equals old logo.png, you can change its source with document.getElementById, open parents, open quote logo, close parents, dot set attribute, open parents, open quote source, close quote, comma, open quote new underscore logo dot png, close quote, close parents, semicolon. This code finds the image with the ID logo and updates its source to new underscore logo png, allowing you to change the image displayed on your page. Changing an element's CSS style is also straightforward with JavaScript. You can use element.style to do this. For example, if you want to change the color of a header, you can write header.style.color equals open quotation blue, close quotation, semicolon. This code finds the header element and changes its text color to blue, allowing you to style your page dynamically. Let's look at a few more examples of what you can do. To add a new paragraph to your web page, follow these steps. First, create a new paragraph element by typing let new paragraph equal document.createElement open parents open quote p close quote close parents semicolon. Next, set the text for your new paragraph by typing new paragraph.textContent equals open quote this is a new paragraph close quote semicolon. Finally, add it to the body of your document. Document.body.append child open parents new paragraph close parents semicolon. This code creates a new paragraph element, sets its text context, and appends it to the end of the document's body. You can also easily remove an element from your web page. First, select the element by its ID by typing let old element equal document.getElementById open parents open quote old element close quote close parents semicolon. Then remove it from its parent by typing old element dot parent node dot remove child open parents old element close parents semicolon. This code finds the element with the ID old element and removes it from the web page. It's that simple. Let's examine how our pretend organization Contoso would use the processes we have discussed in this lesson. Suppose that Contoso is developing an interactive dashboard for its web application and needs to use DOM manipulation to update content dynamically. First, they would type document.getElementById to access the elements they need to update,
like the header and the information sections. Next, they would update their text inside these elements to display real-time data. For example, to change the header text, they would type header.text content equals open quote Contoso dashboard close quote semicolon. Finally, to add new elements like new data points or alerts, they would create the element, set its content, and then add it to the page. For example, they could type let new element equal document.createElement open parens open quote p close parens semicolon new element.text content equal open quote new data close quote semicolon document.body append child open parens new element close parens semicolon. This code creates a new paragraph, sets its text to new data, and adds it to the body of the document. By following these steps, Contoso creates a dynamic and interactive dashboard that updates in real time based on user interactions and data changes. Understanding and manipulating the DOM using JavaScript is essential for creating dynamic and interactive web applications. By learning how to access and modify HTML elements, you can make your web pages responsive and engaging, providing a better user experience. Imagine the Document Object Model, or DOM, as the interactive blueprint of a web page. Just like you can rearrange rooms and furniture in a house, you can manipulate the elements of a web page using JavaScript to create dynamic and responsive user experiences. In this video, we will demonstrate how to manipulate the DOM using JavaScript. You will learn how to change, add, and remove content on a web page using JavaScript. Even if you've never done this before, don't worry, we'll walk through everything step by step. The Document Object Model, or DOM, is a representation of your web page that JavaScript can interact with. Think of the DOM as a tree of objects. Each element in your HTML becomes a node in this tree. For example, your paragraphs, headers, images, and even the document itself are all nodes. Manipulating the DOM is essential for creating interactive and dynamic web applications. It allows you to change the content, structure, and style of web pages in response to user actions and other events, enhancing the user experience. So how do we access the DOM using JavaScript? We use something called the document object. This object represents the entire HTML document. From here, we can access any element in the DOM. If there isn't an existing web page, you must first create a basic HTML structure with a header and a paragraph to serve as a starting point. For instance, you could type the following code. Doctype HTML, HTML lang equals open quotation ing, English, en, close quotation. Head, meta charset equals open quotation UTF-8, close quotation. Meta tag equals viewport, close quotation. Content equals open quotation with equals device hyphen with, comma, initial hyphen scale equals 1.0, close quotation. Then title, accessing the DOM, close title. Head, body, h1 ID equals header, original header, close h1 tag. PID equals intro, this is the introduction paragraphs, close paragraph. Close body, close HTML. Following the paragraph and before the body end tag, you can add a script tag to precede any JavaScript that you wish to enter, followed by an end script tag, as is shown on the screen. The script tag is generally added at the end of the body so elements are finished loading by the time the script runs. The first step in manipulating an existing DOM is to identify the specific parts of the web page that you would like to change. Let's get started with some simple and practical examples. Let's start with changing the content of an element. Suppose you have a paragraph with the ID intro and you want to change it to text. To manipulate the content, you would type document.getElementById, open parens, open quote, intro, close parens,
text content equals open quote, hello comma world, exclamation point, close quote, semicolon. Suppose you want to change the background color of a div with the ID container. You can do this by using the style property. Type document.getElementById, open parent, open quote, container, close quote, close parent, dot style, background color, equal, open quote, light blue, close quote, close parent, semicolon, as shown in the example. This code selects the div with the ID container and changes its background color to light blue. Another cool thing that you can do with JavaScript in the DOM is to automate a change to a web page when something happens, such as clicks, mouse overs, and key presses. This is called using event listeners. Suppose you have a button with the ID My Button, and you want to show an alert when it's clicked. Here's how you can do it. Type document.getElementById, open parent, open quote, My Button, close quote, close parent, dot, add event listener, open parent, open quote, click, close quote, comma, function, open parent, close parent, open curly bracket, alert, open parent, open quotation, button was clicked, exclamation point, close quotation, close parentheses, semicolon, close bracket, close parentheses, semicolon, as shown on the screen. This code adds an event listener to the button. When the button is clicked, the alert message, button was clicked, is shown. Sometimes you need to stop an element from responding to events. Here's how to remove event listeners. Type button.remove event listener, open parent, open quote, click, close quote, comma, handle, click, close parents, semicolon. Now, if you click the button, nothing will happen because the event listener has been removed. Note that you must use the same function, handle click, to add and remove users. Let's walk through a real-world scenario when Contoso is developing an interactive dashboard for their web application. Contoso wants to use DOM manipulation to update content dynamically. The first step is to access the elements that need to be updated, such as the header and information sections. Contoso uses document.getElementById to target these elements, as is shown on the screen. In this example, we access the header and information sections by their IDs, making it easy to update them later. Next, Contoso modifies these elements, text content, and attributes to display real-time data. This ensures the dashboard always shows the latest information. Here, as you can see in the example, the header text has been updated to Contoso Dashboard, and the information section now displays current data, 42 new alerts. To make the dashboard more interactive, Contoso adds new elements, such as data points or alerts, using document.createElement and append child. In this example, a new paragraph element is created to show new data point, 100 users online, and it's added to the information section. This allows Contoso to add new data to the dashboard dynamically. By following these steps, Contoso creates a dynamic and interactive dashboard that updates in real time based on user interactions and data changes. Manipulating the DOM using JavaScript involves selecting elements, changing their content and attributes, and responding to user events. By mastering these techniques, you can create dynamic and interactive web applications that enhance user experience.
Before we can use JavaScript to manipulate elements on a web page, we need a basic HTML structure. HTML, or Hypertext Markup Language, is the building block of the web, and JavaScript works alongside it by making the content dynamic. In this step, we'll create a simple HTML page, add some placeholders such as a heading and a paragraph that we will later manipulate with JavaScript. First, define the document type declaration for HTML5. Next, declare the language attribute, which in this case will be EN for English. Now define the character encoding. Now we need to set the viewport for responsive design. Now we need to define the title of the document, which is going to be DOM Manipulation Lab. Now we need to define the ID for the H1 tag that we will later be manipulating. And then we're going to define the text content for this tag. We're going to write welcome to the DOM Manipulation Lab. And then we're going to define the ID for the paragraph tag that we're later going to manipulate and define the text for that P tag. Here we're going to put, this is a paragraph we will modify using JavaScript. All right, let's check how our code renders by clicking the top right corner. And you see we've got the title and then the text that we will later manipulate. Now that we have this HTML structure, we can begin using elements and manipulating them with JavaScript. The Document Object Model, or DOM, allows us to access and manipulate these elements programmatically. First, let's select the H1 element using its ID. Now, let's select the P element using the Query Selector method. Once we have selected our elements, we can use JavaScript to change their content and appearance. The text content property allows us to change the variable text inside an HTML element. Additionally, we can change the appearance of elements by modifying their CSS properties directly through JavaScript, such as changing size, color, or visibility. First, let's change the text content of the H1 element. We're going to change it to welcome to the updated DOM lab. Now let's change the text content of the P element to this paragraph content has been changed. Finally, let's change the style of the heading to modify its color. Now let's push the button in the top right corner to see how our code renders. And you see we've got different title in a different color and the body of the text has been changed. Now let's add listening events. JavaScript makes web pages interactive through event listeners. Event listeners allow us to define actions that will occur when a specific event happens, such as a button click or a form submission. In this step, we're going to use JavaScript to add a button to the HTML and add an event listener to JavaScript to change the text content of the paragraph when the button is clicked. Define the button's ID as Change Text Button and label the button. Now we want to select the button using its ID. Now we want to define the event that triggers the action, which here would be using click. And now we want to change the paragraph's content to say you click the button with an exclamation point. And we click the button in the top right corner to see how the code renders. As you can see here, welcome to the updated DOM lab, paragraph content has been changed, and you've got a box for changing the text. We can also make our web page respond dynamically to user input. For example, we can use an input field to collect text from the user and update the page in real time based on what they enter. This is a common technique in forms or search bars where input is displayed or processed immediately. In this step, we're going to create an input field and a submit button. When users enter text and clicks the button, the paragraph will update to display the entered text. First, define the input field's ID as user input. Now, we want to define the button's ID as submit button. Next, we're going to select the input field by its ID, user input. We're going to select the button by its ID, submit button. We're going to define the event type, click to listen for. We're going to get the value from the input field. And then we're going to update the paragraph with user input. We select the button at the top right corner to run the code, and you see paragraph content has been changed, and we've got the boxes for data to go into. Great job completing this guided lab.
If you've ever wondered how to write cleaner, more efficient code, the answer is functions. They help you organize your code into reusable blocks, making your programs more powerful and flexible. In this video, we will describe the concept of functions in JavaScript. A function is a reusable block of code designed to perform a specific task. By encapsulating logic into self-contained units, functions help organize code, making it more readable and maintainable. Functions are useful because they promote code reuse, improve readability, and make debugging easier. By breaking down complex problems into smaller, manageable pieces, functions help organize and maintain code efficiency. Let's examine how we can create a function. The first way to create a function is through a function declaration. A function declaration defines a named function using the function keyword. Here's the syntax for declaring a function. Function, greet, open and close parentheses, open and close curly brackets, console log hello world. In this example, greet is the function's name and console.log hello world is the function's body. To use this function, we simply call it by its name followed by parentheses. Next, let's examine function expressions. A function expression is a function that is assigned to a variable. This lets you store the function and use it later, like any other value. It's useful when you want to pass a function to other parts of your code, store it in a data structure, or define it only when it's needed. Here's an example of the syntax for a function expression. Const greet equals function, open curly brace, console log hello world, close curly brace. In this example, the variable greet holds the function that returns hello world to the console. Notice that the function doesn't have a name in its declaration because the variable holds the function. We can call this function by using the variable name with the parentheses. Another commonly used type of function is an arrow function. Arrow functions offer a more concise syntax for writing function expressions. They are especially useful for shorter functions. Here's how you can write a function using the arrow syntax. Const greet equals open and close parentheses, arrow, console.log hello world. In this example, we tell JavaScript to make the greet variable a function by making it equal to the open and close parentheses, and then we use the arrow, an equal sign and greater than symbol together, to define what should happen when the function is called. The arrow points to the output in a sense. In this example, calling greet still prints hello world to the console. But because that's all we need the function to do, we use an arrow function because it's simpler to write and to read. Let's apply these concepts and see how code crafters, a coding bootcamp, could use them. Let's examine how they could use the function declarations, function expressions, and arrow functions to manage and organize their course materials and learning activities efficiently. At Code Crafters, a function declaration could be used to create reusable functions for common tasks, such as fetching course data. In this function, the developers define the function name as fetch course data and pass the course ID to the function. They can then add code to use the ID to fetch the course data from that particular course ID from a database. To use this function, Code Crafters calls it by name, followed by parentheses with the following syntax. Fetch course data, open parentheses, 101, close parentheses. The output is fetching data for course ID 101. Code Crafters can use function expressions for tasks that require more complex logic. These functions are assigned to variables for better control. In this example, the function could process course data and output a result or save information to a database. This approach allows them to manage more sophisticated operations while keeping the code organized and modular. Arrow functions offer a more concise syntax and are used by code crafters for quick operations, like filtering or mapping data, as in this example. Arrow functions simplify the code, making it easier to read and maintain. In this video, we explored the concepts of functions in JavaScript, including function declarations, function expressions, and arrow functions. Understanding these concepts is crucial for writing organized and reusable code in modern web development.
If you've ever wondered how JavaScript keeps track of where your variables live and why some seem to disappear when you need them most, it is helpful to understand scope. Scope is like a boundary wall that decides what parts of your code can see and use certain variables. In this video, we will describe the concepts of scope in JavaScript. Scope in JavaScript refers to the context in which variables are accessible. Scope determines where a variable can be used in your code and how long it remains available. Understanding scope helps you write efficient and error-free programs. There are three main types of scope in JavaScript: global scope, function scope, and block scope. Scope is significant because it helps prevent variable conflicts and reduces the chances of errors by controlling where variables can be accessed and modified. It It is essential for maintaining clean and organized code. Let's examine the different types of scope and how each is used. First, a variable declared in the global scope is accessible from anywhere in your JavaScript code. These variables are typically declared outside of any function or block. Here's the syntax for an example of global scope. In this example, global variable is declared in the global scope, so it's accessible both inside and outside the show global variable function. Next, variables declared inside a function are in the function scope. They can only be accessed and modified within that function. This helps to avoid conflicts between variables and keeps the function's variables contained. Here's the syntax for an example of function scope. In this case, function variable is only accessible within the showFunctionScope function. Attempting to access it outside the function results in an error. Finally, block scope applies to variables declared within a pair of curly braces using let or const. These variables are only accessible within that block. Here's the syntax for an example of block scope. Here, block variable is only accessible within the block where it was declared. Trying to access it outside the block results in an error. Let's see how scope affects the behavior of functions and variables in JavaScript. In this example, the message variable is declared both globally and within the changeMessage function. The message inside the function is different from the global message, demonstrating how function scope creates a separate context for variables. Let's apply these concepts to Dev Masters, a coding boot camp. How could they use scope to manage variables in their learning platform efficiently? Shared variables, like user settings and themes, are stored in the global scope for easy access across different modules. Functions handling specific tasks, such as user authentication, use function scope to keep variables contained and prevent conflicts. Block scope is used within loops and conditionals to ensure variables are only accessible where needed, enhancing code readability and maintainability. In this video, we've explored the concepts of scope in JavaScript, including global scope, function scope, and block scope. Understanding scope helps in managing variable visibility and lifetime, ensuring clean and efficient code. Understanding scope is crucial for writing effective and error-free JavaScript code. By managing scope properly, you can avoid naming conflicts and unintended side effects in your programs. Imagine you're a chef in a bustling kitchen, juggling multiple orders at once. Some dishes need to simmer slowly, others require quick and precise attention, and some tasks can just be left to the side until the timing is just right. Without a system to manage all these tasks, the kitchen will descend into chaos. Asynchronous programming in JavaScript is like that system in a kitchen. It ensures that your code can handle multiple tasks efficiently without everything coming to a halt. Let's explore how asynchronous programming keeps everything running smoothly. In this video, we will explain the principles of asynchronous programming in JavaScript. Asynchronous programming is a technique that allows tasks to run concurrently, meaning they don't block the main program flow. This is essential for creating responsive web applications that can handle multiple operations simultaneously. Asynchronous programming allows your program to start a potentially time-consuming task and move on to other tasks while waiting for the first one to complete. Tasks like fetching data from a server, reading files, or any other operation that might take some time, so asynchronous programming allows you to do something else and keep the project moving along. At the heart of JavaScript's asynchronous behavior is the event loop. JavaScript runs in a single threaded environment, meaning that it can execute only one task at a time. The event loop is a mechanism that helps JavaScript manage multiple tasks efficiently. Let's explore how the event loop works in JavaScript with a simple example. We'll use setTimeout to simulate asynchronous tasks and see how the event loop manages them. Here's the code we'll be using to demonstrate the event loop. This simple example illustrates how the event loop handles asynchronous tasks in JavaScript. Although we set a delay of 0 milliseconds to set timeout, the callback function is executed only after the main code execution is complete. This demonstrates that JavaScript does not immediately execute the set timeout callback, but places it in the event queue. Now, let's examine callbacks. Callbacks are one of the fundamental ways to handle asynchronous tasks in JavaScript. A callback is a function passed as an argument to another function, which is then executed once a synchronous operation is complete. Let's explore how callbacks work in JavaScript with a simple example. Here's the code we will be using. Let's take a closer look at the code and what each component does. In the example, fetch data, handle data, initiates an asynchronous operation with a delay of 2 seconds. However, it doesn't block the execution of the subsequent code. Console.log, this log appears before the data is fetched. This message is logged immediately after fetch data is called, demonstrating that JavaScript continues executing code even while waiting for the asynchronous operation to complete. Cell timeout. After a 2-second delay, the callback function handle data is called with the data, resulting in the message, "Here is your data," being logged. When you run the code, you'll see the following output, fetching data, ... This log appears before the data is fetched. Here is your data. This output sequence clearly shows that JavaScript doesn't wait for set timeout to finish before moving on to the next line. Instead, it logs fetching data, ... and this log appears before the data is fetched immediately, and then here's your data after the 2-second delay. This example effectively illustrates the non-blocking nature of asynchronous programming in JavaScript, where operations like network requests for timers can run in the background while the main thread continues executing other code. Callbacks do have some limitations, however. To address the limitations of callbacks, JavaScript introduced promises. A promise represents a value that may be available now or in the future or never. It allows you to chain asynchronous operations more elegantly. Promises simplify handling asynchronous operations by providing a cleaner, more readable syntax. Let's review an example of how promises work in JavaScript. In this example, fetch data returns a promise. If the data fetching is successful, the resolve function is called, and we handle the result with that. If there's an error, reject is called, and we handle it with catch. To make asynchronous code look more like synchronous code, JavaScript introduced async and wait. These keywords make your code easier to read and understand. The async/await syntax allows writing asynchronous code that looks synchronous, making it easier to read and maintain. The async keyword is used to define an asynchronous function, and await is used to wait for a promise to resolve. In this example, the fetch data function returns a promise, just like before. But now, handle data is an async function, which allows us to use await to pause execution until the promise is resolved or rejected. This makes the code more readable and easier to manage. In this video, we've explored the principles of asynchronous programming in JavaScript, including the event loop, callbacks, promises, and async/await. Understanding these concepts is crucial for writing efficient, non-blocking code in modern web development. Asynchronous operations are a key part of modern web development, allowing tasks to be run without interrupting the flow of your application. By using async/await in JavaScript, you can handle these operations with clean, readable code. Async/await simplifies the process of managing asynchronous tasks, making your code behave more predictably and ensuring it is easier to maintain. In this video, we will describe how to use async/await to handle asynchronous tasks in JavaScript. Asynchronous operations are tasks that do not block the execution of other operations while they complete. They allow other tasks to run simultaneously, which is crucial in web development for efficient performance and responsiveness. Async/await is significant for several reasons. First, it simplifies writing and managing asynchronous code, making it more readable. Next, it allows your code to continue executing other tasks while waiting for an asynchronous operation to complete, like fetching data from an API. Finally, this leads to cleaner, more efficient code that is easier to understand and maintain. The async keyword is used to define an asynchronous function, and the await keyword is used to wait for a promise to resolve within an async function. Promises represent a value that may be available now or in the future or never. It allows you to chain asynchronous operations. While promises are powerful, they can sometimes make our code hard to read, especially with multiple asynchronous operations. This is where async/await comes in. It allows us to write asynchronous code that appears and behaves more like synchronous code. In JavaScript, when you need to perform time-consuming tasks like fetching data from the internet, it's best to use asynchronous code. The async/await syntax allows us to write cleaner and more understandable code when working with these asynchronous operations. Here's a single example of an asynchronous function called fetch data. Let's break it down step by step. First, we use the async keyword, making the function asynchronous. Next, we return a promise, a special object in JavaScript that represents a task that will complete in the future. Then we use setTimeout to simulate a 2-second delay, mimicking delay fetching. Finally, after the delay, we return a user object with the name John Doe using resolve. This is how we create a promise in JavaScript. Let's examine how await keywords work in JavaScript and why it's such a powerful tool when working with asynchronous code. Here, we're using the await keyword before calling the fetch data function. But what does this mean and why is it important? Pause and wait. The await keyword tells JavaScript to pause the execution of the getData function until the promise returned by fetchData open close parens is resolved. Synchronous-like behavior. This makes our asynchronous function behave as if it were synchronous. It allows us to write code that appears to be running in a straight line, making it much easier to read and understand. Simplified code. With await, you don't have to chain .then parents methods like in traditional promise-based code. This results in cleaner, more readable code. Now, let's convert a more complex promise-based example to use async/await. Imagine we have two asynchronous tasks, fetching user data and then fetching their posts. If we convert the promise to async await, the code reads as shown on the screen now. In the async/await version, our code is cleaner and easier to read. The display user and post functions handles both tasks in a straightforward manner. Using async/await makes handling errors easier. To do this, we can try catch blocks. If something goes wrong in our asynchronous code, the catch block fixes the error. This makes it simpler and more intuitive to manage errors. In this example, we're demonstrating how to handle errors using async/await. First, we define an async function called fetchDataWithError. This function returns a promise, which after a delay of 2 seconds will automatically fail with an error message, "Something went wrong." Next, we have another async function called getDataWithErrorHandling. Inside this function, we use a try catch block to handle potential errors. The try catch block attempts to await the result of fetchDataWithError. If everything works fine, it will log the result to the console. However, since the promise is designed to fail, the catch block is triggered, capturing the error and logging it to the console with the message, "Error, something went wrong." Finally, we call the getDataWithErrorHandling function. As a result, instead of the data, the error is caught and handled, making it clear how async/await can simplify error management. This explanation examines the code step by step, emphasizing how the error is caught and managed by using the try catch block with async/await. In this video, we've explored how to use async/await to handle asynchronous tasks in JavaScript, including converting promise-based code and handling errors. Understanding these techniques is crucial for writing efficient and readable asynchronous code in modern web development. JavaScript design patterns provide proven solutions to common problems, helping developers write clean, organized, and maintainable code. The module pattern, observer pattern, and singleton pattern are three popular patterns that streamline how you structure code, manage communication between components, and control instance creation in your applications. By mastering these patterns, you can write more efficient and scalable JavaScript. In this video, you will identify advanced JavaScript concepts and techniques related to common design patterns. A JavaScript design pattern is a reusable solution to a commonly occurring problem within the given context in software design. Design patterns are useful for several reasons. First, they offer proven solutions to common coding problems. Second, they improve code readability, making it easier for developers to understand and work with your code. Third, design patterns facilitate communication among developers by providing a common language. They also help you organize and structure your code. Finally, they ensure that your code remains maintainable and scalable as your project grows. JavaScript design patterns are reusable solutions to common problems in software design. They help in structuring your code in a way that is maintainable, scalable, and efficient. Today we'll explore three fundamental design patterns: the module pattern, the observer pattern, and the singleton pattern. The module pattern helps keep your code base clean by encapsulating private variables and functions, allowing you to reuse code efficiently across your application. Now that we've organized our code within modules, let's explore the observer pattern, which is essential for managing communication between different parts of your application. In this screen, we're going to explore the module pattern in JavaScript, a design pattern used to create encapsulated code. It helps keep certain data and functionality private while exposing only what's necessary. Let's break down the code. First, notice that we've wrapped everything inside an immediately invoked function expression, or IFE, which is the function enclosed in parentheses, followed by another set of parentheses. This makes sure the function is executed right away, allowing us to declare variables and functions inside without polluting the global scope. Inside this function, we have a private variable called private variable and a private function named private function, open close parentheses. These are kept hidden from the outside world because they're not exposed to the return statement. However, we want to make some functionality accessible publicly. To do that, we return an object that contains a public function called public function open close parens. This public function calls the private function, which in turn logs the private variable to the console. Here's the code used to execute. The output will be I am private. This indicates that the public function can access the private function and private variable, but that the private elements can't be accessed directly from outside the module. For example, calling my module private function open close parens will throw an error since the private function is not returned to the main scope. Now, let's examine another type of pattern. The observer pattern is useful when you need to keep multiple parts of your application updated. Think of it as a way to notify all observers whenever something changes in your app, making it perfect for handling most events across different parts of your system. The observer pattern helps manage communication between multiple observers, ensuring they react simultaneously to changes. In this pattern, an object called the subject maintains a list of dependents called observers that are notified of any state changes. Let's break down the code in this example. Here, we have a horn class, which acts as our subject. It keeps a list of observers, in this case workers. We define three key methods: subscribe, open close parens. This method allows us to add workers to the list of observers, meaning they'll be notified when the horn blows. Unsubscribe, open close parents. This removes the worker from the list so they no longer receive notifications. Blow horn, open close parents. This triggers a notification to all subscribed workers telling them it's lunchtime by calling their lunchtime open close parents method. Next, we have the worker class, which acts as an observer. Each worker has a lunchtime open close parents method that gets called when the horn blows, as is depicted in the code. When we call factory horn.blowhorn open close parents, all subscribed workers are notified because they are observers of the horn subject. Now let's observe what happens when we unsubscribe worker 2. The output is horn, time for lunch. Worker 1, time for lunch. Worker 3, time for lunch. Worker 2 is no longer receiving notifications because we unsubscribed them. This demonstrates how observers can be added or removed dynamically. The final pattern we are going to examine is the singleton pattern. Imagine you have a manager in charge of coordinating all tasks in an office. The singleton pattern works the same way. It makes sure there's only one instance of a class, like having just one manager, and gives you a single, easy way to access it whenever needed. For example, think of a game. There must only be one instance of a clock to measure the time, and thus it should be a singleton. Let's apply this concept to our factory lunch worker scenario. We'll create a singleton for the horn class to ensure there's only one horn in the factory that signals lunchtime. Here's an example of the syntax used in a singleton pattern. In this code, we'll check if an instance of the horn class already exists using horn.instance. If an instance exists, we return that instance to ensure no new instances of the class are created. Otherwise, we proceed with creating the instance and storing it in horn.instance. Now, every time we try to create a new instance of the horn class, we'll actually just get a reference to the existing instance. Here, we have set up the worker class. When we blow the horn, the output will be horn, time for lunch. Worker 1, time for lunch. Worker 2, time for lunch. Here's what happens if we try to create another horn instance. When we compare factory horn 1 and factory horn 2, the result is the same. This proves that both factory horn 1 and factory horn 2 refer to the same singleton instance. The singleton pattern ensures a class has only one instance and provides global access to it. In our factory lunch worker scenario, this pattern is useful to ensure there's only one horn signaling lunchtime, preventing confusion and ensuring that all workers are coordinated through a single source of truth. In this video, we explored 3 essential JavaScript design patterns. First, the module pattern, which organizes your code into self-contained, reusable blocks. Next, the observer pattern, which manages communication between different parts of your application. Finally, the singleton pattern, which ensures a single instance of a class coordinates actions across your system. Give these patterns a try in your own JavaScript projects. The more you practice, the better you'll understand how they can help you write cleaner, more efficient code that's easier to manage. Imagine you're building a web application that needs to communicate with a server to fetch user data. Without a structured way to handle this data, your app could quickly become a tangled mess of information. This is where JSON, or JavaScript Object Notation, comes in, helping you keep your data organized and your application running smoothly. Just like a well-organized filing system keeps your documents in order, JSON allows you to structure and manage data seamlessly in your web applications. In this video, we will describe how to manage data using JSON and JavaScript. JSON, or JavaScript Object Notation, is a lightweight data format used for storing and transporting data. It is easy for humans to read and write, and easy for machines to parse and generate. JSON is often used in web development to transmit data between a server and a web application.
JSON data is represented as key value pairs. Let's break down the basic syntax of JSON. JSON data is represented as key value pairs, and here's what that looks like in code. In this example, name, age, and city are the keys, and Alice, 25, and New York are their corresponding values. JSON is crucial in web development because it enables seamless communication between different systems and ensures efficient, straightforward data exchange between servers and clients. This is essential for tasks such as fetching data from APIs and storing data locally, making JSON a very effective tool for creating dynamic and interactive web applications. Parsing JSON means converting JSON data into a JavaScript object, which you can then use in your application. This can be achieved using the JSON parse open close parens method. Suppose we have the following JSON string, as you see on the screen. To parse this JSON string into a JavaScript object, we use the JSON parse open close parentheses method. Let JSON object equal JSON.parse, open parens JSON string, close parens, semicolon, console.log, open parens JSON object, close parens, semicolon. The JSON object now contains the parsed data, and you can access its properties like this, as you see on the screen. Just as we convert JSON data into JavaScript object using JSON parse, open close parentheses, we can also convert a JavaScript object into a JSON string using JSON.stringify, open close parentheses. Let's explore how this works. This is useful when you need to send data from a client to a server in JSON format. For example, Nature Nurture, a company dedicated to eco-friendly personal care products, might need to send customer order information as a JSON string to their server for processing. Here's an example. We start with this JavaScript object. Notice how it is similar but a bit different. In a JavaScript object, the keys don't use quotes. In JSON, they do. To convert this object to a JSON string, we use the JSON.stringify open close parentheses method. Let JSON string equals JSON.stringify open parens person close parens semicolon console.log open parens JSON string close parens semicolon. The JSON string now contains the JSON formatted data, as you see here on the screen. Name, Bob, age, 30, city, Chicago. See the quotes? Let's examine some of the most common scenarios where JSON plays a critical role in web development. These include fetching data from APIs, storing data locally, and managing configuration files, all of which are essential for creating dynamic and interactive web applications. Let's explore a real-world example to discover how these concepts come to life. Imagine Nature Nurture, a company dedicated to eco-friendly personal care products, uses JSON to manage its data. JSON is often used for fetching data from APIs. APIs frequently return data in JSON format, which can be parsed and used in JavaScript applications. Nature Nurture fetches product data from suppliers' APIs. This data is returned in JSON format and parsed into JavaScript objects for use on their website. Another task JSON is used for is storing data locally. JSON can be used to store data in local storage or database in a structured format. Nature Nurture stores customer preferences and order history in JSON format in the browser's local storage, allowing for quick access and updates. Finally, JSON is commonly used for configuration files due to its simplicity and readability. Nature Nurture stores website configuration settings, such as theme preferences and user settings, in JSON format for easy modification and readability. In this video, we've explored how to manage data using JSON and JavaScript, including parsing JSON strings into objects and converting objects to JSON strings. Understanding these techniques is crucial for effective data management in web development.
In this lab, we're going to implement some common JavaScript design patterns in a web application. Let's begin by starting up your environment. First, let's enter the correct doc type declaration to specify HTML5. Then we want to set the language attribute. Now we want to add the character encoding. Now we need to set the viewport for responsive design. Now we want to enter the title for our web page. We're going to call this page JavaScript Design Patterns Lab. Now we're going to link the CSS file, add a heading to the page. Again, we're going to use JavaScript Design Patterns in Action for this. Add an ID to the output container, and then link the JavaScript file to the HTML document. Next, we'll learn how to keep code organized by using the module pattern to encapsulate variables and functions. First, we need to initialize the result variable to 0. Now we're going to add the value to the result using plus and equals. Now we're going to call the display result function. Next, we're going to subtract the value using minus and equals. Set the ID to output to target the correct HTML element. And now we're going to display our result in the string, and then expose the add function publicly. And now expose the subtraction function publicly. And then we're going to add the test code for subtracting 5. Next, let's implement the observer pattern, which helps manage communication between different parts of an application. We need to initialize the observers list as an empty array. Now we need to use push to add an observer to the list. Now we need to identify the observer to unsubscribe. Now we need to call the update method on each observer. Now we need to store the name of the observer. Now we need to display the observer's name in the notification. Now we need to add the test code at the very bottom of this document. Now we've got more test code to add. And another line of test code. Another line of test code on line 33, followed by another line of test code, and one final line of test code. Now we're going to use the singleton pattern to guarantee that only one instance of a class exists at a time. You're going to check if an instance already exists by using settings.instance. Return the existing instance. Now you're going to initialize this configuration as an empty object. You're going to store the new instance. Now you're going to set and get configuration values using key value pairs. And do the same here. Now we're going to add some test code at the bottom of the page, starting on line 20. Next for line 21. Then we're going to have test code for line 23. Line 24, and line 25. Great job completing this guided lab.
JSON, or JavaScript Object Notation, is a widely used data format for transmitting and storing information in web development. Its lightweight and language-independent nature make it an ideal choice for exchanging data between systems. In web applications, JSON is often used to communicate between servers and clients, especially in APIs, where it helps structure data in an organized and readable way. In this video, we will identify advanced JavaScript concepts and techniques related to JSON. JSON, or JavaScript Object Notation, is a lightweight data format for storing and transporting data. It is easy for humans to read and write and easy for machines to parse and generate. Despite its name, JSON is language independent, making it a popular choice for data exchange across different programming languages. JSON is widely used to transmit data between a server and a web application. It is especially prevalent in APIs, application programming interfaces, where it allows different systems to communicate by exchanging data in a structured format. JSON's simplicity and flexibility have made it a de facto standard for data exchange on the web. For example, a web server can have an API with a function to serve the students on a course. It can serve the students' data in a JSON document, which can be invoked from a JavaScript app or other programming languages.
JSON data is structured as key value pairs. The two primary structures are objects and arrays. Before we get to the technical definition of what objects or arrays are, the difference between them is fairly simple. An object is a collection of key value pairs enclosed in curly braces. An array is an ordered list of values enclosed in square brackets. Now let's look at the technical definitions of each and learn how they are used. A JSON object is a collection of key/value pairs. Each key is a string enclosed in double quotes, followed by a colon and the corresponding value. The value can be a string, number, boolean, null, another JSON object, or an array. Here's an example of a JSON object on the screen. In this example, the keys are name, age, is student, and address. The values are John Doe, 30, false, and another JSON object representing the address. A JSON array is an ordered list of values. Values can be any type, including objects and other arrays. Each value can be a string, number, boolean, null, JSON object, or another array. Here's an example of a JSON array. As you see, open bracket with 3 types of fruit in quotation marks, apple, banana, cherry, close bracket. Arrays can also contain objects, creating complex data structures. On the screen is an example of an array of objects. This JSON array could represent a list of users with their age. The syntax of JSON includes curly braces for objects, square brackets for arrays, colons to separate keys and values, and commas to separate pairs and values. JSON values can be strings, such as hello world, numbers, such as 42, booleans, such as true or false, null, such as null, objects, such as key or value, or arrays, such as value 1, value 2. JSON can represent complex data structures by nesting objects and arrays within each other. Here's an example of how JSON could be used in a complex data structure. In this example, the outer object represents the university. It contains nested objects for location and departments. Each department is an object within an array, with its own nested objects for courses. Parsing JSON involves converting a JSON string into a data structure that your programming language can work with, such as an array or an object. It is common to parse JSON in different programming languages, such as JavaScript, Python, and Java. In JavaScript, you can use the JSON parse, open close parentheses method, to parse a JSON string into an object. Once parsed, the data could be filtered, processed, analyzed, or used to fill out forms or create dynamic HTML content, such as a personalized web page. Let's apply these concepts to GroovyCo, a startup focused on sustainable living products, and see how they could use JSON to manage their product data and customer information. GroovyCo needs to store information about each product, including the name, category, price, stock status, and product description. JSON allows them to structure this data in an organized and easily accessible way. When a customer views a product on GroovyCo's website, the application can parse the JSON data to display the product details. GroovyCo also needs to manage customer information, including names, contact details, and purchase history. JSON can help store this data in a structured way, enabling easy access and manipulation. In this video, we've explored advanced JavaScript concepts and techniques related to JSON, including its structure, syntax, and how to represent complex data structures. Understanding these concepts is crucial for effective data management and interchange in modern web development.
Imagine trying to read a book written in a different language and without any translation. JavaScript Object Notation, or JSON, helps us bridge that gap in web development, making data readable and usable. In this video, we will focus on how to manipulate JSON data using JavaScript to enhance your web development skills.
We'll cover techniques like parsing JSON strings into objects and converting JavaScript objects to JSON strings, which are crucial skills for efficient data handling in web development. In this video, we will explore how to manipulate JSON data using JavaScript. JSON is used for storing and transporting data. It is easy for humans to read and write, and easy for machines to parse and generate. The format is commonly used in web development for data exchange between a server and a client. JavaScript provides two main methods for working with JSON: parse and stringify. Let's explore each method with practical examples. Begin by opening a text editor like Visual Studio Code, Atom, Sublime Text, or IDE like WebStorm. For this example, I will be using Visual Studio Code. Click New File and save it as json-example.js. Parsing JSON data in JavaScript involves converting a JSON string into a JavaScript object. Let's examine how parsing works. Copy the code shown into your editor. In this example, let JSON object equals JSON parse open parens JSON string close parens will convert the JSON string to a JavaScript object. JSON parse open parens JSON string converts a JSON string into a JavaScript object. Console log JSON object prints the converted object to the console, displaying its structure. Now, run this command in the terminal to parse. Open the terminal and type node space json-example.js, then press enter. The command will run the file and convert the JSON string into a JSON object in the console. Next, let's explore how to convert a JavaScript object into a JSON string using JSON stringify. Start by creating a new file and saving it as json-example2.js. Now copy the code shown for a JSON object into your VS Code file. Note that the variable JSON string is enclosed with quotes, so it is seen as a string and needs the JSON parse function to convert it into a JavaScript object, whereas the variable student above is enclosed with curly braces, so it is an object. To convert this JSON object into a JSON string, open the terminal and type node space json-example2.js and press enter. This example confirms that both JSON parse and stringify operations are running correctly. In this video, we've explored how to manipulate JSON data using JavaScript, including parsing JSON strings into objects and converting objects to JSON strings. Understanding these techniques is crucial for efficient data handling in web development. In this lab, you will learn how to work with JSON data using JavaScript. Let's begin by fetching JSON data from the public API. This is essential for building dynamic web applications that retrieve data from external services. So first, we start by specifying the document type to indicate HTML5. We set our language attribute to English. We add the character encoding. We set our viewport meta tag for responsiveness. We set the title of the page. We're going to call this one Working with JSON. Now we're going to add a heading for the users list, and we'll simply call that users list. And then we're going to assign the ID users container to the div. And now we're going to link the JavaScript file to the HTML. For our next steps, we're going to add the API URL. Now we're going to use the method to convert JSON, the response to JSON. And then we're going to enter the command to log the fetch data in the console. And then we're going to log an error message if the request fails. Now we're going to select the button at the top right to click to run the code, and you get your users list, and the console will display the list of users returned from the API. When working with JSON data, it often comes as a string, so we're going to use the JSON parse method to convert it into a JavaScript object or array. First, we need to provide the name Alice for the first user here. We're going to assign the age of 25. And then we're going to set the name Bob for the second user. and make Bob 30. Now we're going to use JSON parse to convert the string to a JavaScript object. And now we assign the user's first name to the JSON string, access the name property of the first user, access the second person in the array, and access the age property. Select the button at the top right to run the code, and in the console you will see how the data is converted into a JavaScript object. To send data to a server or store it locally, we have to convert JavaScript objects to JSON strings using Stringify. So let's do that here. First, let's set the name to Charlie. Now we're going to set the age to 28, and we're going to set isActive to true. Then we're going to use the JSON Stringify to convert the object. And then we're going to log the JSON string to the console. And then we select the button at the top right to run the code. And again, you get your information will show up in your terminal. Now we're going to dynamically update the web page using JSON data fetched from the API. This allows the content to change based on data received from external resources. First, we add the API endpoint URL. Now we're going to use the method to parse the response as JSON. Now we need to get the div element with the user's ID, user's container. Next, we're going to create a new P element. Now we're going to set the text content to display the user's name and email. So we got user's name, and then we're going to make user email. And now we're going to append the new element to the container and log the error message in case of a fetch failure. Now we select the button at the top right to run the code, and here you see your users list and their emails that are dynamically retrieved from the API. In many applications, we need to store data locally in the browser using local storage. This allows the data to persist even after refreshing the page. So let's see how that works. First, we want to set the theme to dark. I'm going to set our language to English. I'm going to use user settings as the key for storing settings. And then we're going to use JSON Stringify to convert the objects to a string. Now we're going to use JSON parse to retrieve the object from local storage. Now we're going to use local storage get item under user settings. And then add user settings as the key for storing the settings. Now we're going to log the value of theme to the console. And then we're going to log the value of language to the console. And then we select the button at the top right to run the code again. And we get our usernames and the emails.
As you've learned, mastering JavaScript is crucial for creating dynamic and responsive web applications. It ensures that you can deliver engaging user experiences and handle real-time data effectively. We began by exploring the foundational syntax and constructs of JavaScript, vital for developing responsive and interactive web pages. Then, we delved into mastering DOM manipulation, allowing you to dynamically modify the content and layout of web pages through JavaScript. Next, we explored the mechanisms of functions and scope in JavaScript, essential for crafting precise and efficient code that upholds state and performs as anticipated. After that, we delved into asynchronous programming in JavaScript, which boosts web application responsiveness by managing operations such as API calls without disrupting the user interface. Then, we embarked on a deeper exploration of advanced JavaScript techniques, providing you with the tools for intricate problem solving and enhancing web functionality. Finally, we examined how to manage data with JSON efficiently, emphasizing the interaction between JavaScript and data formats to store, retrieve, and share information online. Mastering JavaScript enhances web application responsiveness and user engagement, equipping you with advanced skills for handling real-time data and complex functionality. Git is an essential tool for managing changes in code, enabling developers to track their work and collaborate seamlessly on projects. By using basic commands, developers can stage, commit, push, and pull changes, ensuring smooth workflows and consistent version control. These commands form the backbone of Git, helping teams maintain an organized, stable code base while working together efficiently. In this video, we will explain the basic commands used in Git for version control. Git is a distributed version control system that helps developers manage changes to source code over time. Git enables multiple developers to work on a project simultaneously without overwriting each other's changes. Git is like a time machine for your code. It allows you to record snapshots of your project at different points in time. These snapshots, called commits, make it easy to track and manage changes. Understanding Git commands is crucial for managing project versions, collaborating with team members, and ensuring a smooth development workflow. Let's examine some core Git commands used for version control and how they help manage changes in a repository. First, the git add command is used to stage changes. Staging means preparing your changes for the next commit. Think of it as selecting the files you want to include in your next snapshot. For example, developers use git add to stage modified files before committing them to the repository. Here's an example of the syntax you would use for the git add command if you made changes to index.html and style.css to stage the changes for your next commit. Git space add space index.html. Git space add style.css. Next, the git commit command records the staged changes in the repository's history. A commit is essentially a saved version of your project. Type the following command to commit your changes along with a -m flag and a message contained in quotes that describes the changes. Git space commit space -m open quotation add changes to index and style files close quotation. Another useful command, git push, sends your committed changes from your local repository to a remote repository like GitHub. This is how you share your work with others or back it up. To push your changes, type git space push space origin space main. Here, origin refers to the remote repository and main is the branch you're pushing to. Then the git pull command updates your local repository and changes from the remote repository. This is useful when collaborating with others. To pull changes from the remote repository, type git space pull space origin space main. This fetches and merges changes from the remote main branch into your local branch. Finally, the git status command gives you a summary of the current state of your project. It shows which files are staged, unstaged, or untracked. To check the status, type git space status. This helps you understand what changes are staged for commit, what hasn't been staged, and what's untracked. Let's see how these commands work together in a typical Git workflow. First, we edit the index.html file and we run git space add space index.html to stage the changes. Next, we commit the changes using git space commit space -m space open quotation updated homepage layout close quotation. We then push the changes to the remote repository with git space push space origin space main. To ensure that we have the latest updates, we run git space pull space origin space main before starting new work. Throughout the process, we use git space status to check the state of our current working directory and staging area. Understanding and using basic Git commands is essential for effective version control. By mastering the git add, git commit, git push, git pull, and git status, you can efficiently manage changes in your repository and collaborate seamlessly with your team. Imagine working on a group project where everyone makes changes to a shared document. Without a system to manage those changes, important parts can be overwritten, contributions may be lost, and time wasted. This is where version control comes in. It's your safeguard against chaos. By keeping everything organized and trackable, version control ensures that whether you're a seasoned developer or just starting out, your projects are managed efficiently and collaboration with others becomes seamless. In this video, we will define the basic concepts of version control. Version control, also known as source control, is like a magical undo button for your entire project. It's a system that tracks changes to your files over time, allowing you to recall specific versions whenever needed. This makes it invaluable for collaboration and ensures that you can always revert if something goes wrong. Using version control systems is essential for 3 key reasons. First, it helps in managing code changes, ensuring that every modification is tracked. Second, it facilitates collaboration with team members, making it easier to work together without overriding each other's work. Finally, it maintains a detailed history of the project's development, so you can always look back and understand how your project has evolved. Having understood the importance of version control, let's now explore some of the fundamental concepts that form the backbone of how version control systems work. A repository, or repo, is like the central hub of your project, where all of your code and files are stored. Imagine it as a digital filing cabinet that not only holds your current work, but also keeps a detailed history of every change you've made. This makes it easy to track progress and revert to earlier versions if needed. For instance, the Innovate Tech repository holds everything from code files to documentation and tracks every change made along the way. Every time you make and save changes in your repository, you create a commit. A commit is like taking a snapshot of your project at the moment, letting you document and track changes as your project evolves. Developers also add messages to their commits to describe the changes made. For example, a developer at Innovate Tech commits changes to a file with a message, "Fixed login bug." A branch is like a parallel universe for your project, a separate version of your repository that allows you to develop new features or experiment without affecting the main code base. For example, you might create a branch to work on a new feature, ensuring the main project remains stable until your work is ready to be merged. Branches enable multiple developers to work on different features or fixes simultaneously. Working with branches, developers create, switch, and merge branches as needed. For example, Innovate Tech uses branches to develop new features without affecting the main code base. Once your work on a branch is complete, the next step is to bring those changes back to the main project. This process, known as merging, integrates your updates with the work done by others, ensuring everything comes together in a cohesive whole. Merging allows developers to combine their work into a single code base. During a merge, conflicts may arise if changes overlap, which need to be resolved manually. For example, Innovate Tech developers merge feature branches into the main branch after completing and testing their work. Understanding the difference between centralized and distributed version control systems is key to choosing the right tool for your projects. Let's explore these 2 approaches and see how they handle project management and collaboration differently. Centralized systems have several key characteristics. First, they rely on a single central repository where all changes in history are stored. Next, developers commit their changes to the central server, ensuring that everyone has access to the latest version from one single point. The primary advantages of centralized systems are twofold. First, they are simple to set up with all data in one place. Second, they require less disk space. However, centralized systems also have disadvantages, a single point of failure, and limited offline capabilities. In distributed version control systems, each developer has a full copy of the repository, including its entire history. This means that you can work offline and still have access to the project's history and changes. When you're ready to share your changes, you push them to a remote repository, and others can pull these changes into their own copies. Distributed systems offer several advantages.
First, there is no single point of failure. Second, they provide full offline capabilities. On the downside, they are more complex to set up and manage, and they may require more disk space for storage. Let's explore how Innovate Tech, a leading technology company, could use version control to manage their projects, collaborate effectively, and ensure high-quality releases. To manage the complexity of their projects and facilitate collaboration among their global development teams, they rely on Git, a distributed version control system. Let's dive into some specific examples of how Innovate Tech uses version control. When working in a distributed version control system, the process begins with each developer creating a new branch from the main branch, often called main or master, for the feature that they are working on. For example, when adding a new payment gateway to their e-commerce platform, a developer might start by creating a branch named feature/payment-gateway. As the developer progresses with the feature, they make commits to the branch. Each commit includes a message explaining the changes, which helps track the development process and explain the rationale behind each modification. Once the feature is complete, the developer opens a pull request, PR, to merge their branch into the main branch. The PR is reviewed by other team members who provide feedback and suggest improvements. This collaborative review process ensures code quality and helps catch potential issues early. After the PR is approved, the feature branch is merged into the main branch. The development team uses Git's merging capabilities to integrate the new feature, resolving any conflicts that may arise. Version control is essential for managing the complexities of modern software development. It ensures that every change made to a project is tracked, providing a clear history of updates and enabling collaboration across teams. By understanding the concepts of repositories, commits, branches, and merging, you can streamline your workflow and maintain an organized, reliable code base. Whether using centralized or distributed systems, version control is key to efficient project management, safeguarding your work, and supporting team collaboration. Efficient collaboration and maintaining a stable code base are important for any development team. Without a system to track and manage changes, projects can quickly become chaotic. Version control workflows help development teams ensure that the code base remains stable, the team collaborates effectively, and the project progresses smoothly. In this video, we will describe common version control workflows. A version control workflow is a set of guidelines and practices that a team follows to manage changes in a project. This ensures everyone's contribution can happen in an orderly way, whether you're fixing bugs, adding new features, or preparing for a release. Version control workflows help teams collaborate efficiently, maintain code quality, and streamline project management. By understanding different version control workflows, your team can pick the right approach for your project, making collaboration easier and managing versions more effectively. Let's explore some of the most common version control workflows and their advantages in collaborative development. First, the feature branch workflow is a common approach in version control where each new feature or task is developed in its own separate branch. This method is useful because it keeps your main code base stable while allowing for isolated development and testing of new features. The process for this workflow is as follows. First, when you start working on a new feature or bug fix, you create a new branch from the main branch, often called main or master. Next, you make your changes on this feature branch. This isolates your work from the main code base. Then, regularly commit your changes to the feature branch to track your progress. Next, once your feature is complete, open a pull request to merge your changes back into the main branch. Finally, team members review the pull request. After approval, the changes are merged into the main branch. The primary advantage of the feature branch workflow is that it isolates new features from the main code base. When you create a new branch for each feature, any changes you make are confined to that branch. This means that your main code base remains stable and unaffected by incomplete or experimental code. If something goes wrong, it won't impact the rest of your project, providing a safe space for development and experimentation. This workflow also simplifies the review process. Once you've completed work on a feature, you can open a pull request. This allows other team members to review your code, provide feedback, and suggest improvements before merging it into the main branch. The isolated nature of the feature branch makes it easier for reviewers to focus on specific changes, ensuring a thorough and effective review process. Lastly, the feature branch workflow allows multiple features to be developed simultaneously. Different team members can work on different branches without interfering with each other's work. This parallel development speeds up the overall project progress and makes the team more productive. The feature branch workflow is best suited to small to medium-sized projects and teams with a straightforward development process. Now that we've explored how the feature branch workflow can help manage individual features, let's explore the Git flow workflow, which is better suited to large-scale projects. It introduces two main branches. First, the main or master branch, which holds the production-ready code. It's the stable version of your project that's deployed to users. And also the develop branch, which contains the latest development changes. It's where all the new features and updates are integrated before being considered for release. Here's the process of the Git flow workflow. First, initialize your main branches. The main branch contains the production-ready code. This is the stable version of your project that's ready for deployment. The develop branch holds the latest development changes. This is where all the new features and updates are integrated. Next, when starting a new feature, create a feature branch from the develop branch. This branch is where you'll develop your new feature. By isolating your work in a feature branch, you ensure that the main code base remains stable. Once the feature is complete and tested, merge the feature branch back into the develop branch. This step integrates your new feature into the main development line. After merging, you can delete the feature branch if it is no longer needed. When it's time to prepare for a new release, create a release branch from the develop branch. This branch is specifically for finalizing the release. You can make last-minute bug fixes and adjustments here without affecting ongoing development. After finalizing the release, merge the release branch into both master and develop. This ensures that the release changes are reflected in both the production-ready code and the ongoing development. Tag the commit in the master branch with a version number, such as v1.0. This tagging helps track releases and makes it easy to reference specific versions of your code. If an urgent issue arises in production, create a hotfix branch from the master branch. This branch is used to quickly address and fix the issue without disrupting the main development process. Finally, once the hotfix is complete, merge the hotfix branch back into both the master and develop. This ensures that the fix is applied in the production code and included in ongoing development, preventing the issue from recurring. The Git flow workflow offers several key advantages. It provides a clear workflow for managing large projects. Git flow's structured approach helps teams manage complex projects efficiently. With dedicated branches for features, releases, and hotfixes, everyone knows exactly where to work and how to integrate their changes. It also separates different types of work. By having distinct branches for features, releases, and hotfixes, Git flow ensures that different types of work don't interfere with each other. This separation helps maintain stability and order in the development process. Git flow workflow ensures a clean and organized history. Git flow workflow works best for large projects with multiple developers and projects with regular release cycles. While Git flow is ideal for managing internal development in large projects, the fork and pull workflow offers a different approach, particularly suited for open source projects where contributions from external developers are common. The fork and pull workflow is commonly used in open source projects. Here's how it works. First, you fork the repository, which involves creating a personal copy of the main repository. Next, you clone your forked repository to your local machine. After this, you create a new branch for your changes. You then work on the branch, making and committing your changes. Then push your changes to the forked repository, and from your fork, open a pull request to the original repository. Finally, the project maintainers will review the pull request. After approval, it gets merged into the main repository. Key advantages of push and pull workflow include decentralized development. This workflow allows developers to work independently in their own repositories, promoting flexibility and autonomy. Encouragement of contributions from external developers. By forking the repository, external contributors can easily propose changes without requiring direct access to the main codebase. Maintaining the integrity of the main repository. Changes are reviewed and approved before being merged, ensuring that only high-quality code is integrated into the main project. Push and pull workflow works best for open source projects and projects with contributions from external developers. Understanding common version control workflows is important for efficient project management and collaboration. By using workflows like the feature branch workflow, Git flow workflow, and fork and pull workflow, teams can choose the best approach for their project needs, ensuring smooth development processes and high-quality code. Imagine you're working on a big project with multiple team members, and suddenly someone's changes overwrite your hard work. Confusion ensues and precious time is lost. Setting up and initializing a Git repository is like having an organized, secure vault where every version of your work is safely stored. A properly set up Git repository ensures that your code projects are efficiently managed and protected from accidental losses. In this video, we will explain how to set up and initialize a Git repository. A Git repository is a storage space where your project's code and version history are kept, helping to manage and track changes to project files. Setting up and initializing a Git repository is the first step in managing your code base efficiently, allowing you to track changes and collaborate with others seamlessly. First, let's install Git by following these steps. First, open your web browser and go to git-scm.com. Click on the Download button. This should automatically detect your operating system and provide the appropriate installer. Once the installer is downloaded, open it to start the installation process. Then, follow the prompts in the Setup wizard. Finally, you can leave most of the default settings as they are, but make sure to check the option to use Git from the Windows command prompt. After installing Git, you need to configure it. Open your terminal or command prompt and enter the following commands to set your name and email address. Git space config -- global space user.name open quotation, whatever your name is, close quotation, and then git space config -- global space user.email open quotation, whatever your email address is, close quotation. These will be used for your commit messages. Great, now Git knows who you are. Next, let's initialize a new Git repository. Navigate to the directory where you want to create your project. For example, if you want to create a new project in a folder called my_project, you would do this. mkdir space my_project, cd space my_project, git space init. The git init command creates a new Git repository in your current directory. You can now start tracking changes to your files in this directory. First, find the URL of the repository you want to clone. For example, let's say you want to clone the repository at https://github.com/user/repo.git. open your terminal or command prompt and run git space clone https://github.com/user/repo.git. This command will create a new directory named repo and download all the files and commit history from the remote repository. That's it. You are set up and ready to start building your project. Setting up and initializing a Git repository is essential for effective version control. This process allows you to configure your user information, initialize new repositories, and clone existing ones so you can efficiently manage and track your project's changes. This lab will provide you with hands-on experience with Git, guiding you through installation, configuration, and core commands to stage, commit, push, and pull changes between local and remote repositories. Let's get started. We need to add the command that specifies your action to set your Git username. Now, add the command to specify the action to set your Git email address. Now, add the command to list all current Git configurations. Add the command to initialize a Git repository. Add the command to stage a file for committing. Add the command to create a commit with a message describing the change. Now let's push changes to a remote repository. Add the command that links your local repository to a remote repository. Add the command to push your changes to the remote repository. Now let's pull changes from a remote repository. Add the command to pull the latest changes from GitHub. Now, let's add the command to check the current status of your project files. Great job completing the guided lab. GitHub is an essential platform for developers working together on projects, offering tools that streamline collaboration and code management. By centralizing code, tracking issues, and facilitating project management, the GitHub tool helps teams stay organized and productive, especially in distributed work environments. Its features, such as repositories, pull requests, and project boards, enable smooth communication and ensure high-quality code across the entire development process. In this video, we will describe the key features of GitHub for collaborative development. GitHub is a web-based platform built on Git, which is essential for version control. It's designed to help developers collaborate seamlessly on projects. By offering tools for code hosting, version control, and project management, GitHub has become the central hub for teams working together on software development, especially in today's distributed work environments. GitHub makes collaboration easy, especially for teams spread across different locations. It helps everyone stay on the same page by managing code changes and keeping track of project progress. The result? More productive teams and higher quality code. Let's explore how you can use GitHub to facilitate collaborative development by discussing its key features. A repository, or repo, is basically the home for all your project's code and files. It's where everything lives and where everyone on the team can access what they need. For instance, when beginning a new project, the first step is creating a repository where all team members can contribute and access the project's codebase. Developers can create repositories to host their projects, enabling version control and collaboration. Repositories can also be cloned to a local machine for development and testing. For example, it is helpful to start each project with a repository where all the team members can contribute code and track changes. A pull request is a feature that allows developers to propose changes to a code base in a collaborative environment. After you've made updates to a copy of the code, you can commit a pull request to share your changes with the team. This is crucial because it allows team members to review and discuss these changes before they are integrated into the main code base, ensuring that only well-vetted code is merged. Let's examine how this process works in practice. Team members review the proposed changes, provide feedback, and suggest improvements. For example, developers can use pull requests to ensure all changes are reviewed and discussed before merging them into the main code base. Issues are like your project's to-do list. They help you keep track of bugs, improvements, and tasks that need to be done. Developers and users can create issues to report bugs or request new features. Issues can be assigned to team members and tracked through completion. For example, the issue tracker can be used to prioritize and manage development tasks, ensuring that critical bugs are addressed and new features are implemented efficiently. Projects organize and manage work using boards. After tracking issues and managing repositories, the next step in organizing work is using project boards. Project boards help visualize tasks, track progress, and manage workflows, providing a clear overview of what needs to be done and what's already completed. For example, project boards can be used to organize sprints, ensuring that all tasks are visible and progress is tracked systematically. GitHub facilitates collaboration by integrating all these features into a cohesive workflow. Centralized code management repositories centralize code, making it accessible to all team members. Collaborative reviews via pull requests enable thorough code reviews, ensuring code quality and fostering knowledge sharing. Effective tracking of issues helps teams track and manage tasks, prioritize work, and resolve problems efficiently. Organized project management by project boards provide a visual representation of tasks, helping teams stay organized and focused. Understanding the key features of GitHub for collaborative development can significantly enhance your team's workflow. By utilizing repositories, pull requests, issues, and projects, GitHub facilitates seamless collaboration among developers, leading to higher productivity and better project outcomes. Picture a project where you and your team are constantly battling version control issues, resulting in lost work and frustration. What if there was a way to avoid these headaches and collaborate smoothly? Whether you're a beginner or hoping to sharpen your skills, this video will guide you through the essential GitHub features for collaborative development, making your team more efficient and your code more reliable. In this video, we will explore how to use GitHub for collaborative development. GitHub is a web-based platform that uses Git for version control. It allows multiple developers to collaborate on projects and facilitates collaborative development by providing tools for code hosting, version control, and project management. Before we explore GitHub's collaborative features, we need to log in. This will give us access to all the tools and features we need for effective collaboration. Let's go through the process step by step. Either log into the page or follow the directions to create an account and then log in. In the left corner, you can view your GitHub dashboard, where you can access your projects, activity, and settings. The dashboard is your central hub for managing your work and keeping track of your team's progress, making it easier to stay organized and collaborate efficiently. Understanding the structure of your project is key to effective collaboration. It helps you manage files and coordinate with your team. First, locate the project you want to work on by clicking on Projects in your dashboard. Then, select a project from your list or choose one from the trending repositories. Finally, once you've selected a project, you'll find its main repository page where you can explore the project tree. The project tree is a visual representation of all the files and directories in a repository, helping you understand its structure. You can then view files, open them to discover their contents, and even make edits directly from this interface. This layout helps you quickly locate and manage files, making collaboration more efficient. If you have an existing project for your team, you can click on Projects in the dashboard. Otherwise, scroll down the page, find Trending Repositories in the center section, and click on one that interests you. Now you are on the main page of the repository that you selected. You will now find a list of branches for the repository. Now click on one of the branches. You will find all of the files within it, as well as the number of commits it has. You can select a file to review or edit within a branch by clicking on its title. To edit the code, first click on the pencil icon at the top right corner of the file. In a collaborative environment, it's common for multiple people to work on the same file simultaneously. To minimize unintentional overwrites or code conflicts, it may be prudent to fork the repository. This allows you to work independently while still being able to contribute to the main project. Forking a repository creates a personal copy of someone else's project. Once any edits were complete, I would commit the changes by clicking in the upper right corner. Once you've made edits in your forked repository and committed those changes locally, the next step in the collaborative process is to open a pull request to the original repository. This is how your contributions are reviewed and merged into the main project, ensuring that everyone's work is integrated smoothly. This results in a review of the changes and merger into the main project. There are two ways to push changes. One is to use the GitHub desktop interface. Simply click Pull Requests at the top left of the page. While the desktop interface offers a user-friendly way to manage pull requests, the command line provides more control and flexibility for advanced users. The method is to use the git pull command to fetch updates from a remote repository and merge them into your local branch. To do this, you would open your terminal or command prompt and then use the cd command to navigate to the directory of your local Git repository, like this.
Imagine you're working on a critical project and suddenly lose track of your code changes. Just like a cluttered desk can lead to misplaced documents, a disorganized coding environment without version control can cause confusion and errors. Combining Git with your integrated development environment, or IDE, can help prevent this chaos, keeping your development process smooth and efficient. An IDE not only helps you stay organized, but also makes your code easily accessible and manageable throughout the development process. In this video, we will explain how to integrate Git with development tools and IDEs so you can streamline your coding workflow and keep your projects organized. Git is a distributed version control system that helps developers track changes to their code over time, collaborate with others, and manage different versions of their projects. Integrated development environments, commonly known as IDEs, are powerful tools that provide comprehensive facilities to computer programmers for software development. Think of it as a one-stop shop for writing, testing, and debugging code. An IDE typically includes a code editor where you can write your code. It often comes with features like syntax highlighting, code completion, and code formatting to make writing code easier and more efficient. A compiler or interpreter that translates your code into a language that the computer can understand and execute. A debugger to help you identify and fix errors in your code. Build automation tools that reduce the need to manually execute tasks to save and push every time you make a change. Version control integration tools that allow you to manage and track changes to your code directly from the IDE. Using an IDE can greatly enhance your productivity and streamline your development process. With features like code completion and syntax highlighting, you can write code faster and with fewer errors. Integrated tools, such as a code editor, debugger, and version control system, all in one place mean you don't have to switch between different applications. Real-time error checking and debugging tools can help you catch and fix mistakes early in the development process. IDEs often come with project management tools that help you organize and manage your files and dependencies. Let's review how to set up Git integration with three popular IDEs: Visual Studio Code,
IntelliJ IDEA, and Eclipse. To begin with, you'll need to have Git installed on your computer. Go to the Git website at git-scm.com and download the installer for your operating system. Run the installer and follow the on-screen instructions to complete the installation. Visual Studio Code, or VS Code, is a popular lightweight code editor with built-in Git support. Let's walk through how to install and set up Git in VS Code. Begin by opening VS Code. Then go to the Extensions view by clicking the square icon in the sidebar. Search for the Git extension and install it. Now that Git is installed, if you would like to clone a repository, open the command palette with Control-Shift-P and then type git:clone or git:initialize repository to create a new one. You can now use the source control view, click the branch icon in the sidebar to manage your Git repositories, stage changes, commit updates, and push to remote repositories. IntelliJ IDEA is a powerful IDE for Java and other languages with excellent Git integration. To integrate with Git, open IntelliJ IDEA and navigate to File, Settings. Then click on Version Control, then Git, and ensure that the path to your Git executable is correct. Click Test to verify the setup, then click OK. You can now access Git features from the VCS menu, such as committing changes, pushing to remote repositories, and managing branches. Eclipse is another widely used IDE, particularly for Java development. To integrate Git and Eclipse, open Eclipse and go to Help, then Eclipse Marketplace. Search for eGit and install the plugin if it's not already installed. To configure Git in Eclipse, follow these steps. Go to the Window menu at the top of the screen and select Preferences. In the Preferences window, navigate to the Git configuration by expanding the Team node. Click on Git and then select Configuration. To add your user information, click on Add Entry. Enter your username and user email. Finally, save the configuration by clicking OK. You can now use the Git perspective to manage your repositories, commit changes, and push updates. Let's examine how Contoso Electronics successfully integrated Git with their development tools to improve their workflow. Contoso's team was using different IDEs for various projects. By integrating Git, they were able to streamline their version control process across Visual Studio Code, IntelliJ IDEA, and Eclipse. They started by installing Git on all team members' computers. Then they set up a Git in each IDE, following the steps we covered. With Git integrated, the team could easily manage their code, collaborate on projects, and track changes in real time. This led to fewer merge conflicts, better project organization, and faster development cycles. Today we learned how to integrate Git with Visual Studio Code, IntelliJ IDEA, and Eclipse. By following these steps, you can improve your coding workflow and ensure efficient version control directly within your IDE. Happy coding! Ever spent hours digging through code to find out who made a change or face the headache of resolving complex merge conflicts? Imagine a tool that can make these problems disappear. By using the right Git plugins and extensions, you can not only streamline your workflow, but also eliminate these common headaches, making your daily tasks much more manageable. In this video, we will identify Git plugins and extensions that enhance productivity. A Git plugin is a piece of software that adds Git-related functionalities to an integrated development environment or IDE or a text editor. It enhances the tool's capabilities by integrating Git commands and workflows directly into the interface of the IDE or editor. Plugins are usually specific to the tool they are designed for and are installed to add or extend features. These plugins streamline various tasks such as code comparison, commit history visualization, and branch management, significantly improving the Git workflow for developers. A Git extension refers to scripts or programs that add functionalities or custom commands that extend the core capabilities of Git itself. Extensions can augment Git's functionality across different environments and tools. Efficient Git management is crucial for developers, allowing them to maintain code quality and streamline collaboration. Using the right plugins and extensions can save time and reduce errors. Let's discuss some of the top Git plugins and extensions available for popular development tools and how they enhance productivity. Let's start with Git Lens, a powerful extension for Visual Studio Code. Git Lens supercharges the built-in Git capabilities of Visual Studio Code, providing you with a wealth of information right within your editor. First, the Blame Annotations feature in Git Lens shows the commit history and author of each line of code directly in the editor, which is incredibly useful for understanding the context of changes. Next, the Code Lens feature makes inline code annotations that provide detailed commit information, enhancing your ability to track changes. The Repository Explorer visualizes your Git repositories, making it easier to navigate branches, commits, and files. Finally, the interactive rebase editor simplifies complex rebases with an intuitive interface. Here's an example of a situation in which Git Lens would be an optimal tool. Imagine you're working on a feature and notice a bug in a particular line of code. With Git Lens, you can instantly determine who last modified that line and when. This information helps you understand the history of the change and potentially reach out to the author for more context. Let's explore another tool for Git integration, IntelliJ IDEA. IntelliJ IDEA is a popular IDE for Java development, and it comes with robust Git integration out of the box, but the Git integration plugin takes it to the next level. Key features of IntelliJ IDEA include a graphical log that provides a visual representation of a project's commit history, branches, and merges, making it easier to understand the flow of project's development. Following this, the change list feature allows developers to organize changes into logical groups before committing them. Also, the interactive rebase provides a user-friendly interface to handle rebasing, cherry picking, and other advanced Git operations. Finally, the branch operations simplifies the creation, merging, and deletion of branches. Using IntelliJ IDEA with Git is particularly useful when you're handling multiple features simultaneously. With the IntelliJ IDEA Git integration plugin, you can create change lists for each feature, keeping your work organized and ensuring that you commit related changes together. The graphical log helps you visualize how different branches have diverged and merged over time. The last tool we are going to examine is eGit, the Git plugin for Eclipse. eGit integrates seamlessly with the Eclipse IDE, providing a comprehensive set of Git tools directly within your development environment. Key features of eGit include repository management, which allows you to easily clone, create, and manage Git repositories within Eclipse. Next, the staging view offers a dedicated space for staging changes and clearly indicates which files are ready to be committed. Following that, the history view displays the commit history of your project with detailed information about each commit. Finally, the merge tool simplifies resolving merge conflicts through an intuitive interface. One situation in which eGit would be of particular use is if you're collaborating on a project and encounter a merge conflict. eGit's merge tool provides a clear, visual interface to help you resolve conflicts efficiently. You can see the differences between branches and make informed decisions on how to merge the changes. Understanding and utilizing the right Git plugins and extensions can significantly enhance your development workflow. By integrating tools like Git Lens, Git integration for IntelliJ IDEA, and eGit, you can streamline your Git operations, improve collaboration, and boost overall productivity. Imagine trying to manage a complex software project with multiple developers working on different features simultaneously, all without a clear strategy for organizing their changes. The risk of conflicts and errors would be overwhelming. In Git, adopting advanced techniques for branch management and merging can be useful. These techniques not only keep your project organized, but also significantly reduce the chances of costly conflicts during collaboration. In this video, we will identify advanced Git techniques for managing branches and mergers. Branch management involves techniques for creating, managing, and integrating branches in a version control system. It helps in organizing changes and facilitating collaboration among multiple contributors. Effective branch management helps prevent conflicts, keeps the project history clean, and makes collaboration easier. It allows multiple developers to work on different features simultaneously without interfering with each other's work. Branching is a core concept in Git that allows you to diverge from the main line of development and continue to work without affecting the main branch. Branching strategies help manage how branches are created, named, and merged. Several types of branching strategies can be used with Git. In feature branching, every new feature is developed in a separate branch. Once the feature is complete, it is merged back into the main branch. Release branching is used to prepare for a new release. Once a release branch is created, only bug fixes and release-related tasks are performed on this branch. Hotfix branching is used for critical fixes that need to be addressed immediately. These branches are created from the main branch and merged back into it after the fix. Git flow branching defines a strict branching model designed around project releases. It includes branches for features, releases, and hotfixes, making it easier to manage the development process. Now let's explore how to create and merge branches. Here's a sample of syntax to create a new branch. Git space checkout space -b space feature -new -feature. This command creates a new branch called feature new feature and switches to it. Here's an example of how you could make some changes to your files and commit them. Git space add period, git space commit space -m space open quotation add new feature close quotation. You would then switch back to the main branch using this syntax: git space checkout space main. Then, to finish, you would merge the feature branch back to the main branch. Git space merge space feature -new -feature. This command merges the changes from the feature new feature into the main branch. Conflicts can occur when changes in two branches overlap. Resolving conflicts involves identifying and merging conflicting changes in the code. This is crucial when integrating branches. Let's simulate a conflict and resolve it. In 2 steps, we will create a conflict. First, in the main branch, edit a file and commit the changes. Git space add period, git space commit space -m space open quotation edit file in main close quotation. Next, switch to the feature new feature and edit the same file, then commit the changes. Git space add period, git space commit -m space open quotation edit file in feature -new -feature close quotation. So now that we have created a conflict, we must resolve it. Conflict resolution is the process of identifying and resolving conflict changes in code during a merge. It involves manually editing the conflicting files and committing the resolved changes. The first step in resolving the conflict that was created is to switch back to the main branch. Git space checkout space main. Next, attempt to merge the feature branch. Git space merge space feature -new -feature. Git will indicate a conflict. Open the conflicted file, resolve the differences, and mark it as resolved. Git space add space process period. Git space commit space -m space open quotation resolve merge conflict close quotation. Your merge will be completed once the conflict is resolved. You've marked it as such with git add and you've committed the changes. Now, beyond merging, Git offers another powerful feature for managing changes: rebase. Rebase is another powerful tool in Git. Rebase is a process that allows developers to move or combine a sequence of commits to a new base commit. Rebase and merge are two ways to integrate changes from one branch into another. Rebasing commits a linear project history, which is easier to understand. Merging preserves the context of feature branches. To rebase a feature branch, use this syntax: git space checkout space feature hyphen new hyphen feature. Git space rebase space main. This replays the commit from feature new feature onto the latest commits in main. If conflicts arise, resolve them as before and continue the rebase by using git space add period, git space rebase space hyphen hyphen continue. After resolving conflicts and completing the rebase, force push the changes to the remote repository with git space push space hyphen hyphen force. Let's examine how Code Crafters, a coding bootcamp, could use advanced Git techniques to manage its course repositories efficiently. Code Crafters can use Git flow branching strategy to manage different stages of course development, including features, releases, and hotfixes. Instructors regularly resolve conflicts when multiple contributors make changes to the same course material, ensuring a smooth integration process. Before finalizing course content, Code Crafters rebases feature branches onto the main branch for a clean history and merges them to preserve the context of changes. In this video, we've explored advanced Git techniques for managing branches and merges, including branching strategies, resolving conflicts, and using rebase and merge commands. Implementing these practices will help you maintain an organized and efficient repository, facilitating collaboration and project management. Have you ever struggled to keep your repository clean while managing multiple features and fixes? In software development, effective repository management is crucial to ensure that your project remains organized and easy to navigate. In this video, we will explain advanced techniques for managing repositories in Git. Repository management involves techniques and practices for maintaining a clean and organized code base in a version control system. Effective repository management helps prevent conflicts, makes it easier to track changes, ensures that the project remains organized, and supports collaboration, especially in large projects with multiple contributors. Let's explore ways to do this, starting with tags. Tags in Git are used to mark specific points in the repository's history as important. Tags help you quickly identify important points in your project's history, making it easier to manage releases and track changes. Imagine you have a project and you've just completed a major milestone. You want to mark this point in your repository. You can create a tag with the following command: git space tag space hyphen a space v1.0 space hyphen m open quotation initial release. Here, hyphen a stands for annotated, and hyphen m allows you to add a message describing the tag. To push tags to a remote repository, you would use git space push space origin space v1.0. Next, stashing changes is a technique that allows you to save your work temporarily without committing it. Sometimes you might be in the middle of working on something and need to switch branches quickly without committing your changes. Stashing is a way to save your work in progress without committing it, allowing you to switch branches or pull updates without losing your changes. It is also a powerful way to keep your work organized and avoid messy commits. So when might you need to stash changes? One situation might be if you are working on a feature in the feature branch, but must switch to main to fix a bug. Instead of committing incomplete work, you can stash your changes. Git space stash. This command stores your changes away safely. Suppose you'd like to find what you've stashed. Simply type git space stash space list. Finally, interactive rebase is a powerful tool for cleaning up your commit history before merging. Rebasing is a way to streamline a series of commits by moving or combining them. Interactive rebase allows you to edit commits, squash multiple commits into one, or even change commit messages. Suppose you have made several small commits while working on a feature. Before merging these into the main branch, you want to clean up your commit history. Start an interactive rebase with git space rebase space -i space head, all in capital letters, tilde 4. Here, head tilde 4 tells Git to include the last 4 commits. This will open an editor with the list of commits. You can choose to pick, squash, or edit commits. Pick allows you to keep the commit as it is. Squash combines the commit with the previous one. Edit modifies the commit. In this video, we've explored advanced techniques for managing repositories in Git, including using tags, stashing changes, and performing interactive rebases. Implementing these practices will help you maintain a clean and organized repository, facilitating collaboration and project management.
In this lab, you will learn advanced Git techniques for managing branches and repositories. Branching allows developers to work on different tasks without interfering with the main project. This is useful for managing features, bug fixes, and experiments. Effective branch management helps prevent conflicts and improves collaboration. Let's create a new branch. Open your terminal and navigate to your Git project, My Project, and then type the code scene. Now create and switch to a new branch by typing the code on the screen. Make changes to any file in the project, then stage and commit those changes by typing the code git add, period, then select enter. To finish, type the code git commit -n and then add new feature, then select enter to move forward. Type the word CLS to clear the console screen, removing all previous commands and outputs. Merging branches integrates changes from one branch into another. However, when changes in both branches affect the same line of code, conflicts may occur. Resolving these conflicts ensures that the final code integrates all changes correctly. Switch to the main branch by typing the code on the screen. To edit the file in the main branch and commit your changes, type the code git add, period. Then select enter to move forward. To finish the code, type git commit -m edit file in main branch. Type the code CLS to clear the console screen, removing all previous commands and outputs. Switch back to your feature branch and modify the same file, then commit by typing git checkout feature new feature. Now type the code git add period, then select enter to move forward. To finish, type the code git commit -m edit file in feature branch. And then type the code CLS to clear the console screen, removing all previous commands and outputs. Merge the feature branch into the main branch, type code get checkout main. To finish the merge, type the code git merge feature new feature. Then we type CLS to clear the console screen. If a conflict occurs, Git will notify you. To resolve, you should open the conflicted file in a text editor, resolve the differences by keeping the appropriate changes. Then stage the resolve file and complete the merge by typing the code git add period. Then select enter to move forward. To finish resolving the conflict, type the code git commit -m resolve merge conflict. The feature branch will be merged into the main branch with conflicts resolved. Type the code CLS to clear the console screen. Tags are used to mark specific points in a repository's history as important milestones such as a release. Tags help you keep track of significant moments in your projects. Create an annotated tag for your current state by typing the code git tag -a v1.0-m initial release. Push the tag to the remote repository by typing the code git push or agin v1.0. Select enter to move forward. The v1.0 tag will appear in your repository marking the initial release. Type the code CLS to clear the console screen. Stashing allows you to save your work in progress without committing it.
so you can switch branches or pull updates without losing changes. This is helpful when you need to switch tasks quickly. Now, check out the feature branch and make some changes to a file, but do not commit them. Stash your changes by typing the code git stash. Select enter to move forward. Switch to the main branch by typing the code git checkout main. To see the list of stash changes, type the code git stash list and select enter to move forward. Apply the stash changes back to your working directory by typing the code git stash apply. Then select enter to move forward. Your stashed changes will be reapplied, allowing you to continue working on them. Type the code CLS to clear the console screen. Interactive Rebase allows you to edit commits, squash multiple commits into one, or modify commit messages. This keeps your commit history clean and easy to understand before merging it into the main branch. Start an interactive rebase for the last 4 commits by typing git rebase -i head approximate 4. Scroll through the output. Here we used pick to keep a commit, squash to combine commits, and edit to modify a commit. Type the code CLS to clear the console screen, removing all previous commands and outputs. If conflicts occur, resolve them by typing the code git add period. Then type the code git rebase -- continue and select enter to move forward. The commit history will be cleaned up with meaningful consolidated commits. Great job on completing this guided lab. As you have learned, mastering Git and GitHub is essential for efficient version control and collaboration, which is crucial for effectively managing complex software projects. We began by exploring the fundamental principles of version control, laying the groundwork for effective change management and collaboration in software development. Next, we examined the critical Git commands central to version control, enabling you to monitor and manage changes in your code effectively. Then, we learned how GitHub facilitates collaborative development, teaching you how to use this platform to improve team collaboration and optimize project processes. After that, we explored the integration of Git with diverse development tools and IDEs, focusing on how this inclusion boosts your efficiency by embedding version control seamlessly within your development environment. Lastly, we examined various advanced Git strategies, focusing on complex techniques to effectively manage large repositories and intricate development tasks. By learning these essential tools, you enhance your ability to manage version control and collaboration, streamline project workflows, and handle complex development tasks more effectively. This knowledge not only improves project outcomes, but also optimizes your development processes. To get started with Microsoft Copilot to help you write code, debug, and improve your processes, we'll need to get set up in your development environment. Whether you're using Visual Studio Code, JetBrains, or GitHub, you'll be fully equipped to integrate Copilot and take your coding efficiency to the next level. In this video, we will set up Microsoft Copilot in the development environment. Let's start with Visual Studio Code, one of the most popular IDEs today. The installation process is simple. First, open Visual Studio Code on your system. Next, head to the Extensions Marketplace by clicking on this icon in the left sidebar. In the search bar, type GitHub Copilot and press Enter. The GitHub Copilot extension should be the first result. Now, click Install to add the GitHub Copilot extension to your VS Code. Once installed, you'll need to sign in with your GitHub account. This is necessary for Copilot to function properly. Here are a few tips to help you maximize Copilot's potential. Use comments to guide Copilot, telling it what you want to achieve will lead to better suggestions. Leverage Copilot's ability to suggest code across different languages by switching between languages in the same project. Keep reviewing the generated code for quality and security, as AI-generated code may need manual tweaking. Congratulations! You've now set up Microsoft Copilot in your development environment. Copilot is here to help streamline your coding experience. Take some time to explore how Copilot can enhance your productivity and coding creativity. Microsoft Copilot takes the guesswork out of coding and makes HTML creation faster, easier, and even more fun. Whether you're just getting started or want to level up your skills, you'll discover how this AI-powered tool can write entire sections of code for you and suggest improvements as you build websites. In this video, we will use Microsoft Copilot to write and enhance HTML code. When starting an HTML file, Copilot can help generate a basic structure. Let's begin by typing a simple comment that says HTML structure into Visual Studio Code to discover what Copilot suggests. With that prompt, Copilot suggests the structure of the new HTML file, automatically including the best practices like the lang attribute in the HTML tag and the meta tags for responsive design. Now, let's enhance this page by adding some content with semantic HTML. Semantic tags help give meaning to your content, making it more accessible and easier to understand for both users and search engines. Let's start by typing add a header section. Copilot has suggested a well-structured header with a navigation element and a heading. This semantic structure not only organizes content logically, but also improves accessibility, allowing screen readers to navigate the page more easily. Copilot is also great for generating more complex HTML elements, like forms and tables. Let's create a simple contact form using Copilot. Type Create Contact Form. Copilot can generate a form with fields for name, email, and a message, all neatly organized and following HTML best practices. With just a few keystrokes, Copilot has created a fully functional and accessible form. Microsoft Copilot is a powerful tool for writing and enhancing HTML code. It can save time, promote best practices, and help you build clean, semantic web pages. Whether you're a beginner or an experienced developer, Copilot can take your coding to the next level. Give it a try in your next project and discover how much more efficient and productive you can be. Have you ever found yourself staring at a blank HTML file, unsure where to begin? Or maybe you're tired of spending hours structuring your web pages for both accessibility and SEO, but still feel like something's missing. What if I told you there's a faster, smarter way to create clean, organized, and optimized code? In this video, we will create semantic HTML using Microsoft Copilot. First, let's talk about semantic HTML. Semantic elements are HTML tags that clearly describe their meaning in a way that both the browser and developers can understand. For example, instead of using div tags everywhere, we can use elements like header, article, or footer to give structure and meaning to the content. In this example, each element, header, nav, main, article, and footer, clearly indicate the role of that section on the web page. This helps users and search engines better understand the content structure. Now, let's discover how Copilot can help us write semantic HTML code. Once you've opened your IDE, such as VS Code, as you start typing, Copilot will analyze the context and suggest appropriate HTML tags. Watch how it recommends semantic elements as we build out a simple web page. Notice how Copilot suggests elements like header, section, and footer as we build this page. It helps by recognizing the structure you're trying to create and offering appropriate semantic tags. Copilot isn't just about speeding up your workflow, it's also great for improving the accessibility and SEO of your web pages. It suggests attributes like alt for images, ARIA label for navigation, and other important accessibility features that ensure your site is inclusive. In this example, Copilot recommended adding the alt attribute to this image, which is essential for screen readers and SEO. It also suggests adding proper headings and labels for form elements, making your code accessible from the start. That's how easy it is to create semantic HTML using Microsoft Copilot. By combining your knowledge of HTML with Copilot's intelligent suggestions, you can write clean, structured, and accessible code quickly. We encourage you to keep exploring how Copilot can assist you in your coding journey and continue to apply semantic HTML best practices in your projects. Whether you're just getting started or hoping to streamline your workflow, you can use Microsoft Copilot to level up your CSS skills. It can help you write professional-grade CSS faster and with fewer errors, making suggestions to help you streamline your processes as you go. In this video, we will use Microsoft Copilot to write and enhance CSS code. When working with CSS, Copilot can suggest code, automate complex styles, and even provide useful tips for improving your designs. This is especially helpful if you're just starting or when you need a quick way to style web pages efficiently. After opening Visual Studio Code or a similar IDE that has already been set up with Copilot, start by entering the simple HTML code displayed here in a file titled index.html. Now, let's ask Copilot to generate some CSS for a styles.css page. I'll start by typing create a simple style for the header and paragraph. This example demonstrates how Copilot can provide a clean, professional design with minimal input from me. This is great for rapid development. Next, let's use Copilot to implement more advanced CSS, such as Fluxbox layout for responsive design. Watch how Copilot simplifies the process. Type use Fluxbox to create a responsive layout and hit enter. With that prompt, Copilot has created a fully responsive layout using Fluxbox. Copilot can also enhance an existing style sheet. Say you have a set of basic styles, but you want to add some flair. Copilot can suggest improvements, such as adding transitions or hover effects. With the existing CSS file open, you can simply type suggest transitions or hover effects, and Copilot will generate the code. Here, Copilot has suggested adding a transition for smooth hover effects. This enhances the user experience with minimal effort. While Copilot is a powerful tool, it is important to follow best practices when writing CSS to ensure your styles are clean, scalable, and maintainable. Here are a few tips to keep in mind. Use semantic class names. Make sure your CSS classes are descriptive and meaningful. Avoid overspecificity. Try not to make selectors too specific, as it can lead to complex, hard-to-maintain code. Optimize for performance. Use shorthand properties and avoid excessive use of large images or complex animations. Leverage Fluxbox and Grid. These layout techniques ensure your designs are responsive across different devices. In this lesson, we've explored how Microsoft Copilot can help you write and enhance CSS code. From basic styling to advanced layouts and best practices, Copilot simplifies the coding process, making it easier and faster for you to style your web pages. As always, keep practicing and don't be afraid to experiment with Copilot's suggestions to determine what works best for your projects. Thanks for watching and happy coding. Have you ever visited a website on your phone and it just didn't look right? Maybe the text was too small or the images didn't fit the screen. Microsoft Copilot can help you avoid this when you are creating websites by helping you create responsive layouts quickly and efficiently. Whether you're just getting started with responsive design or you've been coding for a while, Copilot is here to help you code smarter, not harder. In this video, you will learn how to create responsive designs using Microsoft Copilot. Responsive web design is a web development approach that ensures websites work well on various devices and screen sizes by using flexible layouts, images, and CSS media queries. Responsive design adapts a website's layout depending on the screen size or device, ensuring a more accessible and seamless experience for users. Now, let's examine how Microsoft Copilot can assist us in creating responsive designs. Copilot can generate media queries for you, write layout code for different screen sizes, and suggest optimizations based on best practices. It can even handle the complex math involved in flexible grids. We'll use Copilot to enhance our CSS so it works perfectly across all devices. Let's use Copilot to create a responsive layout. Imagine we're building a simple web page with a header, a main content section, and a footer. We want this layout to look good on mobile, tablet, and desktop screens. First, open your favorite code editor with Copilot integrated, like VS Code, and create a project folder by selecting File, then Open Folder, and navigating to the directory where you want to create the project. Once inside the folder, you will create two files, index.html, this will be your HTML file, and style.css, this will be your CSS style sheet file. On the index page, ask Copilot to generate a responsive HTML5 template with linked external CSS file. Now, let's define the basic layout using CSS. Copilot can help us quickly style the elements. Simply request that it provide basic styling for the layout by opening the CSS file and typing basic styling for the layout in the Copilot query. Copilot chat, you can request create a responsive CSS style sheet for a basic HTML page with a flexible layout, including mobile-first design. Your output will be similar to this. Now, let's make this design responsive. We'll use media queries to adjust the layout for mobile, tablet, and desktop. Type generate media queries for mobile, tablet, and desktop screens. Watch how Copilot suggests the media queries automatically. With Copilot's help, we've generated a fully responsive layout. Let's test it out. To view your responsive design in action, you need to preview your project in a browser. Here's how. Right-click your index.html file in VS Code and select Open with Live Server. If you don't have Live Server installed, go to the Extensions sidebar, search for Live Server, and install it. Live Server will launch your site in the browser, allowing you to view the page as it will appear to users. To test how your design responds to different screen sizes, you'll use the browser's developer tools. In Chrome, Firefox, or Edge, right-click anywhere on the page and choose Inspect or press Ctrl+Shift+I. Once the developer tools are open, click the toggle device icon. It looks like a mobile device and tablet icon. Or press Ctrl, Shift, and M. This will allow you to display the page in different device views. You can select predefined device sizes like iPhone, iPad, etc., or manually resize the viewport by dragging the edges of the screen. Imagine having a personal coding assistant that can write JavaScript for you, quickly, efficiently, and with just a few keystrokes. Sounds like magic, right? Well, with Microsoft Copilot, it's a reality. Whether you're completely new to coding or looking for a way to boost your productivity, Copilot is here to help you turn ideas into working code. In this video, I'll show you how to harness the power of Copilot to write JavaScript, solve coding challenges faster, and unlock your full potential as a developer. In this video, we will use Microsoft Copilot to write and enhance JavaScript code. First, ensure you have Microsoft Copilot set up in your development environment. I'm using Visual Studio Code, but Copilot also integrates with several other popular editors. Once installed, Copilot will automatically activate as you start typing code. With everything set up, let's start a new JavaScript file. You can do this by clicking File, then New File, and save it with a .js extension. For example, script.js. This tells VS Code you're working with JavaScript, and Copilot will be ready to assist you with code suggestions. Type this simple comment describing the task. Function to add two numbers. Copilot immediately suggests the full function. This example demonstrates how a basic comment like function to add two numbers can prompt Copilot to generate a complete functional piece of JavaScript code. Here's a slightly more complicated example. Suppose that I want to write a function that calculates the factorial of a number. I'll start by typing a comment that describes what I want. Function to calculate the factorial of a number. As I start typing, notice how Copilot instantly suggests a full implementation of the factorial function based on the comment. Here's the code found in the output. Copilot just generated a recursive factorial function for us. This is a powerful feature. By providing clear comments or partial code, you can let Copilot handle repetitive or complex implementations. Now, let's say you have some existing code and want to enhance it. Copilot can suggest improvements based on best practices and performance optimizations. For instance, here we have an array of numbers, 34, 7, 23, 32, 5, 62, that needs sorting. I would type let numbers equal and put the numbers in a bracket, followed by semicolon, numbers, period, sort, open parens, close parens, semicolon. Here is the output. Copilot suggests a more efficient and accurate solution by adding a comparison function, ensuring that the array is sorted numerically. You can also guide Copilot by providing more specific comments or partial code to tailor its suggestions to your needs. Let's explore another example. When writing JavaScript, efficiency and readability are key. Let's create a function that filters out even numbers from an array and returns only the odd numbers. Watch how Copilot helps. Type function to filter odd numbers from an array. Again, Copilot generates the correct and efficient code almost instantly. Notice that it uses the filter method, which is a cleaner and more concise approach compared to writing manual loops. While Copilot is an incredible tool, it's important to follow best practices when writing JavaScript. Let's review a few key tips. Always review and understand the code that Copilot generates. Blindly accepting suggestions without understanding them can lead to bugs or inefficiencies. Copilot responds well to clear, descriptive comments. This helps the AI understand your intentions and ensures that the generated code aligns with your needs. Maintain readability in your code. Even though Copilot can write complex code for you, simpler code is often easier to maintain in the long run. Microsoft Copilot is a game changer when it comes to writing JavaScript. By leveraging AI to handle repetitive tasks, generate code from comments, and suggest improvements, you can focus more on building features and solving complex problems. Remember to always review the code, comment generously, and follow best practices for maintainable JavaScript. Thanks for watching and happy coding! When you bring your website to life with interactive features like buttons that respond when clicked, or content that changes dynamically without reloading the page, you enhance your visitors' engagement and experience. In this video, we will implement interactivity using JavaScript and Microsoft Copilot. We'll focus on how Copilot can assist you by generating event handlers, manipulating the document object model, or DOM, and even making asynchronous requests using AJAX. Let's get started. The first thing we need is a code editor. If you don't already have one installed, I recommend using Visual Studio Code, or VS Code. It's free and works perfectly with Microsoft Copilot. Once you have VS Code or another integrated development environment, or IDE, installed, make sure the Copilot extension is set up and ready to use. If you don't already have Copilot integrated with your IDE, click on the icon in the left sidebar to access the extensions marketplace. In the search bar, type GitHub Copilot and press Enter. The GitHub Copilot extension should be the first result. Now click Install to add the GitHub Copilot extension to your VS Code. You'll also need to sign in with your GitHub account. This is necessary for Copilot to function properly. Now, let's create a new HTML file and link a JavaScript file to it. Create the two new page files in VS Code, index.html and script.js. Then, on the HTML page, begin by typing a prompt to Copilot that says HTML structure into Visual Code to discover what Copilot suggests. You will get an output something like this. Prompt Copilot to add a button element to the HTML page. The result will be similar to this. When clicked, the button will trigger an action, but we haven't defined that action yet. Let's move on to JavaScript for that part. Switch to the script.js file. We want to add interactivity when the button is clicked. To do this, we'll use JavaScript's add event listener method. Let's ask Copilot for some help. In VS Code, type this comment describing the task. Add an event listener to the button to trigger an action when clicked. Just like that, Copilot gives us a working event handler. Now, when we click the button, an alert box will pop up saying, "Button was clicked." You can test this by opening the HTML file in a browser and clicking the button. Let's make the interaction a little more exciting by manipulating the content on the page instead of displaying an alert. We'll change the text of the heading when the button is clicked. We will do this by having Copilot modify the document object model, or DOM. Write another comment in script.js. Change the text of the heading when the button is clicked. Copilot will suggest code for updating the DOM. Thanks to Copilot, we've added a function that updates the heading text dynamically. Now, instead of just displaying an alert, the text on the page changes when you click the button. Interactivity doesn't stop there. JavaScript also allows us to fetch data from a server without reloading the page using AJAX. Let's demonstrate how you can use Microsoft Copilot to write an AJAX request, prompt Copilot in the JS script file. Make an AJAX request to fetch data from a server. Here, Copilot generated a full AJAX request using the Fetch API. When the button is clicked, the script sends a request to a placeholder API, retrieves some data, and updates the heading text with the title of the fetched post. If something goes wrong, the error will be logged in the console. Let's test everything we've done so far. After writing your code in index.html and script.js, you need to open the HTML file in a browser to test it. Here's how. If you're using Visual Studio Code, VS Code, you can right-click on the index.html file and select Open with Live Server or Reveal in Explorer to manually open it with your default browser. Alternatively, navigate to the folder where your project is saved, double-click on the index.html file, and it will open in your browser. And there you have it. In just a few minutes, we've implemented event handlers, manipulated the DOM, and even made AJAX requests, all with the assistance of Microsoft Copilot. This tool can save you time by suggesting code based on your commands and tasks. It's like having a coding assistant right by your side. Whether you're brand new to web development or have some experience and want to improve your workflow, Microsoft Copilot can help you bring a web project to life using HTML, CSS, and JavaScript, all with the help of AI. In this video, we will apply Microsoft Copilot to develop a small web project using HTML, CSS, and JavaScript. Before we begin, let's make sure you have Microsoft Copilot set up in your development environment. You can follow the setup instructions from the Copilot documentation. Once Copilot is up and running in your integrated development environment, also called an IDE, you are ready to start coding. Microsoft Copilot is an AI assistant built into Visual Studio Code that helps generate code based on your prompts. It can assist in writing everything from simple HTML tags to complex JavaScript functions. Today, we'll walk through how to use Copilot to create the structure, design, and functionality of a small web project. First, let's create the structure of your web page. In Visual Studio Code, open a new file and save it as index.html. Now, simply prompt Copilot to generate a basic HTML structure. Here, Copilot has generated the basic structure of our web page. It includes the doc type, HTML, head, and body tags that form the foundation of every web page. This is where our content will live. Now, let's give our project some style. Create a new file called style.css and prompt Copilot to generate some basic CSS styles for the web page. Copilot generated some basic styles that set the font, color, and text alignment for the web page. The body tag now has a background color, while the heading and paragraph have their own unique styles. This is how you can quickly bring your web page to life with Copilot's help. Next, we need to link the CSS file to our HTML. go back to index.html and prompt Copilot to add a link to the CSS file in the head section. Copilot has linked the CSS style sheet, adding a line of code, link rel equals style sheet href styles.css. Next, let's bring our project to life by adding interactivity with JavaScript. You'll want to create a third page within the folder and name it script.js. For this example, we'll create a button that displays an alert when clicked. Type in a prompt like add JavaScript to handle button click in your JavaScript file, and Copilot will generate a function for you. Copilot has created a button element and added an alert for a button click. Now, you'll want to integrate the button into the HTML page. Go back to the index.html page and inside the body tag, add the following button. Button on click equals show alert, click me, close button. This button calls the show alert function generated by Copilot when clicked. Finally, you need to link the JavaScript file to your HTML file so that the browser knows to execute the code. On the index.html page, prompt Copilot to link script.js to this page. Copilot has linked the JavaScript file in the code right before the body tag. Save your files by clicking File, then Save at the top of the page. By following these steps, you will have integrated JavaScript interactivity into your project using Microsoft Copilot, taking your web project from static content to a dynamic, interactive application. Have you ever spent hours trying to find that one bug that's breaking your web project? We've all been there. Debugging can feel like an endless maze, but with AI, you can fix issues faster and with less frustration. In this video, we will test and debug a web project using Microsoft Copilot. To begin, make sure all your HTML, CSS, and JavaScript files are in the same folder and are correctly linked. Here are 3 things to check. First, ensure that your HTML file includes a link tag in the head section that correctly points to your CSS file. Next, make sure the href in the link tag is pointing to the correct path of the CSS file. Finally, make sure your HTML file includes a script tag that points to your JavaScript file, preferably before the closing body tag. In this HTML page, the CSS style sheet is linked and it points to the correct location of the external CSS file. The JavaScript file is linked and the link points to the correct location of the external JavaScript file. Now you'll want to check how the drafts of the files appear online. Navigate to the folder where your HTML file is located using File Explorer in Windows or Finder in Mac and open it. Right-click on the index.html file, then Open With and select your preferred browser to load the draft of the HTML page. Your page will load into the browser. Inspect the page, checking if colors, styles, alignment, content, and interactive features are working. On this page, when I click the Click Me button, nothing happens except a color change. It does not go to a form or another page. Can you guess why that is? One of the most useful features of Copilot is its ability to assist with common testing tasks. Let's say we have an issue with a button not responding when clicked. Instead of manually going through every line of code, we can ask Copilot for help. Go back to your index.html page in your IDE. Here, Copilot responds that we need to add an event listener to the button to redirect to a form, and it suggests code that can be used to do so. We simply go back to the script.js file and paste in the recommended code. Notice that the code also includes a comment to us. Replace form.html with the actual form page URL. When I save my code and go to test the implemented solution, I have the same problem. Now the comment replace form.html with the actual form page URL makes sense. I need to create or link the form. I then either move the missing form into the project folder or create the missing form in the project folder. Here I will create the form.html by prompting Copilot to do it for me. Type, create a basic form that elicits the following contact information from the user: last name, first name, email address, and phone number. Copilot creates the code in seconds. Now we go back to the JavaScript page, add the name of the form, form.html at the location noted, and save all files. Let's reopen or refresh the index.html page in my browser. When I click on the button, it now takes me to a form where I'm asked to input my first name, last name, email address, and phone number, then click Submit. Once Copilot has helped you identify and resolve issues, always test the project thoroughly to ensure everything works as expected. Check for layout issues, console errors, and functionality across different browsers and screen sizes.
Congratulations on completing the Introduction to Web Development course. You've mastered the essentials from HTML to advanced JavaScript and CSS, preparing you to create sophisticated, accessible web solutions. With your new skills in Git and Microsoft Copilot, you can enhance collaboration and streamline your coding process. We began by defining HTML's basic structure and elements and exploring its critical role in web development alongside CSS and JavaScript. We discussed semantic HTML's importance for enhancing web content accessibility and SEO, and guided you through creating basic HTML documents and constructing simple web pages. Next, we delved into the syntax and context of CSS, emphasizing its function in crafting responsive web designs and improving web accessibility. We explored advanced CSS techniques for sophisticated styling and layout, equipping you to design responsive web pages that adapt to any device. Then, we focused on JavaScript, starting with its syntax and constructs and moving to how it interacts with the DOM to create dynamic web experiences. We covered functions and scope, asynchronous programming techniques, and advanced concepts like JSON data management, enriching your interactivity skills. After that, we examined the essentials of version control using Git and GitHub, highlighting how these tools facilitate effective code management and collaboration within development teams. We also discussed integrating Git with development tools to enhance your development workflow. Finally, we explored utilizing Microsoft Copilot to develop web projects with HTML, CSS, and JavaScript. We demonstrated how Copilot can assist in writing and optimizing code and apply these tools to complete a small web development project, showcasing the practical application of your new skills. The expertise you've developed, from mastering HTML to employing tools like Git and Microsoft Copilot, serves as your foundation in this ever-evolving field. Web development continually adapts to emerging technologies. Maintain your curiosity, keep your skills sharp, and be ready to integrate new practices as you advance in your career.